Hello everyone, I am Guru Shravani. In this video, we are going to learn about full stack Java development course from basic scratch level to the advanced level. We will be covering all the important concepts of Java and also we will be doing few practice exercises and MCQ based questions for each topic. By the end of this course, you will be able to build your own real-time Java applications. Before beginning this course, why we need to learn Java? Java is one of the most popular programming language in the world. It has very high demand in the IT industry. Java provides us a strong career and high paying job opportunities. If we see companies like Google, Amazon and Netflix, they highly rely on Java language. Uh, to develop any Android application, Java is most essential language, but we can also develop applications using C, C++ and Python languages. But why specifically Java? Java is more secure, robust and reliable. And it is also has very strong concept in object oriented programming. So let's discuss about the history of Java. Java is a high level language because it uses simple, human readable English like words, which makes it easier to write and understand compared to the low level machine code. Java is object oriented, which means Java organizes everything using objects just like the real world things that have the properties and actions. And it is also platform independent. That means once you write the Java code, you will be able to run it on any Windows system. And coming to the development, it was developed by James Gosling. He is also known as the father of Java. James Gosling worked with a small team of engineers in a company called Sun Microsystems in the early 1991. Their project was started in 1991 and they were trying to build a new type of language that was simple, fast and reliable. And this team that particularly they were developing this Java language is known as Green Team. So the reason main motive behind developing this Java language was not just for computers or web development. Instead, they wanted a language that could run inside small electronic devices such as our daily usage, TV, washing machines, setup boxes, remote controls, etc. To achieve these goals, they need a proper language which is more secure, easy to update, and able to run on different hardware systems. So, Java will perfectly suit to make all these things possible. And when they are building this Java, they decided to name this language as Oak. Why? Because when James Gosling developing this language, he was sitting in his office cabin and there was a tree outside his office window, which is called as Oak. So he decided to name this language as Oak. But when they tried to register this name officially, they get to know that this particular Oak name was already trademarked by some other company. So their team decided to rename it as Java again in 1995. Why the name Java? Because the team liked the name. They drank a lot of Java coffee during this Java language development. This particular coffee is famous from the Indonesia island where the Java is very famous. So they decided to name it as Java because it is very simple and unique and it reflects energy and power just like the programming language they were building. So now let's talk about few important features of Java. As we already discussed, Java is a platform independent. That means once you write your Java code, you can run that particular code on any operating system. It can be Windows, Mac, or Linux, anything using the JVM. And we will see about this JVM in later topics. And Java is object oriented. That means everything in Java is about objects and it is very simple and familiar just like C or C++. And Java is very secure because it has no pointers and it performs bytecode verification. And Java is robust. It handles exception handling and memory management. And it is multi-threaded because it can run multiple tasks at a time, so it makes it a very powerful language. And it is portable because bytecode can run anywhere. As we said, it is able to run on any operating system, and we will see about this bytecode and bytecode verification in later sessions. Coming to the programming language, what exactly is programming language? So programming language is nothing but you are giving instructions to a computer so that it can solve a particular problem. If you see in this image, when human wants to communicate with each other, they need to they will use their own language. It can be English or Hindi, their own native language, so that they can understand what the other person is talking about. But when it comes to computer, it cannot understand the normal human language. It can only understand the zeros and ones. So, there the programming language act as a bridge between humans and computers, where it allows us to write instructions in a structured readable format so that the computer can later convert that particular code into machine code. That means it is converting the code from high level language to the low level language. Here high level language is nothing but the human readable code, and low level language is the computer readable code, which is zeros and ones. Then when we are writing a program, it follows some specific rules, and it will define some meanings, and it will follow some steps or instructions to execute that particular code. If we take for example, if we take a real time situation where you are writing, think of writing code is just like a sending WhatsApp message to your friend with exact instructions. If you type bring milk on your way back home, so your friend will read that message and he perform that particular task. Likewise, when you write code like print hello world, the computer does exactly the same. So in overall, programming language is nothing but it will follow some instructions so that the computer will understand that particular concept and it will execute the code. What is syntax? So syntax is just a set of rules that will define how code should be written. It will provide the structure and grammar of a programming language. It ensures that statements are written in such a way that computer can understand and execute correctly. So, in simple terms, syntax is a correct way of writing code, just like the grammar in English. So, if we see these two images, in the first image, uh, before the utensils and things, objects were organized, no, they were not organized properly. So, later, when they organized in row wise according to the utensil type, later if we want to fetch the particular object, uh, we can easily get that particular item because everything is organized properly. Same like if we see the second example. So as we said, syntax is just like a grammar in English. So when two uh, humans are communicating with each other, if your statement is not proper, that means if your statement has some grammatical mistakes. So if we see here, every girl must bring their own lunch. So girl itself here is a single person. So there is no point of using there. So the same way, in correct statement we will use every girl must bring her own lunch. So if we provide the proper words or grammar, then only the other person able to understand. Just like syntax is the crucial step in any programming language. If we follow particular steps, then the program, when the computer is executing, it will understand whether it is a correct statement or whether it is a correct block, so that it will provide the results without any errors. Now what exactly is an algorithm? So, algorithm is a step by step procedure, or it is a clear set of instructions which we will be using to solve a particular problem or to perform a task. So, algorithm act as the logic behind programs. So, for example, if a program is implemented, uh, every program is implemented using a particular algorithm. So, every algorithm should be precise, ordered, finite, and effective. That means there should be no confusion in the code. It should be very correct, and it should follow the particular order to execute the code, and it should also know where to end after few statements, and it should be effective. That means every statement that you wrote in the program should be executable. If we see this example, we know that the particular steps we will follow to prepare the Maggie. So first, when you decide to prepare the Maggie, you will start taking the lid and boiling the water. In the first step, you will boil it with water, and then you will add the all ingredients like Maggie masala, carrot, beans, everything whatever you require. So in the second step, you will add all the ingredients. Then in the third step, you will let it stir for some time and you will let it boil. Later, in the fourth step, you will add the noodles and you will let it boil for some more time so that it will mix and your Maggi will be properly mixed with all the ingredients. And in the fifth step, finally, when it is finished, you will serve it into the bowl. So, here, what I am trying to say, algorithm is nothing but following the clear, precise steps to get a proper output. So, as we follow all these steps to get the Maggie perfectly, we know what and all steps you need to follow. Then only it will give a clear output. So, the same way, when you are writing the code, you need to follow when you are executing the code, you need to follow particular steps so that it will give us the correct output. Then, as I said earlier, what exactly is bytecode? So, imagine if you are writing a Java program. You write it in normal English like code, which is nothing but the human readable code that is called as source code. That means the programmer who is writing the code, that particular code is known as source code. So, but as we know that computer cannot understand this particular source code directly. It will only understand zeros and ones. So, Java here uses a middle step. That means once you compile your program, Java will convert your human readable code, that means the source code, into a special format that is called as bytecode. That means once your code is converted into bytecode, you can run it on any operating system. So let's see it in this image. Here, the source code is nothing but the programmer who is writing the Java program, and you are going to in every program in the Java is saved with .java file extension. That means whatever your class name or file name, you are going to save it with .java in the end. So once you write the code and saved it, the compiler is going to convert this particular source code into the bytecode format. That means, as we already discussed, this is something written in the English language, like English like words that a human can understand what the programmer wrote. But computer will not understand all those words. It will only understand the zeros and ones. So the compiler Java will compile your particular source code into the bytecode, and here bytecode is nothing but it's just zeros and ones. It is a mixture of all characters. That means it can have the numbers, it can have alphabets, or it can have special characters. So it is all about the mixture of characters which even the human cannot understand. Only the computer will understand what exactly the bytecode is. And when you compile it, you the automatically the dot class file is getting created. Your source file will create automatically the dot class file. Then, once you convert, here in between, the JVM will uh, execute this particular bytecode, and when you executed it, it should be able to run on all the operating system irrespective of any OS. It should be run on Windows, Mac, Linux. That means you no need to write again the Java program according to that particular operating system, because here JVM will make sure that that particular code should be run on in any operating system. I hope you understood what is mean by bytecode. Now let's move on to object oriented programming. This is one of the important topic in Java. As we said, Java has very strong OOPS concept. That means, so what exactly is object oriented programming? So it is a approach where everything is organized around objects. That means in our daily life situations or in our daily life usage, everything have the data and action. That here data is nothing but attributes and actions are nothing but methods. That means instead of writing code as a long list of instructions, oops will help you to structure your program like real life things and their behavior. For example, uh, we know that every object has some set of properties and some set of behaviors. That means, let's see the example here. If we take the car as an example, let's assume that here car is a class. That means we know that car has many different types of brands or companies. One is Maruti, Audi, BMW. Assume all these three as objects. That means in a particular concept called car, which is nothing but class, we have different objects, and we can see each object has a different set of properties and actions. That means it has different color. You can see it is in red and it is in black, it is in green, and it has different functionalities like the speed of this particular car may be different, and Audi will give some particular speed and mileage will be different, and it has some different functionalities. Now coming back here, as we said, each object has some set of properties and behaviors. That means color, brand, name, price of each car, everything will be different. All these will come under properties. Now, when we talk about behaviors, so for every car or object, there will be some particular methods like start, stop, drive, call, deposit, brakes. All these will come under methods. And basically, OOPS is mainly built on four main core principles, which are nothing but encapsulation, inheritance, polymorphism, and abstraction. So, we will look into these topics in more detail in the upcoming topics, and note that these topics are very important in the entire Java course. That means you have the high scope of getting questions from these even in interview. It is one of the important concept. Next, as we got to know what exact history of Java and why we need to learn Java and few of the topics like programming language, algorithm, now we need to start working on Java, and we need to install and set up the environment. For that, before doing the Java programs, you need the particular kit to run the Java programs. So you can, irrespective of editor or any platform, we definitely need the Java development kit before running any Java program. So you can download this JDK from the Oracle website, and I have given the clear steps how to do that. Once you download it, run the installer and set up the environment variables, and then verify the installation process. Once you downloaded it, you can just check in the command prompt like whether the it is downloaded or installed with the command like Java version or Java C version. So if it installed correctly, you will be seeing the Java version information, and if it shows the version, then your JDK is installed successfully. Here I have also given the image of where to download, and you can go to this particular Oracle website. There you can go to Java downloads, and here you need to go to your web windows. Like, if you are based on your operating system, if it is Mac, you can go to Mac. If it is Linux, you can go into Linux. And if it is about Windows, so you can download this particular x64 installer. So download it and it will get installed. And as I said, follow these particular steps and verify whether it is installed or not. Then, after downloading the JDK, first we are going to we can run the Java programs either on the text editor or on the particular platform, IDE platform. So before, we will be checking how we can execute codes on text editor. Here I am going to use the Notepad++ text editor. So even this you can download from. You can just search download Notepad++ in the Google, and you can download it. And here I have given the link. You can just go to that link and this page will get open, and just download the top uh, top statement which it is showing. Download that particular version, and when you click on it, you will navigate to this particular page and just click the download button. And even here, if based on your version, if it is Windows and if it is Linux or whatever, select that particular, go to that particular operating system, and then just click download. It will get installed. Then here is our first Java program, and I am going to explain you about the basic Hello World Java program on first on text editor, that is nothing but our Notepad++. So let's go and check. So when after you are installed the text editor Notepad++ successfully, your screen will be like this. And when you open it, you can just go to file and open the new document, and then just start typing. Public class main and public static void main string args, open the curly braces, and system.out.println, just type hello world. Then just close the curly braces correctly. Then while you are going to save it, you have to save the and one more thing, when you are going to save, you have to save it with the class name. So here our class name is main, so you need to save the file with this particular class name, that is nothing but main.java. And even here, when you are saving the file, you need either you need to create the separate Java folder, or you can just save in the desktop. But the extension should be .java. And here you need to select the source file, that is Java source file, and just save it. Now, once you write the code, you need to execute it. For that, you need to go to the command prompt and just navigate to your particular folder. Here, I need to navigate to OneDrive first, then desktop and Java, because I have saved this particular course in the Java folder under the desktop folder. So to compile, first you need to compile the program. For that, you need to use the command javac and the class name main.java. Then it will get compiled, and if it prompt to the next cursor directly, then your code is compiled without any errors. And then you need to run the particular program with Java and class name. Then it will print you the hello world as output. So this is our basic hello world program, and we will see about this particular format, what exactly is public, static, void, about all these terms in the next slides. So as of now, I just showed you how to run the program on text editor. And then now we'll see how this execution works. First, there will be a Java developer. That means we will be writing the particular program. And as I said, we need to save any Java program with the .java file extension. And once you write the code, you have to save it with this particular extension. And then the Java will compile your program. For that, as I said, you need to use the command javac with your class name and .java. Once the Java compiles your file, it will convert your code into bytecode. That means it will be in a mixture of characters with all zeros, alphanumeric, and special characters. Then it will automatically create the .class file once your uh, source code is executed. Source code is compiled. Then this particular bytecode will run on the JVM. So to run your bytecode on JVM, before that, as I said, to run any Java program, you need to install the JDK. Without JDK, the JVM cannot run the program. And when the bytecode is running on the JVM, JVM will start execution from the main method in your file. That means, as we have seen, that we have a line that's stating public static void main, which means if there is no main in your code, that means if there is no main, this particular method, JVM will not understand from where the code should be executed. If there is no main, your code will not executed. So in Java program, main method is mandatory. So your code should have the main method. Then the JVM will start execution from that particular main method. And when it is executed, it will pass the output to the developer. So this is how the Java works. Next, as of now, we just seen how the code will be executed on text editor. And as I said, we need to run going to work our Java programs on the particular platform in IDE. That is nothing but here I am going to use the IntelliJ IDEA. So you can download it from this particular website and follow all these steps same as you did for the ID that JDK tool. So here I have given images same like you need to navigate to that particular browser and select your OS and start downloading it. Then once you download it, just check whether the IntelliJ is installed or not. Now, after successfully installation, we are going to run our Hello World program on IDE. That means on Intel IJ IDEA platform. So let's navigate over. So when you install it, uh, before you will be you need to create a particular project folder, and there here I have used the I have named my folder as Java Full Stack YouTube. There I have created your main.java will be automatically displayed when you open the new project. So here I have saved it with main because my class name is main. So you have to save the Java file with particular class name and with the extension .java. And we know as the code is already written, and once you write the code, you can just compile it with the current file. And when you execute this, you will get the hello world as output in the terminal. So this is how you are going to execute the Java programs on IDE platform. Now, let us see what exactly this program is talking about. So these are the components of a Java program. First, there will be the class name. There will be the class line where public class my app. Public is nothing but it should be accessible to everyone. And class is it is a class name, and my app here is the class name. But in our code we have taken hello world. Here my app is the class name. And remember, the class name should always start with the capital letter. And uh, even there should not be any space. And if you are going to use multiple words, you need to start the first letter of the particular word with capital. And these are the open curly braces of this particular class block. And this is our main block, public static void main. That means public is same, it should be accessible to everyone. And static, we will see about static in later sessions. And what is void? That means void will not have any return type. It will not give any return value. So whenever we don't want any return value, we can use void in our block. Then this is the name of this method is main. And string args is nothing but arguments to the method. That means this method must be given in a array of strings, and the array will be called as args. And this block will open with our curly braces, and this is our print statement. System.out.println is nothing but we are using this particular method to print the output, and it is a standard format to print the output. And whatever we are going to give inside these brackets under this double quotes is our string, that which is going to display on our terminal, or which is going to provide as a output for us. And semicolon, every statement in Java must end with a semicolon. Whatever you are going to write under the main block, or whatever you are going to provide inside the print statement, you are going to end it with the semicolon. And you need to close the curly braces accordingly to the class and main block. These are the components of Java program. Hope you understood what is the structure of the Java, how we are going to write programs, and what and all is mandatorily required to write the program. And these are the few practice exercises that I gave you. Uh, then these are the few MCQ questions. Uh, about these practice exercises and MCQs, we can discuss in the later sessions. So now let's discuss about the tokens. So what exactly is token? So token is the smallest piece of code that Java understands. That means when you write a Java program, Java will break your code into little parts, words, names, symbols, numbers, everything separately. So they will treat each part as a token. For example, think of token as the smallest meaningful word or a symbol in Java program. If you see in English, like basically a sentence is made of words. For every word, there will be having particular meaning. Same like in Java, a program is made of tokens. Tokens have meaning to Java. So tokens are like the individual building blocks of the Java code. So there are these are the main categories in Java. They are keywords, identifiers, literals, operators, separators. And separators, sometimes it is also called as punctuation. So let's discuss in detail about these things. So the first one is keyword. So keywords are the reserved words that have a special meaning in Java language. So just like a grammar, so you cannot use these keywords as a name for a variable or classes, methods or identifiers. That means there will be few built-in keywords in Java which we will be used only for a particular reason. You cannot use them as a name for variables. Just like for example, here we have taken an example that int class equal to 10. Here class is the variable name, but we have used the keyword. So you cannot use class as a keyword as a variable name. So that will become the invalid reason. Then these are the few keywords that we already have in Java. So we almost have 32 keywords which have a very special meaning for each keyword. So for example, if we take class, class is nothing but when we declare a class, and public, private and protect, these are all the access modifiers. And we also have the static, which means it will indicate the class level member. And we have void, that means it will not return any value. And if else, these are the conditions. And for while loops, so try, catch, finally, throw, all these are exception handling. So we will be discussing, or we will be using these particular keywords somewhere in the code, then when that we will discuss in later. Now the second token is identifier. That means identifier is nothing but the name you are giving to the class, methods, variables, packages, and labels. And there are few rules for the identifiers. So you must create an identifier that which will start with the alphabet. It can be capital A to Z or the lowercase a to z. Or you can start the identifier name with currency character, that is dollar, or you can use the underscore. And after the first character, you can contain letters or digits or even underscore or dollar symbol. But the identifier cannot be a Java keyword. And also Java is case sensitive. That means you have to check whether, for example, if you see the age, and we have three ages, each of them wrote differently. This is completely the smaller case age, and here we only used the alphabet A as capital and we wrote everything in uppercase. So for these three words, there will be a different meaning. So all these three are different identifiers. And when you are creating a identifier, there should not be any space. For suppose if you are creating class name, you have to write either concatenating them, or you cannot write with the space like class and name. This is invalid identifier. For example, if I have given few examples here. Int age, this is valid because you are declaring the identifier and age is not a keyword. And string first name, this is also valid because we are not giving the space. Instead of that, we are using the underscore. And as we said, every identifier should start with the letter either uppercase A to Z or lowercase a to z, or even underscore or dollar. And here uh, this is also valid because we are using dollar sign instead of the space. And this is invalid. Here int age, and here int second value. Int is a data type that we will be seeing in the next slides. And mm, this identifier is invalid because, as we said, it should not start with the digit. So in every identifier should start either with the character or the underscore or uh, dollar symbol. It should not start with the number. So this particular example is invalid. Now the third token is literals. Literal is a fixed value that appears directly in the source code: numbers, text strings, characters, booleans, or null. And in when talking about literals, we have different type of literals: integer literal, decimal literal, character literals, string literal, and boolean literals. Let's discuss about them. Integer literal is nothing but a whole number. That means the integer values, it can be either positive or negative. You can use integer literals whenever you feel that you do not need any decimal value. For example, when you are declaring the age or count or number of students, here we will just use the number or the count. We don't need any decimal value. So in this particular case, you can go with the integer literal. Then if you see the example here, we have declared the variable name age, and you have given the integer literal 25. Here 25 and 80 are the integer literals. Now Java allows numbers in many formats. As I said, This one we already discussed, that is the integer literal, and we also have decimal numbers, hexadecimal numbers, binary numbers, and we will use underscore in between numbers just for our readability purpose, easy to understand. And we also have the long numbers. So whenever we are using the hexadecimal number, always you have to use OX as the prefix, and whenever you are writing binary numbers, you have to use prefix as OB, because binary numbers only understand zeros and ones. And we are using underscore to make the long numbers easier to read. And the long numbers are if a number doesn't fit in the integer value. So we will add L at the end. We can add either capital L or lower L, but we will be preferring the capital L because try to avoid the misunderstanding between the small l and the number 1. So this is about literals, integer literal. Then we have another literal as decimal. These are the numbers with decimals, like the decimal values. That means we will be adding extension numbers after the point. So use them for things like prices, height, weight, distance. That means whenever you are going to calculate price or height, weight, distance, we all know that there will be something extension after the point. There will be numbers after the point. So in that case, we will go with decimal literals. And here I have given examples that pi value, we all know that it is 3.14159, and the price, when you are going with price, we can use the 9.99. And f is nothing but the float. Whenever we are using the float data type, we have to use the f at the end of the value, and everything we have to end with semicolon. Here, double means whenever we use double, it will automatically take decimal type as default. And whenever you are using float, as I said, you must add f at the end. It can be either small f or the uppercase f. So, and you can also use the scientific notation, because whenever we are having the more number of zeros, in that case, you can go with letter E power 3. That means we are using the 1000, we have 3 zeros. So, in that case, we can use the scientific notation E. And the another literal is character literals. So, a character is a single letter or a number or a symbol written in the single quote. That means it a character means we will be writing only one letter under the single quote. It can be either alphabet, or it can be number, or it can be any special character. So if we see the example, we have taken a variable name grade, and we wrote cap a in single quote, and here we declared digit 5 as the character. We also have special characters which are known as escape characters. So escape characters, nothing but we have some special characters, like we will be using backslash for them. So here backslash n is nothing but the new line. So whenever you use this character, your line will the output will go to the next line. Or the whenever you are giving the print statement, when you need the new line, you can use the backslash n. Or whenever you need the tab space, you can go with slash t. And when you want the backslash, the same backslash to print in your statement, you can use the double backslash. And when you want the double quotes to print in between your statement, you can go with slash double quote. So these are some special characters which are known as escape characters. So the next literal is the string literal. So string is a group of characters enclosed in double quotes. That means whatever we are going to write as a word or as a statement, we will be enclosing it with the double quotes. For example, here even the one word I wrote in double quotes, and this is a statement, Java is fun. So even the statement I enclosed with double quotes. The difference between the string and character, in character we will be using the single quote, and we will be writing only one character inside it. And when it comes to string, we will write the particular word or statement under the double quotes. So here I have given example name, I have declared Shravani under the double quotes, and the message, even the statement I have declared under double quotes. So when we will use strings, whenever we need sentences or words or text, then we will go with string literal. Then the next literal is the Boolean literal. A Boolean literal can only be either true or false. That means these are used in conditions, decisions, or logical checks. Whenever in the code you want to check whether it is true or false, whether this condition is true or false, whether your decision is true or false, and you are checking whether your logic is correct or not. In that case, we will use the Boolean literal. So here I have given two examples. Is Java fun? I have declared as true, and is light on? I have given false. So whenever you are using these variable name inside the code and you want to check whether the logic is correct or not, you can use the data type Boolean. And the next literal is operators. So operators are special symbols or keywords that perform operation on one or more operands. Operands is nothing but the uh, let, uh, letters, alphabets, whichever we are, not alphabets, the characters which we are going to do. For example, here I have taken A plus B. Here plus is the operator and operands are nothing but the AB. Even here X and Y are the operands. So whenever you are using any operator that is doing some operation between two operands or even more operands. So few of the operators are addition, subtraction, multiplication, division, modulus, greater than, less than, equal to, and operator or operator and double equal to checking. So here the difference between division and modulus. So division is nothing but it will give us the quotient value and modulus will give us the remainder. And the difference between these two are whenever we are using double equal to sign, it means you are checking whether the condition is true or not. And whenever you are using the single equal to sign, it is nothing but you are going to assign the value which is on right to the left side variable. For example, as we have seen in the previous examples, now I gave age equal to 25. That means the value which is on the right side of the equal to sign is going to store under the variable age which is on left side. These are about operators, and we'll discuss each in detail about each operators. There are so many operators like arithmetic, relation, bitwise. So we will see in later sessions. And next literally separator. Separator is nothing but the symbols that you use to separate the code parts. For example, whenever you are writing code, we will be using the curly braces just to define this is a particular block, and we will be using parentheses whenever you are declaring methods, and we will be using square brackets whenever you are creating arrays, and we will be using semicolon for end of the any end of every statement, and we will be using commas to separate the parameters inside the method, and we will be using dot operator. Dot operator is used to access the method of an object or the class. So this is one of the program that I have taken, including all the tokens. If we see here, uh, public, as we discussed in the earlier class, public is nothing but accessible to everyone, and class is the class name, and demo is the name of the class. And as I said, every class name should start with the capital letter. First letter in a word should be the capital. And the opening curly braces, this is the separator token, and we have used the square brackets, this is the method separator, and we have used the array brackets, and we have declared the integer literal, and then we have used the double literal, then we have used the string literal, and we have also used the boolean literal, and it is going to print the name. Whenever we use call the name, here it is going to access the name which it is stored with Shravani, and has amount. I have stored the amount with 10. So equal to operator will store the value to the amount. So when you execute this, it will give print that name Shravani has amount 10. So let's see by executing this. So this is the code as I have explained already. So int amount equal to 10. It can come under keyword, identifier, operator, literal, separator. And double pi is the literal with decimal, and string name is the literal with string literal, and boolean is the Boolean literal. And when we execute this, we will get the output. As I said, Shravani has amount 10. So hope you understood the Java tokens. Now the next topic is comments. So how we will declare comments in Java. So basically comments are the notes that we write for humans, not for the computer. It is just for the human who is trying to read the code. Why we need comments? This will help you to explain your code. So there are mainly three types of comments in Java: single line comment, multi-line comment, documentation comment. So single line comment, whenever you are declaring a single line comment, you can go with using the double uh, backslash. And then uh, whenever you want to declare the multi-line comment, when you want to add multiple lines of comments, then you have to declare it with backslash star and star with backslash. Then documentation comment, when you want to comment the entire document, you have to use the two stars after the slash and end with single star and slash. uh, this is the code. So if you see here, uh, the about top part is the documentation comment. So I have to document the entire code. So I have commented with the multi-line documentation comments. And wherever I want to declare the single comment, I have taken the two backslashes. So it just means that I am going to comment just this particular line. And when you want to declare multiple lines of comments, you can use the slash star and star slash. So let's try to understand this code. Like here we have declared the number as 10. So the particular variable name number is trying to store the value 10 into it. So now again I am trying to calculate one operation, that is the particular number which we have stored, it has to multiply with the value 2. And when we multiply 10 with 2, it will give us the 20. And this particular 20 value we are trying to store into this result variable. And when you print result, it will fetch the value 20 as output. And whenever you want to print the statement, you have to you want to access the particular variable result, you have to use the plus operator. That means here a plus is nothing but the concatenation. So whatever you wrote inside the double quotes, it will just print as it is. But whatever you are writing after the plus sign, this is nothing but it is going to fetch this particular result what it stored inside the memory. So let's see by executing this. So comments. So as I said, this is the single line comment. It explains either one line or a short part of the code. And this is the multi-line comment. It is used when you want to explain something in detail over multiple lines. And when we execute this, we will get the output as result 20. So our next topic is variables. So what exactly is variables? So in Java, a variable is nothing but a named memory location that we will use to store a value. Till now, I have shown you whatever you are going to provide after the assignment operator, that is going to store in a variable. So variable is nothing but that is storing some value. So it acts as a reference to a specific position in memory where data of a particular data type is kept, and its value can change during program execution. And variable is not fixed. If you are declaring in one particular place variable a equal to 4, and you can change it later in your program. And why do we need variables? So variables let programs remember information while they run. For example, username, number of items in a cart, or current score in a game. So without variables, a program cannot store or use data dynamically. For example, if we see this particular image, this is one particular box, or treat this as a container. So for this container, I have declared a name as variable. So in this variable, when you open this box, there will be having some value, and this is the particular value presented inside this variable. That means this particular name variable has stored the value. So this value is stored into this variable. You can use these variables to store or read and change the value in that container. And if we see this image, we have four different types of variables. One is my int, and one is my real, and my char, and my string. So each of this particular variable is storing different values. Integer is storing the value 4, and real is nothing but decimal. It is storing the decimal value, and character, it is storing the character A. Actually, it should be in single quote, not double quote. And the string should be in, stored the string as hello. So this is the example we have seen here, and this is the particular variable age. Age is trying to store the value 25, which is integer. So we have used the data type int. And whenever we are creating the variable, we will be following some specific set of rules. First thing, as we have seen in identifiers, whenever we are creating identifiers, we have followed some rules. The same wise, we are going to follow some rules for variable. Whenever you are trying to create variable, you have to start it with either with a letter or underscore or dollar, special symbol. You cannot start a variable name with a number. After the first character, you can use either letters, numbers, or special symbols, that too only the underscore and dollar. Other than these two special symbols, you cannot use any other special character inside the variable name. That means you cannot use the uh, at the date symbol, or the percentage, or any type of operators signs. And there should not be any space between the variable name. And variable name is case sensitive. You have to be careful whenever you are declaring variable. If you declared a variable as age, and whenever you want to fetch this particular age and you are using this age with capital A, it is invalid. So Java is case sensitive, and you cannot use the keywords as variable name. And whenever you are trying to create a variable, try to name it as meaningful, because when you want to reopen the code later, you want to understand what this particular code is talking about. If you are calculating someone's age, to use that age, just use the meaningful name age. Don't try to use just the alphabets A, B, C, or X, Y, Z, where most of the people will use. Just give them meaningful names to understand better. And uh, it should start with local case, and the variable name should start with lowercase. And you can use the camel case style. There are still so many cases, but the most preferred style is the camel case style, that we will be discuss in the upcoming slides. And most importantly, the length of the variable, it can be any size, but uh, try to keep the length should be readable. Don't just give the huge number of length of size. Just try to make it short for better readable. These are the few rules that you have to follow when you are creating a variable name. And here, the another important topic is declaration versus initialization versus assignment. That means whenever you are declaring a variable, how you are going to declare it, and whenever you are initializing the variable, and when you are assigning some value to the variable. So declaration is nothing but you want a variable and its type. So whenever you are declaring variable, you have to create a variable, and you have to mention the type of that particular variable which you are going to store the value. So here I have declared the variable name as age, and I have used the data type as integer, because I just want to store the integer value to this particular age variable. If you are declaring int and you are going to store some decimal value, it will throw the error. So whatever you have specified the data type, you have to just store that particular value. And this is declaring, this is how we will declare the variable. And next, initialization means giving the variable its first value. That means here initialization, when we will do, whenever you are going to give the value initially during your starting stage of the code, I am going to declare a equal to 10. So this is my initialization of variable. Later you can change this value, but whenever you are going to first initialize the value, we will declare in this way. And the assignment variable is, you are going to change the particular value or you are going to set the value. As I said, you have declared a variable and you are going to assign one particular value to this. Then this is how you will assign the value to the variable. Earlier I have given a equal to 10, then I am going to change it 30. So the value is changed here. This is how you will assign the values. And also, till now we have seen the declaration part separately and initialization part separately. You can also do both declaration and initialization together. That is where you will be declaring the value, declaring the variable and assigning the value to that particular variable. At the same time, you are going to declare the data type of that particular variable. Then we have mainly two different types of variables. One is the primitive variable and the other one is non-primitive uh, non-primitive reference variables. So what exactly is primitive variables? Primitive variable, simply it will store the values, actual values directly. So in Java, we have eight primitive types. That means byte, short, int, long, float, double, char, boolean. So byte, short, int, long will come under the whole numbers, and decimals we can go with float and double, and character we will be using only single character. Boolean, either we will be using true or false. So in if you see the example here, I have declared you I have used the int data type and I have declared the value 10. And to declare the decimal value, I have used the data type double. And to declare the character, I have used the char variable data type. And to declare true or false, I have used the boolean data type. So these are the eight primitive data types which will store the actual value. And these are the reference variables. That means it will store reference to the objects. These do not store the actual object value. They will just store a reference address pointing to an object in the memory. The object lives separately. So here, if you see the examples, I have declared the string name as Shravani and I have declared array with the new int array size 5. And whenever I am going to create an object, I am going to declare the class of that object of that particular class. Here if you see this particular variable name, array and Java object, these are not the primitive variables, these are reference variables, because they will point to the object, not the actual value. And this is one of the important topic, variable scope and lifetime. So here we have different types of variables. Like one is the local variable. Local variable is something that we are going to declare inside a method or a particular block. So before that, what exactly mean by scope and lifetime? Scope is nothing but where the variable can be used. That means which part of the code can see it. And lifetime is how long the variable exists in memory. So whenever we are declaring the variable as local, you have declared it inside a method or block. That means here the scope is this particular variable can be visible only within that method or block, and its lifetime is until that method or block executes. Until up to that time, this variable lifetime will exist. And Here I have taken the example. This is my particular method greet. So I have declared a variable string message equal to hello. This is the local variable because I have declared inside the block. And when I am trying to print this message, it will execute because you are trying to execute it under this particular block only. And here I have given the comment message is not available here. That means if you try to execute this particular statement after the block, so it will throw an error because you cannot access the local variable outside of that method or the block. It is only valid within that particular block. This is about local variable. And instance variable. Instance variable is you are declaring a variable inside a class but outside methods. You are declaring the variable inside a particular class, and you can also access it outside the methods. So each object will have its own copy. So the scope here is throughout the class. That means up to the particular class whichever you are going to use. Within this particular class, wherever your variable is, it can be accessed by any method. It can be accessed by the object. Each of them will have the one particular copy, and its lifetime will be as long as the object exists. So if we see the variable here, here you are not using the method. Here you are directly declaring the class. You are going to declare the variable inside the class. So the string name, this is the instance variable. And whenever you are going to access it with the particular object, you are going to get this data. And the next variable is class variables. Class variables are declared with static inside a class. That means it is shared by all the objects of the class, only one copy. The scope of this particular class variable will be, it will be throughout the class and can be accessed via class name dot variable. And its lifetime is as long as the class is loaded, usually the entire program run. Throughout the program, you can access this particular variable. And if we see the example, here I have declared this particular class counter, and I have given the declared the static variable class variable. That is, I have given the value 0 to the count variable. And the next topic is default values versus initialization. So we have seen that local variables, instance or class variables. So local variables, for the local variables, Java do not give the default values. That means you must initialize them before use. Otherwise, the compiler will throw an error. Whenever you are going to declare the local variable, you have to assign the value. For example, you have declared the variable int age, and you have print giving the print statement SOUT, and you are trying to print this particular age value. When you execute this program, this particular line will throw the error because you haven't initialized the value to this particular variable. So that means if you are going to use the local variable, you have to assign the value to the variable. Then only you can execute the statement. Otherwise, it will throw an error. So Java will, by default, it will not provide any value to the local variables. But coming to the instance or class variables, Java does give default values. Even though if you don't give any value to this that particular variable, if it is of numeric type, integer or decimal or float, it is going to provide either 0 or the 0 0.0 decimal value. If it is a boolean data type, it will provide either true or false based on the condition. If it is char, it will just give the null char. And if it is about reference, it will give the null. So whenever you are declaring the variables n and s here, you haven't initialized any values, but still when you try to execute, it will give the default values because these are the instance or class variables. So the next topic is naming conventions. So naming conventions, if as I said earlier, we have uh, five different types of naming conventions. The first one is the camel case. That means first word starts with small and every next word starts with the capital letter. As you see in the name itself, the camel case, the first word will start with the lower case and the next coming word, the first letter of that particular word will be capital letter. So camel case mostly we will be used when you are trying to declare the variables or methods in Java. So as we see the shape of the camel, it will be uh, giving the curve at top. So whenever you are going to write the next word, you have to declare it with the capital letter. And the next case is Pascal case. That means every word should start with a capital. That means whatever word you are trying to use, if you see here, upper camel case. So each word first letter is declared as capital. So this is nothing but the Pascal case, and we will be using Pascal case when you are trying to declare the class names. As we discussed, class name should be have the first letter as capital. Then the next case is snake case. So snake case is all letters in the snake should be small. There should not be any capital letter. Every letter should be in lowercase. And if you are trying to use multiple words, you have to separate those words by the underscore symbol. And the next case is screaming snake case. That means in screaming snake case, all the letters are written in the uppercase, and you can separate the words with using underscore sign. And the next case is kebab case. Here we are using all letters in lowercase, and whenever you are trying to separate the words, you are going to separate here it with hyphen. When you see, if you see this image, whenever we are getting that kebab, you can see there will be a stick gap between each cup. Treat them as hyphen. That means whenever you are going to declare a variable name, you have to use that particular name in lowercase and separate them with hyphen. So these are the few cases which you can use according to your code, and and this is how it looks like. As I said, camel case, it will look as the first word will start with lowercase and the next word will start with the capital letter, and it is mostly used in variables and methods. And the Pascal case, here each word is capitalized with the first letter. This is mostly used in the classes, as we start the first letter as capital in classes. And the snake case, each word is written in the lower case and separated by the underscore symbol. This case we will use very rarely in Java. And the screaming snake case, every word we will be writing in the uppercase, and you will be separating each word with underscore. This particular case we are going to use mainly in constants. And the kebab case, we are going to write every word in lower case, and we are trying to separate each word with the hyphen. Even this we are going to use under the class names. And our next topic is data types. So what exactly is data type? A data type tells Java what kind of value you want to store in a variable and how much space that particular value needs. For example, if you see this particular image, you can see that there are four different types of containers. So each container have different size. That means we are choosing the containers according to the value or the item that we are going to store. So different items are stored in different containers according to their amount of quantity that we are going to store in that particular container. The same way, when you are trying to store some values in Java, we will be use particular suitable data type for that value. If we are going to use very integer number, we are going to use the int data type. The same wise, based on the value that we are going to choose, we are selecting our data type accordingly. Uh, think of a variable. Think if a variable is a box, The data type says what size and shape of items go inside that particular box. Basically, there are two main categories: primitive data types and non primitive. It is also called as reference types. So, primitive data types, as we already seen, there are 8 primitive data types, and non primitive data types are object, arrays, string, custom classes. So, this is how the data types are divided in Java. The first set is the primitive data types, and the second one is non primitive data types. When talking about primitive data types, again it was categorized into two categories. One is the Boolean type, and the other one is numeric type. In numeric type, again we are categorized it into the character value and the integer value. And again in integral value, we have characterized into integer and floating points. In Boolean type, we will get the Boolean value. In character, we will get char. Under integer, we will get byte, short, int, and long. Under the floating point, we will get the float values or double values. Under non-primitive data types, as we discussed, we have strings, arrays, objects, classes, etc. So, this is the 8 primitive data types. So, if we see, so these are the basic building blocks for our any Java program. They simply store the actual values directly. If we see, we have 8 primitive data types. In this 7 or comes under the numeric data type, and Boolean is the separate data type, which means it will store either true or false values. But all these 7 data types will store the numeric values. So for each data type, we have some particular size. If we take the first data type byte, it has 1 byte. That means in data types, we have either byte or bit. So bit is nothing but we have one particular value. It can be either 0 or 1 that is going to store in that particular memory location. So if 1 byte is equal to 8 bits. That means if you are using the byte data type, it is going to provide you the space of 8 bits. That means you can store the 8 values in that particular data type. So it can be stored either, it will be storing only 0 or 1 values. And when we are taking short, it is allowing 2 bytes. That means 2 into 8 bits, that it is going to provide 16 bits. And the same wise integer have 4 bytes and long providing 8 bytes. And character it is providing 2 bytes, and the float is providing the 4 bytes, and double is providing 8 bytes. If you are going to store very short value, you can go with a byte, and if it is a bit of little medium, you can go with short, and you can use int. If your integer value that you are going to store is a very big value, then you can go with the long data type. And if you are going to store a character, it can be in either number, alphabet, or anything. And here, why we have considered char as a numeric data type? Because even though we are storing alphabets or numbers, whatever we are going to store in the variable, it is going to convert the particular value into numeric value. For example, if we take A, so if we know the ASCII value, for even for alphabets, we have the ASCII value. So for A, the value is 97. So for B, it is going to be 98 and so on. And even for lower cases, we have some ASCII code. So whatever we are going to store, it is going to convert it into values either 0 or 1. So based on that, it is going to store in this particular memory location. And for float, we have 4 byte, and for double, we are going to store 8 bytes. And boolean is 1 bit. Before, in earlier days, even boolean is considered as 1 byte, but later they have changed it to 1 bit, because it is going to store either only true or false. True means we will be having the 1 value, and false means 0. If the condition is true, it is going to store 1 in that memory cell. If it is false, it is going to store as 0. So it just required 1 bit. So these are the primitive data types according to their sizes. And these are the non-primitive data types. The non-primitive data types, they do not store the actual value directly, but they will store a reference. That means a pointer to where that particular object is stored in the memory. For example, if you are declaring the data type string, it is going to store text like hello. This particular variable, it will hold the address of this hello, and it is not storing the actual object value. So the default value for references is null. That means there is no object yet, and it is going to display the value as null. So that means here, think of primitive data types like you have a small box, and you labeled it as A, and inside that box the number 5 is placed. So the box contains the actual value. So for example, uh, as I said, you have the value A, and you are going to store 5 inside this particular box. Think that A is a box, and you are going to store 5 into this box. So this box contains the actual value 5. So that's why we say the primitive types always store the actual value directly. But when we are coming to the non-primitive data types, the variable does not store any value. For example, if you I am going to declaring a variable name, and to that name I am going to assign the value straw. So this variable does not store straw inside this. So instead, Java will create an object in a different memory area. So that particular string object containing this characters straw. So Java will store only the address of this value. That means the address of this object. So Java will somewhere create a address for this object for this value straw, and this variable is going to store the address of this object. That means I am having the address as 1001 for this particular object of straw, and the name variable is going to store this address. So it is not going to store straw directly inside this. Instead, it is going to store the address of that particular object. From there, it will fetch the value inside the memory location. So this is how you will be storing values in the primitive and non-primitive data types. So then the next important topic is typecasting and type conversion. So how we are going to convert a particular data type. For example, what exactly is type conversion? So when you mix different data types, Java may convert types automatically, or you may need to do it yourself. So mainly there are two different types of conversion. One is the implicit conversion, it is also known as widening, and the other one is explicit conversion. That means the implicit conversion is also known as widening, and the explicit conversion is also known as narrowing or casting. In implicit conversion, it is automatically going to change the data type, and in explicit conversion you have to declare that particular data type which you want to change to. For example, implicit conversion will travel from smaller to larger data type. If you see this image, these are the data types that we have. So implicit conversion will travel in this direction. So byte, then short, then int, then long, float, and double. So you have, for suppose you have declared the variable as 10. So if you see in this particular example, so we have declared the data type int, and we have declared the value 10, and you want to change this integer data type to double. So it will go from smaller to larger type. So byte is integer is the shorter data type compared to the double. So the implicit conversion, it will automatically convert the integer value to the double. So the 10 will automatically convert to the decimal value 10.0. And but in the case of explicit, when you want to convert the big data type into the small data type, you have to declare that particular data type. So if we see in this particular example, I have declared the value as double data in double data type, and I want to convert this particular decimal value to the integer. So I have to use the integer data type, but unlike in implicit conversion, you cannot just directly give int and you cannot declare the variable. You have to provide that particular data type which you are trying to convert. So I have to declare integer here in the parenthesis so that it will convert this particular decimal value to the integer data type. So here the x will become 9. And you have to be careful when you are going to use explicit conversion, when you are dealing with some real time application where it is about price or the amount matter. So when you are using the explicit conversion, and you may lost some fractions or decimal values which will create a big difference in the total amount. So you have to think and use which conversion will suit for your program. And this is one of the example that I have taken. So let's execute it. Yeah. So this is our type conversion example. So if we see, I have declared the class name as testing typecasting example, and I have declared the integer num value as 10, and then I have declared the I am trying to change this particular integer value to the double value. So here you are converting the int data type to double data type, which will automatically fit because integer double is greater than the int data type. So it will automatically convert 10 to 10.0. So this is the implicit conversion. Then the second one is the explicit conversion. Here I have declared the double value and I am trying to convert it to integer value. Here double integer data type is smaller than the double, and when you are trying to convert some large data type to the small data type, you have to declare that particular data type which you are going to convert. So when you declare int here, so it is going to convert this particular 9.78 value to the integer value, that means 9. So when you print this line, it is going to provide you the value 9. And next is, and we can also convert the character to, here we are going to convert character to integer. This is also the implicit conversion because char is smaller than the integer is smaller than the char data type. So when you are going to convert this a to integer, it is going to give the value as 97 because the value of a is 97 in ASCII value. And here we are going to convert integer to character, that means explicit. Here character is smaller than the integer data type. So whenever you are going to convert the value 66 to char, you need to explicitly mention the data type char. Then it will convert to that particular data type and display the output. So let's see by executing this. And we can see here, as I said, the first implicit conversion, this particular part, when we convert the integer value to double, it is going to provide you the decimal value 10.0. And the next explicit conversion, when you are going to convert a double value to integer, it is going to declare you the integer 9. And then when you try to declare the uh, convert the character to integer, it gave the ASCII value. The ASCII value of uppercase A is 65. And next, when you are going to convert the integer to character, and it is going to convert this particular 66 into the alphabet, and the 66 will hold the capital letter B in the ASCII code. So this is how we will perform the type conversion. So our next topic is scanner input. So what exactly is scanner input? So scanner is something, it is a helper class that is provided by Java that makes it easy to read input typed by a user at the keyboard or from other sources like files. So think of it like a receptionist who listens, understand basic data types, numbers, words, lines, and hand those values to your program. So when you want to import this particular scanner, you have to declare the package java.util. So when you use this package, it will import this particular library from the particular package from util library, and which will provide methods to read and parse inputs from various input sources. And what exactly this scanner will do? It will break the inputs into tokens and convert those tokens into different data types like int, double, boolean, and string. So whenever we are going to use the scanner, first you need to import the scanner class. That is, we have to follow three steps. And the first step is you have to import the scanner class. Before you use scanner, you must tell Java where to find it by importing the class. So then when you have to declare this particular statement at top of your code, so that it will import the scanner package. And the second step is you have to create the object for this particular scanner class. As we know, we will create object for classes. Here the scanner is a class. So you need to create a scanner that reads from standard input. That means from the keyboard. So how you will declare the scanner? So scanner is the class name, and the SC is the object or the variable name, and new scanner, and system.input is, it will help you to read the data, input data from the keyboard. And when it comes to third step, you are going to read the correct values with the correct method. That means scanner will provide different methods depending on what you want to read. So use the method that matches the data type. And common methods, so these are the few common methods that we are going to use. So sc.nextInt method, so it will read an integer value. That means the whole number. And when we are using the next double method, it is reading the decimal value. And when we are using the float, it is reading the float value. And if we are using long, it is going to read the long value. And whenever we are using the next method, it is reading the next word. That means stops at particular space in the statement. In a particular statement, we will be having the so many words. So whenever we will give the next method, it is going to read the next word, and the next line, it will read the full line. So the difference between next and next line is, next is going to read the number just beside word just beside it, and when you use the next line, it is going to read this entire line. Whatever words and comes under this line, it is going to read this particular entire line till enter. And next boolean, it is reading either true or false values. So if we see this particular example, int age, I have given the next int. It is going to take input from the user. So it will read the integer value. And for salary, I have declared double because salary will be in decimal values. And for word, I used the next because it is going to read the single word, and it will stop when it sees the space. So for every word, we will be having a space in between. So whenever that particular next method is seeing the space, it is going to stop, and it is going to just read the word before it. And when we are using the next line, it is going to read the whole line, including these spaces. And the boolean, whenever I am going, here I have used the next boolean method because I am going to check whether the flag is 0 or 1. So these are some common methods. So this is one of the scanner example that I have given. So let's execute it and understand one by line. So this is our scanner example. So if we see here, as I said, first whenever you are going to use the scanner variable, you have to declare the import line before your code so that it will import this particular package from this particular util library. So this line will import the scanner class. Uh, so import is nothing but I want to use, you are telling to the computer that I want to use the scanner in my program. So it will bring it into your code. And the next line, public class input example. As we know, public is accessible for everyone and we are creating a class with the name input example. And a class is just like a container that will hold your program. And the next main method and the public static main method. So this is the main method. Java will start running your program from here, and without main method the program will not run. JVM will not understand from where your program should execute. And the next print statement, here I am going to declare the scanner variable, scanner class. So you are creating an object to the class scanner and you have named that object as SC. And the new scanner system.in means it is telling to the computer take input from the keyboard. And think of this SC like a receptionist, like who will collect information from the user. The same way SC is going to collect information, whatever the user is going to type from the keyboard. And the next line, I am going to print the name of the user. So it is just a print message asking the user to enter the name. And print does not move. Here I have just given the print. I have not given any ln beside the print. So it will just be in that particular line. For example, if I declare ln, uh, I will execute and show it to you. When I execute it, now you can see the cursor in this particular line only. But when I add the print ln, that means it is new line. And when I am trying to execute it now, you can see the cursor is went to the next line. So that is the difference between print and println. Whenever you don't want your code to go to the next line, you can just use the system.out.print. So it will ask the user to enter their name. And here I have used string name with the method sc.nextLine. That means it will read that particular entire text. That means that entire line of text, whatever the user is going to type. So it will store that particular value inside the variable called name. So here the name is our variable and whatever the value user is going to enter here beside the enter your name, that is going to store into this particular name. And so then for example, if I have typed the Shravani, so the variable name is going to store the value Shravani. And the next print statement is it is going to ask you to enter your age. So whenever you are the same way here also I have declared only the system.out.print. It is going to ask you the age and I have declared the method sc.nextInt. So here it will read the integer value whatever the user has typed and it is going to store that particular value into this variable age. And the next line I am going to print the entire content. So here I have given hello, and whenever you give name variable, it is going to fetch the particular value that is stored in the variable name and it is going to print here. As I said before, whenever you want to when you exactly want the statement to be displayed on your terminal or the console, You just have to place that particular statement and inside the double quotes, and then if your value should be stored to concatenate to that particular statement, you have to use the plus operator so that it will concatenate the result value here and it will display in the output. This name will fetch particular value that is stored in the memory. For example, if I stored Shravani, so it will display hello Shravani, and it will concatenate the next statement you are and age, whatever age I have given to the input, so that is going to fetch here. And for suppose if I given 32, so hello Shravani, you are 32, and it is going to add the next state words, that is years old. So finally when you execute this, it is going to provide you hello Shravani, you are 32 years old. And SSC dot close is whenever you finished using the scanner, you can just use this method sc dot close. It is not mandatory, but it will be useful because it will not lose any memory information. So let's execute this particular code. So the cursor blinked and I am going to enter the name, and then it is going to ask me the age. So as I said, it will display you hello Shravani, you are 22 years, 32 years old. So this is about our scanner input. Okay, now let's talk about the functionality, how the Java programs will work. So first let's discuss about the JVM. JVM stands for Java Virtual Machine. So what exactly is JVM? So think of JVM as a special machine inside your computer whose only job is to run the Java programs. That means we know that when we write the Java programs, first we will save the file name with .java extension, and then when the Java compiles it, it will convert into the .class file. So this .class file is nothing but the bytecode. So we already know about this part. So we know that computer cannot understand this directly. So in that place, the JVM will steps in and it says to the computer, don't worry, I will understand this bytecode and I will run it on your computer. So this is why Java is platform independent. Java code is the same everywhere, but each OS, that means the Windows, Mac, Linux, or whatever, has its own JVM to run that particular bytecode. So why Java exists? So because every computer speaks a different language. Windows machine speaks Windows machine code, the same way speaks the Mac machine code, and the Linux speaks the Linux machine code. But Java produces the same bytecode for everyone. Then how it is getting executed in different operating systems? So that is where we have the JVM. It acts like a translator who understands bytecode and translates it into that computer's machine language. So if you see here, we have four types of main components. First one is the class loader. So class loader is like uh, it is like a finder and loader. That means it is this part is like a librarian. So its main job is to go and find the .class file, and it will bring it to the memory, and it will load everything that your program needs. For example, the classes from your code or libraries or files, etc. Think of it like we will use the scanner library in our code to get the input. So the class loader job is to find that scanner class. So this is what the class loader will do. And the next main important component is bytecode verifier. It is like a security guard. That means after the class loader brings the particular file, JVM will check is the code is safe, or is anything illegal written in that particular code, or is someone trying to hack or break memory rules. So if it finds suspicious code, it blocks that particular execution. It will prevent memory corruption, unsafe instructions, attacks from malicious bytecode. So the main goal of bytecode verifier is its only safe code will run in the computer. Next comes to the our third runtime areas. That means memory sections will be used while we are running the code. So when a Java program runs, JVM creates different memory areas. It can be method area, heap, or Java stack, register, or native method stack. There are so many areas. So each of them, what exactly is method area? That means method area will store the class information, method names, variable names, static variables. It is like a big reference book, so where it will store all the details. And heap is nothing but it acts like a main memory where Java will store the objects. And Java stack is uh, each thread in the Java will get its own stack where it will stores the method calls, local variables, temporary values. So this is what Java stack will do. And PC registers, so it will store the current instruction that a thread is running. So whatever the current thread is running, it will store that particular instruction. And native method stack is like, for example, if Java code calls the C or C++ native, so JVM uses this area. So this is about the runtime data areas. And next, the last important component is execution engine. So this is where the actual program runs. That means this part will execute your code. It has two main workers, that is the interpreter and JIT compiler. Interpreter means whatever bytecode is created, it will read that bytecode line by line and it will execute it. So it also has an advantage and disadvantage. So the advantage is it will start fast, but the disadvantage is slower for repeated instructions. We know that we will be having so many repeated instructions. So in that case, it will become slow, and this is the disadvantage of the interpreter. When it comes to JIT compiler, JIT, the full form is just in time compiler. That means it is like a smart assistant. It will notice which parts are running repeatedly and convert those repeated parts into native machine code. So next time when the code runs, it will directly run it and it will become much faster. So this is how Java becomes fast at runtime. And JVM is platform specific. That means, as we know, each OS has its own version, JVM for Windows, Mac, and Linux. But all of them can understand the same bytecode. That's why we call it as write once and run anywhere. So next important one is JRE. So JRE full form stands for Java Runtime Environment. It contains the JVM implementation. Whatever the JVM will take, so it will implement it. It will be having the core libraries, and these are the few libraries like java.lang, java.utility, and input output, networking, so many. And it other runtime components. So if you want to run your Java program, you have to install the Java runtime environment. And the Java development kit. So Java development kit is like it contains the JRE, so where you can run your programs, and it contains the compiler where your dot Java file will convert into dot class file, and it also has the debugger, Java debugger, and it has some tools, and it also has header files for converting into native code, and tools for packing and monitoring. And install the when you want to run the particular Java programs, you need to install the JDK. So if you see this image, first JVM will be inside the JRE, and where the JRE will contains the Java classes and libraries, and JDK, the whole kit will contain both the JRE and the JVM. So where it contains the development tools and header files and everything. So we already know like how the Java programs will work. So whenever you write the code, you will be saving it with the .java extension. So you will be saving it with a file name and with .java extension. So when you run it, you will be running with Java C hello.java. That means this particular thing is the Java development kit. where it will produce you the hello dot class bytecode. And when you run this hello file, and JVM which presents inside the JRE will load this hello.class file and then start executing it. So we know the .java means our source file which we have saved, and once it compiled, it will get converted into .class file. Then the JVM will make it run on your machine. So this is how the Java programs will work. And next, what is the importance of main method? So we know that main method is the entry point for a standard Java application. When you run Java class name, the JVM looks for a specific method signature to start that particular execution. We already know without the main method, JVM will not understand from where your program should execute. So if you don't have the main method in your program, it will throw the runtime error. So this is the standard signature that which we have, public static void main, and it can be in any format. So when we see this particular parenthesis, so string args, it can, this square brackets can be written here, or even the public and static keywords can be replaced. So there are so many different types of signature, but the JVM will mainly look for the standard signature, that is public static void main string args. And our next important topic is operators in Java. So these are the different types of operators: arithmetic, unary, assignment, relational, logical, bitwise, ternary. Let's see in detail about each operator. So the first one is arithmetic operators. So in Java, arithmetic operators are symbols that allow you to perform basic mathematical operations. So just like you do every day in your life, like addition, subtraction, multiplication, division, etc. So these operators work on numbers like int, double, float, long, etc. So let's break down them clearly. So these are different categories. And so for example, first if we take the addition operator is nothing but we are adding two numbers, or we are joining the two strings. We can be used the addition operator for joining, adding the numbers, or concatenating the words. So for example, if we declare the variable int a equal to 10 and int b equal to 5. So to add these particular numbers, we need to store the result into another variable. You can write it as result or sum. So where you will be adding the two integers a plus b. So that will produce the result. 10 plus 5 is nothing but the 15. So the same way we will use the addition operator for concatenating the words. So if you want to add concatenate two words, for example, I am going to declare a variable name where it will store the Java, and if I take another variable as language where it will store the programming string. So we used string data type because we are storing the words. So to concatenate these two words, I am going to print the statement with string system.out.println. So when you want to add two words, you need to use the addition operator which will concatenate the value. So when I at moment when I write the name and language, it will combine the words and it will produce the output as Java programming. So here I did not give any space. So it will combine both the words. If in case you need a space between the words, you have to use the space operator in between. For that you can give just blank double quotes and then you can write the lang again. So in this case it will going to produce you Java space programming. So this is how we will use the arithmetic operators. So we also have the subtraction. The same way, if you want to subtract one number from the another, we will be using the subtraction operator. And then, like if you are subtracting 10 minus 3, it will give us 7. So the same way, wherever you are going to use the addition operator, here if you use the subtraction operator, it is going to produce you result 10 minus 5 will be 5. And at the same time, if you are going to use the multiplication operator, it is going to produce you 10 5s are 15. The same way, if we are going to use the division, it will produce you the quotient. And when it comes to division, divide numbers, if both are integer, it will produce the integer division. For example, uh, but the important part is, if both numbers are integers, decimal part will be removed. So, because it cannot store the decimal values, because we are using the int data type, it cannot store the decimal values. If you need the exact decimal value, you need to use either double or float data type to get the decimal values. So, and the difference between decimal and modulus is, when division and modulus is, whenever you try to divide two integers, it will produce you the quotient value. And whenever you are performing the modulus, it will gives you the reminder. That means, for suppose if I am trying to divide the 10 by 3 in our example, so whenever you will perform the division, it will give you the quotient. So this will become your division operator, and the remainder one will gives you when you try to perform modulus. So these are the arithmetic operators. So now let's see a program on it. So this is the program of arithmetic operations. So let's try to execute it. So we know that we are creating a class named arithmetic example. I have named it as arithmetic example. And then in Java, every program must be inside a class. So this is the main method, starting point of every Java program. And when you run the program, Java begins from this particular line. So first I'll explain it. Then here we are declaring a variable price of item with the value 250 rupees. So it stored the price of particular item. So the value is 250 rupees, and int means we already know it is the data type of whole number. So for example, if let's take that if one chocolate cost 250 rupees, that is the price of one chocolate. And in quantity equal to 3 means the customer buys 3 items. So the customer is buying 3 items. So we store this 3 value in the variable called quantity. And let's assume that customer takes 3 items from the shop. And when you are giving the discount, the shop is giving a discount of 50 rupees, and this 50 is getting stored in the variable discount. So shopkeeper reduces rupees 50 from the final bill. So then uh, here we are doing the multiplication with the price of item and quantity. So multiplying the price of each item with the number of items that he has taken. So for example, in our case, the price of item is 250 and then the quantity is 3. So that means the 250 will get multiplied with 3. So the total, the amount will become 750. Then this is the total which before applying the discount. So if one chocolate costs 250, then 3 will become the 750. And finally, before making the final bill, here they are providing the 50% discount. So we are subtracting 750 minus 50, that will become 700. So this is the final bill that customer need to pay. need to pay. So here we are printing the total amount first, then the amount of discount they are providing, and the final bill to pay. So when you run the first line, it will provide you the total amount, that is 750, and then the discount will be displayed as 50, and in the final bill it will show the 700. Now let's execute and check the values. So, yeah, as I said, the total amount will be 750 and the discount is 50, and the final bill the customer need to pay is 700. So this is how the arithmetic operators will work. So the second operator is unary operators. So unary operators are operators that which will operate only on single operand to perform operations such as value modification, sign change, logical negation, or bit level manipulation. So that means they require only one input operand and appear before or after the operand depending on the operator's type. So these are the different categories: unary, plus, minus, incrementation, decrement, logical not, or bitwise not. So why they are called as unary? Because they require only one operand, unlike binary operators where we need two. So unary operators require only one. Let's discuss each categories in detail. So unary plus, that means it will return the positive value of the operand. It usually has no effect but is used to indicate positivity explicitly. So for example, if here I have given plus 5, it doesn't make any change, still it will give the output as 5. At the same time, when we use unary minus, it will return the negative value of the operand. That means, for suppose, if I have declared the integer x as 5 and I am asking the computer to display me the negative value of the particular x. So then in this case, y will become the minus 5 because x value is 5 and it will change the operator sign and it will give the result as minus 5. The same way, increment operator. So this is the pre-increment. So there are two forms, prefix and postfix. First we will see about the pre-increment. That means incrementation happens before the value is used. For example, if I am declaring the variable x as 5 the same way and I am applying integer y equal to plus x. That means initially our value is 5. And what exactly the pre-increment is doing? It will increment before the value is used. Before the value is used because we have addition before. So first it will increment the value 6, 5 to 6. Then it will 5x will become 6 and y also will become 6. And the same way the post increment. So in post increment, it is doing incrementation will happen after the value is used. For example, uh, if you see the same way, instead of plus x, if I declare it as x plus, first it will use the value. Uh, b will become 5. So for example, if I have declared int a equal to 5 and int b equal to a plus plus. So what exactly the post increment will do? First, increment will happen after the value is used. So once the value is used, then it will get incremented. First, it will use the value 5. Later, it will get incremented to 6. So the same way we have the decrement, pre-decrement and post-decrement. So even here it will first decrement and then it will use the value, and in post-decrement first it will use the value, then it will decrement. So then we also have the logical not. That means it will invert the Boolean value because we have true or false. That means whenever we use the logical not, true will become false and false will become the true. And then we have the bitwise operator. That means it will flip each bit of its operand. That means we will be having ones and zeros, and 1 will become 0 and 0 will become 1. It is also called as one's complement. So that means it is flipping all the bits. For example, if I have taken the uh, integer x as 5, and then I am giving integer y equal to flip the uh, flip the x. So we will be using this tilt operator. So for example, we know the binary value of 5 will be 0 0 0 0 1 0 1. So, or we can just say take the short form 101 will be the binary value of 5. And when you are converting it, it will be 1 will become 0, 0 will become 1, and 1 will become 0. So it will generate the 0 1 0. So this is how the logical not bitwise not will perform. So these are the few unary operators. And now let's see the code. So this is the example of unary operator. So we know here I am declaring the int likes equal to 100. That means we know that like is an integer variable. It will store the current number of likes on a post. So the one post got the 100 likes. So we know that initially the likes is 100, and then I am going to print this particular likes. So before like, that means previously how many likes, here it will print the 100. And once we increment it, so this is the unary increment operator. So it will increase the value of likes by 1. That means 100 will become the 101. So why unary? Because the operator works only on one operator. So increment, we have, when we want to increment exactly one value, we are going to use the increment operator. So when we are printing this particular line, here it will display 101. So before we have 100 likes, and then once we increment, it will become the 101. Let's execute it and check. So this is the code. So before likes, we have the 100 values, and once we increment it, it will become the 101. So our next operator is the assignment operator. So we use assignment operators to store a value into a variable. So I have been telling you from the beginning, whenever you want to store a particular value, we will be using the assignment operator. That means the right side value will get stored into the left side variable. So that is the basic format. So Java will also provide compound assignment operators, which will combine an arithmetic or the bitwise operation with assignment. So that we will be seeing in detail. So these are the compound operators. So let's see one by one. So first we will see the simple assignment operator. This we already know. Whenever we want to store the value from right into the variable on the left, we will be using the simple operator. That means whatever the value we are declaring here, the 10, it will get stored into the variable a. So a will become the 10. Then the compound operators. So we are using the addition operator and then we are also assigning the value. That means these operator perform an operation and assign the result back to the same variable. For example, uh, here I am declaring it as a plus equal to 5. So here a plus equal to 5 is nothing but a equal to 5. Initially, a will be having some value, then it will add to the 5. For example, if we see here, I have declared the variable a as 3 and I am going to add it to the 5. That means we know that a equal to a plus 5, then it will become the 3 plus 5, which is nothing but 8. So you can see here the result will become 8. So that means it is performing both operation and assigning the result back to the same variable. At the same way, we will be doing the subtraction and assigning the value, and it will subtract b from a. Whenever we are trying to give a minus equal to b, it is subtracting b from a. The same way we are multiplying it, so it will multiply a by b, and then here we are doing the division. It will divide both a by b, and modulus, it will store the remainder of after dividing a by b. That particular remainder is getting stored into the value a. So these are the few bitwise operators. This will be used mostly in advanced programming programs like embedded system graphics and all. So for example, if I'm going to take a real-time example. So imagine like if you have a wallet that has some money. For example, you have money with you as 100. Then now you are going to add 20. To add 20 to the current value, initially we use it to do 100 plus 20. Instead of that, we can just write money plus equal to 20. So it is going to add the 20 to the original amount. Then here your amount will become 120, and then now your wallet has 120 rupees. Imagine you spend 30 rupees from it, and again now you need to subtract from it. The same way you are going to deduct your amount, that is equal to 30. So 120 minus 30, that will become the 90. So now your wallet has the original amount 90. So let's see the real-time example. Here, this is the example of assign operator. So, initially, I am going to store a value 10 into the integer variable a. So, this is done using the simple assignment operator. So, this is how first I will be declaring the initial value. And then when I am going to perform the addition assignment, that means I am going to use the a plus equal to 5. This means the previous value is 10 and you are going to add 5 to the previous value, that will become the 15, and here I am going to deduct. So now your original value is 15. For this 15 you are going to deduct minus 3, so that will become 12. Now your a value is 12 and now you are going to multiply it with 2, that will become 24. The same way, your current value is 24 and you are dividing it with 4, it will give you the quotient value 6. And your a is 6 now, and you are going to perform modulus operator, that is 4. Then it will give you the remainder as 2. And whenever you print the final value of a, it became from 10 to a. So this will provide you the value as 2. So this is the final a value which we got. So let's execute it. So this is our assignment operator example. So as we see, the final operate value will be 2. So these were our assignment operators. Now let's move on to the next operator, that is relational operators. So in Java, relational operators are used to compare two values. So the result of any relational comparison is always a Boolean value. It can be either true or false. Whatever operation that you are going to perform on relations, so it will be providing either the true or false value. So this will help you to check the relation between values like is one value bigger than the other, or they equal, or they different. Does an object belong to a particular class? Whenever you are going to compare two values, in that case we can go with the relational operators. So mainly we used these relational operators in our if else condition, loops, decision making, validation, or searching or filtering logic. So we know why they are called relation, because they are checking the relation between two operands. So operands can be anything, it can be numbers, characters, or objects. So these are the list of relational operators: equal to, not equal to, etc. Let's see in detail. So equal to, why we use the double equal to sign? That means whenever we are using the double equal to, here we are going to check whether the two values are equal or not. So for example, if I declared int phi equal to phi, then uh, or we can see I have declared the two variables int a and int b. Int a value is phi and int b value is phi. So now when I am going to compare it, I will be going to write int a double equal to b. That means a value is phi, b value is phi, and it will give the output true. If my value is 6 and I am trying to compare it, then it will display the value as false. So it will check the particular memory address. For objects, it will check memory address, not the content. So this is for numbers. If we try to use this particular double equal to for the string variables, that means since I am going to declare the string s1 equal to new string, that is the hello, and I am storing the value hello. The same way, I am going to declare the another variable string s2, and that value is new string. This particular value is storing the variable storing the value hello. So here we can see the both values are same and it is storing in two different variables. But still, here if you try to print the values, if you use the equal to operator s1 equal to 2, you may think that it will produce the output as result, but still it will produce the output as false. Why? Because for objects, these are the objects. So we have created the objects. So it will store, always objects will store the memory address. So it will check the memory value. It will not check the content inside that particular variable. So here S1 will have memory address as 1001. Maybe here it may have 1002. So when you try to perform the equal to operator, the values of S1, S2 will get stored as 1001, 1002. So the both values are not equal. So in this case, it is going to produce the false. So if you try to perform equal to operator on strings, it will always produce the output as false, because we cannot have the same memory address for any variable. So each memory address will be different. And next category is not equal to. This will check whether the two values are not equal. So here if the operator sign will be the exclamation, when we try to give f1 is not equal to f2, it will produce true, because it is not, it is phi is not equal to 2. The same way, mm, the same way, if I try to use the phi not equal to phi, I get this particular declaration. Here it will give the result as 5 because 5 is equal to 5, and you are trying to use the not equal to operator, which will give the result as false. And there are the another category is greater than, so it will check whether the left value is greater than the right value. So here the 10 is greater than 5, that will give the result as true. The same way you are going to check the less than operator. It will check whether the left value is smaller than the right value, and it will print the true. And this is the greater than or equal to operator. That means it will be used in a condition, if condition. That means the condition is true if either it will go with two categories. That means here I have taken 10 greater than equal to 10. That means first it will check the with one condition 10 greater than 10, and then it will check with the another condition 10 equal to 10. In this two, either one need to be get correct, so then the condition will be true. For example, here it will check for both the comparisons, which if even the one comparison is true, that it will produce the result as true. So the same ways it will go for less than or equal to. Here we are checking whether the uh, left value is less than or 6 or equal to 6. Here it is producing 2 because 4 less than 6 condition will get true. So these are the assignment operators. Sorry, these are the relational operators. So now let's see the example. Okay. So here first I have initialized two values, a as 10 and b as 20. So when I am trying to print a equal to 4. Okay. So a equal to 4 is false because 10 is not equal to 20. And when I am trying to print a not equal to b, it will produce the true because they both are not equal. And a greater than b, we know that is false because a is less than b, and here a less than b, it is going to print true. And when you are comparing greater than or equal to, a greater than or equal to 10, here I have used particular value, so it will give true because a means 10 greater than or equal to 10, of course it will get equal. And the same way here I am going to use 20 less than or equal to 20, still the assignment operator will work, so even this is the true. So let's execute and check. So whenever you are going to use the relational operators, it is going to print you just the Boolean values, either true or false. So if we check, it has print the exact values: false, true, false, true, true, true. So this is what our relational operators. So next we have the another operator, which is the logical operators. So logical operators will be used to combine multiple combinations and produce a Boolean result. Even the logical operators will produce you either true or false value. Even these will work only with the Boolean values. So logical operators will help the Java make decision inside the conditions like if statements, while loops, and complex checks. Whether you are going to check the real-time scenarios, check the particular person age, and check the password. So in these cases, we will be using the logical operators. So there are three categories: logical, and, or, and not. So so the first operator is logical and. So the logical and means it will return true only if both conditions are true. uh, if we take the real life example, so whether whenever you want to enter the exam hall, you must have the hall ticket and you have your college ID. Even if anyone is missing, you cannot enter. It's not like the relational operator. If one operator becomes true, then even the other is wrong, it will become true automatically. In logical operators, the both conditions should become true. So and will used only when both conditions are true. Uh, if I am trying to, for example, uh, so imagine I am declaring the variable 20 to the value 20 to the variable age, and I am declaring the boolean type this particular person has ID. So that will give true. And I am going to check if this particular person age. So I'm giving a condition that the person, every student should have the age greater than 18 and they must have the ID with them. So we know that when we use the AND operator, when we want to check, both conditions should be true. So as I said, you should have the hall ticket plus ID with you, then only you can enter into the examination center. The same way here, I have given the condition as age. He or she should be greater than 18 and she or he must have ID with them. Then it is going to print the statement. Yes. Um, Here this is, for example, here we are doing this for voting. So in voting, we must have our age should be greater than 18 and we have our voter ID. Then only we can vote to the person. So when I try to print this, if this condition is true, then it will display you can vote. Or if else, it will display if this condition is not true. If it is true, it will print you can vote. But if it is false, if this particular statement is false, it will print you are not allowed to vote. So this is how you will use the AND operator. So whenever you want to check both the condition 1 and condition 2 become true, then only you will be eligible. So this is where you will use the logical AND operator. So we also have the logical table. For example, let's write A and B, and we are trying to perform A and B. For example, first condition, imagine this is as condition 1 and this is as condition 2. So first condition is true and second condition is true, then the logical AND operator is true. If first condition is true but the second condition is false, it will become false. If the first condition is false or second condition is true, even though it will become false. Also, if both condition is false, it will become false. So logical AND will be works in only one case, both conditions should be true. Then only it will display true. So in some cases, if the first condition itself become false, then it will not go for the second condition. Directly it will produce the result as go to the else block. So this is called the short circuit evaluation. So it is an important interview question. You The interview person may ask when is in which operator we will be using the short circuit evaluation. So then it will be as logical and operator. And the next category is logical OR. Here it will return true even if one condition is true. So if we take the uh, real time example as you can pay using UPI or you can just give the cash on delivery. So any one option is applicable. Whenever you go to any shop, they may ask you either pay from UPI or you can give the cash. So both may work. So even if you have one, you can go and buy the items. So the same way, uh, here, as I said previously, for example, here I am declaring int age equal to 16. My initial value is 16 and I am giving the boolean value whether has permission to enter or not, that I am declaring as true. And while I am giving condition, the same way I am going to give the condition age should be greater than or equal to 18, or it can have the uh, sorry, it can have the permission as true. So then your SOUT statement will be you can enter, or if that particular condition is false, it will print as access is denied. So when we are going to check whether either one condition should be true. So we have two conditions. This will become false because initially I gave the condition as true 16, and here I am going to check whether the person has age as 18. So here the condition will become false, but has permission, here I gave it as true. She has the permission, he or she, to get enter into uh, so here it will become true. So logical operator will check either one condition should be true. So in this condition it will become true. It will give output as you can enter. So the same way here even this will get an table. So check for condition A and condition B. You are going to apply or operator. So if your value is true or true, it will produce true. And if one condition, it is even if it is true or false, it is true. False or true, it is true. And false or false, it is false. In logical operation, you need either any one condition as true. Then it will automatically will become the true statement. So even this is a short circuit behavior because it will check if the first condition is true. It will automatically skip checking the second condition. So this is the short circuit behavior. And our next category is logical NOT. Here we already know it will reverse the boolean value. True will become false and false will become the true. Uh, Imagine, let's take an example. So for example, I am giving a variable whether it is raining or not. It is false. I have given it as false. That means it is not raining currently. So when I give the condition not, that means logical not is raining, then it is going to print you can go outside. Okay. So initially here my condition is I have given is raining equal to false. So here when I use the not raining, so false will become true. If true, then you can go outside to play or something. So we know that Boolean value A will become true will become false and false will become the true. So these are our these are our collaborators. Like if we take a real world example, for example, uh, we will be using the logical operator to check the user access. So I am declaring the first variable string user equal to I am here user is the admin, and I am going to set the password as 123, and when I am checking it should match with the user and password. Then if user equals to admin and his password is equal to 123, 123, so then he will get the access. So it will show whether the login is successful. If not, it will print the login is failed. So it will check for the both conditions whether the user is equal to the admin and his password match with 123. So then only he will get the login success. If not, the login will get failed. The same way we can use in many scenarios like bank withdrawal permission or so bank withdrawal, we will be checking what are the basic conditions for bank withdrawal. If you want to withdraw money from the bank, we will be checking whether the balance should be there in our account and our account should be inactive and there should be the limit should be there. So if all these conditions will work, then only you can withdraw the money from the bank. So let's see the. So this is the logical operator example. So here initially I have declared the variables. I am giving the person age is 16 years old and the person is with a parent. That particular person is with parent and the show is not full. Here we are going to check it for booking the movie, booking a ticket for movie, and the first it should be 16 years old. He or she should be 16-year old and he or she should be with their parents, and show it has to show the show is not full. That means the seats are available. So still the seats are available. So for let's understand this particular condition here. Let's see this first half. I have given age greater than or equal to 18. So the condition A is age should be greater than or equal to 18. And let's combine this particular condition. This entire part is okay. So this entire part is one condition. Then this entire part will become another condition. So first see this condition. So condition 1 is the age should be greater than or equal to 18 and he or she should be with the parent. So here if we see that I have declared age as 16. So age is 16, so it is not greater than 18, so the first condition became false. And with parent I have given true, so the second condition is true. So in this case Whenever we will use the logical or operator, we are going to check only for the one condition. If any one, either A or B should become true, then your logical or will become the true. So here one condition has true, then this particular entire condition becomes true. And now we are checking for the second half. Here I have given is show full, I have given as false initially. That means seats are available. When I am trying to use the not logical not operator, is show, that means it will become true. So initially the condition is false, we are making it as true. And this particular first condition became true, and even this particular condition became true. And what is the sign between here? Logical and. We already know when we are giving the table, if both conditions are true, then logical and operator will be true. So here this entire condition became true. It will print the statement as ticket booking successful. If not, even if you forgot to keep the not operator here, then this particular statement will become false, and then your value will be first condition become true and second condition will become false. This will automatically become false, and this is going to print booking failed in this particular condition. So this is the logical and operator works. So let's execute it and check. So this is our code. So when I run it, as we know, this particular condition will become completely true. So it is going to print you ticket booking is successful. So what is the meaning of this entire program? So you are trying to book a movie ticket, and you must be 18 plus or you must come with a parent. So our case under 18, because we gave the value as 16, but with parent is allowed. So that is our rule number 1. And rule number 2, the show must have seats available. So initially we have given false, that means the seats are available. So both rules are satisfying. So then the booking will get confirmed. So this is what this particular logic operator is explaining. Then our next operator is bitwise operator. So bitwise operators works on bits, that means zeros and ones of integer values. So they do bit by bit operation on numbers. They will work only on byte, short, int and long. They do not work on float, double or boolean. Why they are called bitwise? Because these bitwise operators do not look at the whole number. They look at its binary form and operate on one bit at a time. For example, uh, here my as we said, binary operator of 5 is 101 and 3 is 001. So we can apply either and or operator. So Java compares each bit one bit at a time. So it is going to compare each bit at a time. So it is going to work only on byte, short, int and long. So these are the some categories of bitwise operators. Let's see one by one. So first operator is AND operator. That means bitwise AND. So it will return 1 only if both bits produce result as 1. That means if we see the example, so as I already said, I am going to declare 5 as 101 and 3 as 0 1 1. So when I try to perform the AND operator in this, when I am performing AND operator, 1 will become 1. When 1 and how AND operator will become work? If both conditions are true, it will produce true. If one is false, it will give false. And if both conditions are false, it will give false. So in this case, true means 1, false means 0. Remember this. Okay. So true means 1, false means 0. Remember this particular pattern. And now when we are solving, that means if I write this particular table into ones and 0, 1, 0, 1, 1 will become 1, 1, 0 will become 0, 0, 1 will 1, 0 will become 0, 0, 1 will become 0, 0 will become 0. So when we operate this table, so 1, 1 will produce 1, 0, 1 will give us 0, 1, 0 will give us 0. And when you do the AND operator, this is our final value 0, 0, 1. And this will give as output 1. So the result 5 and 3 is going to give us 1. The same way we are going to use the bitwise OR operator. It will return 1 if any one bit is 1. So that means the same example. mm, Here like in this case why we got 1, because the binary value decimal value of 001 is 1, so it will produce the answer as 1. The same way, if we try to perform it this particular condition for OR, uh, imagine you are doing this for sorry, you are doing this for OR operator. So OR means either one condition should be true. This is for and I'm going to write it for OR. 1, 1 will become 1. 1, 0 is also 1. 0, 1 is also 1. This will become 0. Any one condition should be true. That means 1 should be 1. So then it will produce the answer as true. Here if we try to do it for 1, 1 will become 1. Even if it is 0, 1 it will become 1. Even if it is 1, 0 it will become 1. The binary value of 111 is 7. So when you try to perform 5 or 3, it is going to give result as 7. And before when you try to perform 5 and 3, it gave result as 1. So this is how the bitwise OR and operator will work. And next we have bitwise XOR. That means it returns 1 only if bits are different. That means if both bits are same, it is going to give you answer as 0. If there are different bits, it is going to produce you 1. For example, okay. So now I am going to take the same example. My 5 will be 101 and the binary value of 3 is 011. When I am going to perform the XOR operator on this, it is going to what is the condition? Either it should be same. If it is same, it will become 0. If it is different bits, it is going to become 1. So here 1 1 is same, it is going to produce 0. Here this is different, it is going to give 1, and here also different, it is going to give 110. And the binary value of this particular 110 is the decimal value of this particular binary form is 6. So when you try to perform XOR operator on 5 and 3, it is going to produce you the 6. The same way, we have the bitwise not operator. That means it will just flip the values. 1 will become 0, 0 will become the 1. So it will work only on single operator. So if I take the uh, uh, just we will see on one operator. So this is the 5 binary form. And when I am trying to perform bitwise not operator, 1 will become 0, 0 will become 1, again 1 will become 0. So it is producing me the 0, 1, 0. And the binary decimal value of this is 6. So the same way we have the left shift and right shift operators. So left shift means it is going to move all the bits to the left and add zeros on the right. So each left shift operator is like multiplying it by value 2. For example, let's take the same 5 value. 5 is 101, and when I am going to perform, oh, you can add a 0 here. So I am giving 5 left shift 1. That means you have to shift one value. Uh, so what is the condition? It will move all the bits to the left side and it will add 0 on the right. For example, this is our initial value. If we try to shift to left, this particular 0 should get out and 101 will get shifted to right, and we are going to add 0 on the right side. Now the decimal value of this binary form is 10. And if you are doing 5 left shift 2, here you need to shift 2 values. That means our 5 value is 101. You are going to add 2 zeros on the right side. That means the decimal value of this is 20. So as I said initially, 5 value is 101. We just need to add zeros on the right side. So we also have the right shift. Right shift is also same. Whenever I am going to perform 10 right shift 1, so the decimal value of 10 is 101. So 101 will move to the right side, and left side we are going to add zeros, that will become the value 5. And we also have another shift operator, that is unsigned right shift. That means it will shift bits to the right, but it will fill left with the zeros, ignores the sign. So it is used for large numbers and binary operations, considering the 32-bit integer operators. So it is mostly used in real-time scenarios, like whenever we are going to perform cryptographic or hashing functions or compression. In this case, we are going to use the unsigned right shift operator. So let's see this example. So this is the bitwise operator example. First, how we need to understand how we are storing the numbers as binary. So we know that binary form of decimal 5 is 10101 and 3 is 0011. So it will compare each bit either individually. One first it will compare either 0 or 1. So here we are using the bitwise AND operator. That means what is the rule of bit AND operator? If both are 1, then only it will become 1. Whatever the other combinations that we are going to get, those combinations will become the 0. Here in our case, it is 1011 and 0011, and when you perform the AND operator, it will become 0001. So the answer is 1. It is going to produce you the 1. The same way when you perform the OR operator, it is going to produce you the value 7, because 7, it will just take, even if one condition is true, it is going to become the true. So here it is true, here 1 is true, 1 is true, here both are false. So this is the decimal value of 7. And when we are performing the XOR operator, if it contains the same bits, it will become 0. If there are different bits, it will become 1. So if we take this condition, so same bits will become 0. Here there are different bits, same bits 0. So 110 will become the decimal value of 6. So that is the XOR operator. And NOT operator, we know it will just flip the values. So in this case, it will 1 will produce us so bitwise not value 1 will actually produce as 1, but it will become 0. 1 will give us 1, it will become 0. 0 will give us 1, it will become 0. 0 will give us 0, but it will give us 1. So this is the binary form of a not 0, and it will give the decimal value of -6. And also when you are trying to perform the left shift operator, so it will give you 10, and when you perform the right shift operator, it is going to give you the uh, value as 2. Because if I see, this we already discussed, they will be going to work only on one one operator. So 5, when you are performing left shift operator, so it will go to left and add zeros on the right. This is the decimal value of 10. The same way when you are performing on right shift operators, it is going to shift on right side and adding values on left. This is the decimal value of 2. So this is how the bitwise operators will work. So this is the example that which we have discussed, and let's try to execute it. Okay. So when I execute this particular code, as we have already displayed the answers, it will give you 1, 7, 6 and -6, 10 and 2. So this is how the bitwise operator will work. Then our next final operator is ternary operator. So ternary operator in Java, it is like a 3-operand operator which we will be used to evaluate a Boolean condition, and we will be choosing one of two values based on that particular condition. So this is the syntax. If the condition, it will check the condition whether the value is true or false. So it is just like a control flow operator. that will evaluate the Boolean expression. That means the conditions and returns either one of two values depending on whether the condition is true or false. So it is a shorthand replacement for false for if else statements that will return a value. So how it will work internally? So internally, it will work. The condition must evaluate to true or false. For example, if the condition is true, the expression before this colon is selected. That means if this condition is true, this particular expression is selected. If the condition is false, the expression which is after the colon, this is get selected. So this entire ternary expression will return a single value. It is an expression. This particular thing is an expression and it is not a statement. So this entire expression will produce us a only single value. It can be either true or false. So it is just like asking, if the condition is true, give me this value. Otherwise, give me that value. For example, as we discussed, the eligibility, voting eligibility, if the age of a person is 18 and you are going to check whether he or she is eligible or not eligible. For example, I am going to declare the age of a particular person and I am going to declare the result. This particular result contains the ternary operator giving the condition age should be greater than or equal to 18 and then check for eligible. If it is true, eligible. If it is false, not eligible to vote. So it will just check the condition. Here what we will get the output as eligible because I have given the age as 18. For suppose if I given age as 11, it is going to produce you the output as not eligible. So it is just a replacement of if else conditions. So we are going to check if the particular person got this many marks, he or she is pass. If got less marks, then it is fail. So just it will always return a value. So this make it useful for inline decisions or assigning values, returning values from functions, compact logic in printing statements. So it will choose between two expressions. Okay, so these are the common uses of ternary operators. The common uses like it will assign values quickly and prevent division by zero, and it will print the results and it will select based on the boolean. Okay, so these are the few operators. The first one is ternary operator or conditional operator. So we will be using three operators. It will evaluate a condition returns one of the two values based on true or false. This is the most commonly used operator. So it will return maximum of A and B. And in next operator is true condition selector. It will select only the true part. Here also we will use three operands. It will separate the conditions from value to return if the condition is true. Here I am going to check whether the age is greater than or 18. It will produce 1 if the age is greater than or equal to 18. And when colon is the false condition sector, that means it will separate true values from the false values. When you are going to divide the variable, if it produces 0, it could be either even or odd. So these are the operators. So this is our ternary example. So we already discussed this, the eligibility of a person. So we have given a condition, short form of an if else condition. So if the condition is true, it will pick the first value. So if it will pick this particular value, and if it is false, this will pick the second value. It will help the reduce the multiple lines of if else condition into one single line. So initially I have declared the age as 20 and the particular person age is 20, and I have declared the string condition. That means it will check whether the person age is greater than 18 or equal. If this, so the condition is true. If the age is 20, I have given the condition as 18 and initially I have declared the value as 20. So here the condition will become true because 20 is greater than 18, and it will check true or false statements. When this condition is true, the person is eligible to vote. And if this particular condition become false and the person is not eligible to vote, in our case it is going to produce the person is eligible to vote. So this is a quick short form of the if else condition. Let's execute it. So it will produce eligible to vote because our initial age is 20, and here we are checking whether our condition is true or false. Our age is greater than the given value, given condition value. So it is going to print the true statement which is eligible to vote. These are all the our important operators in Java. So these are few practice programs that which I gave you to uh, work on it. So these are the 5 programs. First I gave to find the quotient and remainder, then the increment and decrement values, and swapping the values using the operators, and finding the large number, and calculating the answers of this particular conditions. Now let's discuss about the conditional statements. So conditional statements are nothing but that will allow a program to take the decisions. So when you are trying to check a condition whether it is true or false statements and execute a specific code, we will use the conditional statements depending on the result. So Java will support different type of conditional statements such as if else if ladder, nested if, and switch case. Let's see all of these in detail. So what exactly is if statement? So the overview of if statement is, so it will check a condition. Whether the condition is true, the program runs the one block of the code. If it's false, it can optionally run a different block. So it is the simplest decision making construct in programming. Like it will make the program branch. So if we see this image, so it is a classic decision flowchart for a single if. So it will start, that means the program begins, and if, which is in the diagonal statement. So the condition is evaluated here. So this is the decision point. One outgoing arrow labeled true. If the condition evaluates to true, it will follow this particular path, and another outgoing arrow labeled as false. So if it's false, this will follow this particular path. So for example, so if I see the statement 2 here, so it is on the true branch, so which is labeled just below the 2 branch. So this code will execute when the condition is true. And if we see the statement 1, this is on the false branch. So this particular code is executed when this particular if condition is false. So if condition is mainly depend on this particular if block, whether it will check the condition is true or false. So both branches converges to the stop stop block. So that means the flow continues after the decision. If the condition is true, it will execute the second statement and it will stop the code. And if it is false, it will execute the first statement and it will reach to the stop. So the particular key idea is the program will always reaches the if node and then chooses between two mutually exclusive branches. Only one branch will run per evaluation. After the branch finishes, this particular flow region, it will rejoins and continues. So using this diagram, whenever you want to show, you can make a choice, do one thing if yes and do different thing if no, then continue. So this is the proper definition. So if statement is used to run only when a condition is true. So this is the syntax of the if statement. We will be mentioning our condition inside the if block, and this particular code will be executed if this block is true. And after this, we will be stating another statement. If this condition is false, it will get out of this loop and execute this particular statement. So if I see the example here, I have declared int age equal to 18, and I have given my condition age greater than or equal to 18. So here our condition is getting validated because we have declared 18 and our condition is also true. So it will print the statement which is inside the if block, that is you are an adult. So if suppose if I given the condition age should be greater than 21, so this particular block will not execute this statement. If there is something out of this block, it will execute this particular statement. So this is the one of the real-time example. So let's discuss it line by line. So it is demonstrated a if check for a discount. So here we have declared the class statement, the if state example. So this is a public class. A Java program code like lives inside these particular classes. So public means we know that it is accessible for everyone. And then we have declared our main method, which is the entry point. When you run this particular class, the JVM start executing the code whatever present inside this method. So here I have declared the two integer variables and initialized the value. So purchase amount holds the total value of customer purchase. So whatever the customer purchased, that amount it will hold, that is the 1200, and discount limit is the threshold required to get a discount. So here we have given discount of 1000 rupees. So here these are the printout statements. So these are like comment describe intent, which will be helpful for the reader. So here I have declared that we are executing on a shopping app, and it will display your total purchase and it will concatenate the purchase amount. So these two lines print on the console. So it will show the header line shopping app and then the user purchase amount. We know that the plus will concatenate the integer purchase amount to the string. Java converts the integer to a string in concatenation. So if we see this particular, here is our main if condition. So what we have stated here, the purchase amount should be greater than or equal to the discount limit. Whatever the user made purchase, his total amount should be greater than the discount limit. So it is a Boolean expression that tests if the purchase amount is greater than or equal to the discount limit. If this particular condition evaluates to true, the body inside this particular if block will execute. That means this print statement will get executed. For suppose if this condition evaluated to false, this block will get skipped. This particular block will get skipped and it will execution will continue after the block. That means it will execute this line automatically. So the body prints a congratulation message if the customer is eligible for the discount. If here you have to make note that there is no else here. So when the customer is not eligible, nothing special is printed for that case. So it will directly print, it will go out of the block and print thank you for shopping with us. So this is a closing message regardless of the eligibility. So the main ends the and main will end here and the program will get stop. So what happens with the number now? So the our purchase amount is 1200. So and the condition, the discount limit we have given is 1000. So our condition is getting satisfied. So the customer purchase amount is greater than the discount limit. So this condition is true. So it is going to print the statement which is within the if block. That means congratulations, you are eligible for the festival discount. So this is what this example describes. And most importantly, why and when we use the if conditions or if statements. So use if whenever your program behavior must change depending on some condition. Some common examples like your input validation, checking whether the user input is valid, otherwise shows an error. Or feature gating, like running code only if a flag or permission is set. Or threshold checks like discount eligibility, that is what we have seen now, and grade cutoffs or alerts for high temperatures. So in all these cases we will be using the if statements. And why we need to use if? So it will make the code dynamic and it will react to runtime data. It keeps the logic explicit and readable, and it will enable validation, security decisions, and also the branching flow. So this is where and why you have to use the uh, if statement. And next, coming to our if else statement. So the overview of if else is like it will test a condition and always chooses one of the two paths. So that means if the branch when condition is true, or it will go to the else branch when the condition is false. So it is basically either or decision structure in programming. So if we see this example, flowchart diagram, so the program will starts with begin. So here with the start the program will begin, and this is the condition that we will be giving. A boolean expression is evaluated in this condition. It can, this condition can be either true or false. If it is true, it will follow this arrow, and body of green, which is in the green box, it will get executed when the condition is true. And after executing the if body, the flow will proceed to the end. And if, for suppose, if this particular condition is false, it will follow this arrow, and the execution, it will lead to the body of else, which is in the red box. So this is get executed when your condition is false. So after executing the else body, the flow will also proceed to the end. Same like if we have seen earlier, if the condition is true, if it will execute the statement 2. If it is false, it will execute the statement 1, and both will reach to an end, that is nothing but stop or end. Same wise here, instead of taking only one if condition, we are taking two. That is, one is the if part and another one is the else part. So if your condition is true, it will execute the if block. If your condition is false, it will execute the else block. Same like statement 1 and statement 2. Once it is finished, the end, that means the both branches converge and program continues. So the key points here are exactly one of the two bodies execute per evaluation. So this makes behavior deterministic based on the condition. So using this diagram, whenever you need a single decision with two exclusive outcomes, you can go with if else condition. And if we see the definition, it will run one block if the condition is true, another if false. So if it how may if we are writing conditions in two blocks, for suppose this is the syntax, we will be giving our if condition here and else condition here. If the condition is true, it will execute this statement. If the condition is false, it will execute this particular statement. So it is going to execute only one block based on the condition whether true or false. So if we see this example, I have declared the n value as 5, and we are going to check whether it is an even number or odd. So if we do that, n is not divisible by 2 and it will not lead to 0. So this condition will get false and it is going to print the else block statement, that is the odd number. So this is one real-time example. So we have declared the class name as if else example, and we have declared our main method. The same, this is an example of withdrawing the amount from the bank. So initially I have declared the value as 5000. That is, my current account balance is 5000, and I am trying to withdraw the amount 7000. So here we are going to print the statement bank withdrawal, and whenever attempt to withdraw, it will concatenate the withdraw amount. Here we have declared our if and else conditions. So it is checking the condition that I have provided is the withdrawal amount should be less than the account balance. So here I have initialized the account balance as 5000 and withdrawal amount is 7000. So this particular condition, that means the 7000 should be less than the 5000, which is our condition is false. So it is not going to print the statement which is inside the withdrawal statement, that is withdrawal successful or the remaining balance. It is not going to print this statement. So it is directly going to the else block, and it is going to print withdrawal failed, and it will show the insufficient balance. So if suppose if I have given the value withdrawal amount as 4000, then our condition is going to true, and it will display withdrawal is successful, and it will show the remaining balance. That means from if we deduct the amount, so it is going to be 1000 is your remaining balance, and it is going to print here. So this is how we are going to use if else. And when we will use if else condition, like behavior must differ in two mutually exclusive ways. Either it should be success or failure, or allowed or denied. In such cases, we will be using the if else condition. So you must validate inputs and either proceed or reject, or you want to present different messages or compute different results based on some runtime condition. So in real time situations, if we say, we will be using this for login checking whether it is successful or failed, or payment approval whether it is approved versus insufficient balance, and in temperature cases also. So, and why we are going with if else conditions? So, it's explicit and easy to read. That means it is going to execute only one block. That means only one branch. So, it will help safely guard conditions that should only run after certain conditions. So, it will makes the intent clear. If this is true, do this particular block. If otherwise, go to the next block. So, this is what the if else condition is doing. And our next conditional statement is if else if ladder. That means it will check the top to bottom, and it will execute the first matching branch. That means it's used when you need to choose one outcome from many ordered possibilities, uh, and also only the first true condition will get run. If none match, the else statement will get executed. So if we see this flow chart, so the start will evaluate the condition 1, and if this condition is true, it will follow the true arrow and it will reach to the statement 1, and then it will direct execute this particular statement and it will reach to end. If this condition 1 is false, then it will follow to the false arrow and it is going to down to the condition 2. Again, here it is going to check whether this condition 2 is true or false. If this condition 2 is true, it is going to execute the statement 2 and then it will reach to the end. If this particular condition 2 is false, again it will go down and execute the statement 3 and it will reach to the end. So, the conditions are checked in order. It is not they are going to check the condition 2 first and then condition 1. The order will follow in sequence. The first condition will get evaluates to true, determines the path. Exactly one statement block is executed. Or the final else block, if none of these get matched, the final else block will get executed. So this is ideal for mutually exclusive ranges or the ordered rules. So if we see the definition, it used when there are multiple conditions, we will be using the if else if ladder. So this is the syntax that we are declaring the if condition, then else if, and then else if condition 2, condition 3, and then the else block. It will check which condition is getting matched with our requirement. If none of these conditions matched, then directly the else block will get executed. So this is the simple example like marks grade. So initially I have declared marks as 72. So in the if block, I am going to declare the condition that marks should be greater than 90. If marks is greater than 90, then print me A grade. And in else if condition 2, I am going to declare it as marks should be greater than 75. Then provide me it is as B grade. And in third condition, I am declaring it should be greater than 60. Then provide C grade. So based on our conditions, so condition 1, condition 2, condition 3, my value I have declared as 72. So it is it will not satisfy the first condition. It is not above 90, and even it is not satisfying the second condition. It is not even greater than 75. It is matching with the third condition, which is it should be greater than 60. So this particular person got the C grade. So if suppose I have given 59, so it is not even going to match the third condition. So all three conditions was not satisfied. Then it is directly going to print the else block statement, which is the particular person is failed. So this is how the if else if ladder works. So the same thing I have taken as a real time example. So university grade system. Initially I have declared as 82 and I have declared all my conditions. So it is going to fall under the second condition, which is greater than 80. So it is going to print the grade as A and very good. So this is how the if else if condition statement works. And our next conditional statement is nested if. So nested if is a great concept and it will explain everything clearly. So the runtime flow or when to use the nested if. So the basic definition is it is simply an if statement placed inside another if statement. So so it is used for hierarchical decisions. That means when a decision only makes sense after a previous decision is true. That means it is a hierarchical flow or dependent checks. So think of a lock with two tumblers. Like if the first number turns, do you check the second number? And then if the outer check fails, you never even try the inner one. So the same way, so it will start. For suppose it is getting started with the uh, program will get started, and there will be a one condition. It will check whether this condition is true or not. If this condition 1 is true, it will go to the condition B, which is inside this particular condition. So then inside that it will check whether the statements inside this are true or false. If true, it will execute this particular statement, and if it is false, it is going to execute this statement, and both of them will reach to the end. So here the key idea is the inner condition. That means this particular condition. So this condition is reached only if this outer condition is true. If this condition itself is false, it is not going to check whatever inside that particular block. So there are three different outcomes, like outer true, this should be true, and even this inner should be true. Or this can be true, but inner block can be false. Otherwise, the outer itself can be false. So these are the three particular cases. So this model hierarchical checks. So this here I have given the example as voter ID. So I have declared the age as 20, and it is going to check whether this particular person is eligible to vote or not. and I have given my if condition, the outer, this is the outer block. So it is going to check the outer block condition, age should be greater than 18. And if this particular condition satisfies, then it will go into the inner block. So I have declared 20, so it is greater than 18, so this condition is true. It is going to the inner if condition, which is has voter ID. We have declared voter ID as true, so even this condition is true, then it is going to print the statement you are eligible to vote. So if suppose if I declared this voter ID as false, then this particular condition is false, it is going out of the block. Or I have declared the age itself as 16. So first outer condition itself is false, then also it is going out of the block. So this is the use of nested if. Now let's see an real-time example. So it will check if a card is present or not, or then it will check the pin. Otherwise, it will ask for the card. So we have declared our class and we have declared our entry point. Then initially a Boolean variable that represents when the ATM detected a card. That means when the ATM, the card is inserted, if it is detected, it will display the true. So this true will simulate the user is inserted a card into the ATM. And then I have simulated user input. That means the pin the user will get typed. So the entered pin is 1234. And then the pin stored or expected by the system, that is getting stored in the correct pin variable. So even this I have declared as 1234. Then it is printing the statement ATM security system. And then here we have declared our if else nested if block. So we have if within the another if. So this block first outer loop if condition will check whether the card is inserted or not. So outer check is only if a card is present. Do we attempt pin verification? If card is inserted, if card inserted, this condition becomes false, then we can skip the inner check. That means we can skip this particular inner block and we can go to the else block directly. So if this condition is true, it is going to print card is detected and it is going inside the inner if block. Here again I have declared another condition. So the inner check will compare user entered pin with the correct one. So this is evaluated only because the card inserted was true. So this condition became true. That is why it is going to check the second condition. So if this condition also true, it is going to print the statement pin is correct and access is granted for you. If this particular condition is getting false, it is going to print the else condition in that block. That is, you have entered the incorrect pin and your access is denied. So finally, this will close the inner if loop, and then we are writing the another else block. This particular else block will get executed when this card inserted become false. That means this particular card inserted becomes false. It is directly going to execute the else statement. That means please enter your ATM card. Please insert your ATM card. So it will prompt user to insert card. And then we are closing the main method. So this is how the nested if will get executed. Then our next topic is switch statement. So switch will examine one value and then it will jump to the matching case label. So it is like a multi-way branch, cleaner than the else if else block when you compare the same variable to many constant variables. If no case matches, then the default will run. That means the if present, and it will break the statements without executing them into the next case. So if we see this particular flowchart, so start will evaluate the switch expression. That means this is the single value. So then the flow goes to a decision block that checks each case, that is going to check each and every case in labeled in an order. So first, if case A, that means this case matches, it is going to jump to the case A block. Or if case B matches, it is going to jump to case B block. The same way, condition 1, 2, 3. If none of them is matching, it will directly jump to the default block if it is present in our code. Then each case block run until either if it hits a break statement. So if this condition is true, it is going to print the statement 1, and if there is break over there, it is getting break and proceeds to the code after the switch. Again, it is going to check for condition 2, it will execute, it will break. So if this condition fails, it will go for condition 2. If that is fail, it will go for condition 3. If whichever case will get match, it is going to execute that particular statements inside that cases. And if they see the break statement and they are going to end, they will just below the switch case, it will going to exit that particular block. So after block, the code is going to exit. So one expression is tested against several constants in the switch statement. So exactly one case code typically executes unless you intentionally fall through. So default serve as a fallback, because if no case matches, it is going to execute the default statement. So this is the definition. It is used when you need to compare a single variable with multiple values. So switch statement is going to support integer, character, string, byte and short enum. So the syntax will be in this way. So switch, we will be declaring only one value, and that value is going to check which case is getting matched with my switch value. If none of these matches, it will go to the default statement. So here I have given my switch value is 3. So it is going to check the day. Switch I have given day, that means 3. It will check which case is getting matched. Case 1, case 2, case 3, and this will get matched with the case 3, and it will print Wednesday and it will get break and go out of the loop. So this is the real-time example. So mobile recharge plan. So initially the choice is a single value. So the switch will evaluate here 3 will simulate a user selecting the option 3. So that means the combo pack that user selected is option 3. So then it will print the statements mobile recharge plans and the selected option it will display. And this is the start of the switch block. So Java will evaluate the expression choice once and then searches for a matching case, which case will get match. So our first case is, it is checking this choice will get check with the case 1. That means it is going to check whether the choice is equal to case 1. So if this condition is true, it is going to jump to the execution here. That means here the statement is daily data pack activated and 1.5 GB per day. So this is the action for the case 1, and it will just break. That means stop execution of the switch and continues after the switch block without break, and execution would continue into the case 2. So if this particular condition, if the case 1 is getting matched, it will print this statement, and it is going to next line that we have break here, and it will just break. If in case we are not using break here, it is directly going to the case 2, and it is going to execute this statement, and then it will going to execute all the statements. So after in every case we have to declare the break condition. So the same wise it is going to check for case 2, case 3 and case 4. So when we reach to the case 3, it will check whether our choice is equal to case 3. So we have given our choice is 3 and it will get matched with the case 3. So here it will print this particular statement, combo pack activated. So data plus calls plus SMS. So action for case 3, because this program current selection is 3, and it will break. So it will prevent fall through into the this particular case 4. So, and case 4 will handles the SMS pack option, and default statement runs when no case matches. So a safety, this is like a safety net. So no break needed if, as if it is the last statement. So but you may include one for consistency. So this will print invalid option selected. So we have given our option as 3. So it is getting matched with the case 3 and it will print this particular statement, combo pack activated. So when we are going to use this switch statements, whenever you want to compare the same variable to many constant values, or the values represent discrete categories like menu choices, error codes, or you want clearer, more readable code than a long if else if chain. So, and use if else when the conditions are ranges or non constant expressions. So this is when we are going to use the switch statements. So now we are going to enter into the looping statements. So loops, when we will use loops, like whenever we want to repeat a block of code multiple times, we are going to use the looping statements. So Java is supporting so many loop statements like for loop, while, do while, for each, nested, infinite, and break and continue. So first let's discuss about the for loop. So for loop will it will run a block of code repeatedly, like while a condition stays true. So that means it has three parts in one line. That means it is going to initialize, then condition, and then update. So because the condition is checked before the body, it is an entry control loop. Or just think of for loop like a conveyor belt with a counter written on. So just like a counter written on a whiteboard, you set the counter, then check if it is in range, do the work for that counter, then change the counter and repeat it. So uh, this is what about for loop. If you are going to check this particular image, so for loop is, as I said, it is for initialization, then condition, and then for updation. So first initialization, it will happen only once. So if we see here, this is our first condition. So it will happen only once. And this sets the starting point. And then our condition 2. So this is our second condition. So it is checked before every loop run. So for example, if this condition is true, the loop will get continued. If this condition becomes false, the loop will stop iterating. And then our updation statement. So after every iteration, it is going to update the value. So that means the variable value is changed. Initially, we will be declaring one value for a variable, and then we will be using the after every updation, that variable value is getting changed. So then uh, outside the loop, so as I said, if this condition true, if this becomes true, it is going to execute the statement present inside the loop body will get executed. If this condition becomes false, it is going out of the loop. It will skip the loop body and go outside the loop and execute the statements whatever present outside the block. So this is what the loop statement. So it is a deterministic looping construct used to perform repeated execution of statements. So it will provide us a compact syntax that integrates, as I said, initialization. That means it will run once before everything, and condition evaluated before each iteration. If true, it will run the body. If false, it will exit the loop. And update, it will run after the body. That means incrementation. Then jump will go back to the evaluation condition again. So this is the syntax. As we seen in the flowchart, first we will be initializing the value, then we will be giving condition, and then we will be incrementing the variable. So if we see this particular example, here I am going to print the numbers from 1 to 5. So for that, initially I have initialized the value as integer I as 1. So it is executed. So now I is 1. Then I have given condition as I should be less than or equal to 5, and then I have given the incrementation. So first when it is iterated, now our I is 1. So it will check the condition, that is whether I is less than or equal to 5. So 1 is less than or equal to 5, then this condition is true. It will enter into the body. That means it is going to enter into this particular block. It is going to print the print SOUT statement. That is, here it is asking to print the I value. That means what is our I currently here? I is 1. So it is going to print the output as 1. Now, then it will update the step. Later we have the updation. That means it will just increment the I value. Now our I is 1. It is going to become the 2. So this is our iteration 1. Then in iteration 2, now our I is incremented. That means I value is 2. Again it will check the condition whether the 2 is less than or equal to 5. This condition is true. So it is going to print the output as 2. That means it will enter inside the block and it will display as I. I is nothing but 2. So it will give output as 2. Again in iteration 3, again this updation will go back to the condition block. Now this will get incremented to 3. So now our I will become 3. It will check again 3 is less than or equal to 5. Even this condition is true, and it will go inside the block and it will print the I value. Now our I value is 3. Once it is printed, again it will go back to updation. It will increment the value to 4 now. So now it is running the iteration 4. I value is 4, and it will check whether the 4 is less than or equal to 5. Condition is true. Then it is going to enter into the block and it will give output as 4, because here we are printing I. Then our last iteration. So now I will get incremented to 5. It will check whether the condition is true. So 5 less than or equal to 5. Still it is true. Then it is going inside the block and it will print the I value, that is nothing but 5. Again it will go back to updation. Now I will become 6. So in our next iteration, I is becoming 6, and again we will check condition whether 6 is less than or equal to 5. Here our condition will become false. So then it will come out of the loop. So this is how iteration happens in the for loop. So first we will be declaring one value, then we will be checking the condition whether it is true or not. If it is true, it is going to execute the statement inside the block, and then again it is going back to increment the value. And then again after incrementing, it will check the condition whether it is true or not. Again it will print the block. So this repetition will continue until this condition become false. So once this condition becomes false, it is going to come out of the loop. So the key points should remember here is condition is checked before every body execution. So update happens after the body always, except when you break. So when condition become false, the loop will stop and once when I will be 6 after the loop finishes, it will get stop uh, executing. So this is our real time example like grocery bill. So here this loop is using an array index to visit each element. As of now we haven't entered into the array concept, but still here just remember array is something, it is going to store a collection of elements. So when we declare the array, we are going to use the curly braces. Just remember as of now this part. So we have set up our item prices. So I have declared the item prices and then I have initialized my total to 0 initially. So currently my total is 0. And then it is going to print this particular statement grocery bill, and it is just for separation. And then here we are going to see our iteration. That means here I have declared my for loop block. So which is nothing but I have initialized my I value as 0, and then here I have given condition this particular I value should be less than the item prices dot length. That means what is the length of our item prices? That means the count of the prices or the count of the array. So when I have declared the 5 elements 1, 2, 3, 4, 5. So the count is 5. That means it is asking I should be less than 5. So that is the condition I have given, and then the incrementation. So now it is going to perform the iteration. So if we see, so our first iteration will be, it will check the condition. That means I is less than 5 or not. So initially I have given my I value as 0. So it is going to check 0 is less than or equal to 5. So remember that item price length is 5 here. So it will check the condition I less than or equal to 5. This condition is true and it is going to enter inside the block. That means it will enter to this place and it will print the item. That means here what is I plus 1? That means I is nothing but here just we are incrementing. So initially our I value is 0. That means it is going to add 0 plus 1, which will become 1. So it will print item and it will concatenate item 1. That means this line is going to print item 1, and then we have concatenated again price, that is item price, and we have declared rupees. And here we are going to concatenate item prices of 1. So whenever we used this square bracket of 1, this is nothing but we are going to indexing the value. So this concept we will discuss later, but as of now, whenever we want to retrieve the value from the array, we are going to use the index value. That means I have given item prices of I. That means what is our I value currently? Our I value is 1. So it is going to fetch the value 1, element 1. So which is nothing but 40. So it is going to print 40 here. That means item 1 price is 40. So hope you understood. When you want to retrieve the value, we will be going to follow the indexing pattern. So then next coming to the second line in the block. So here we are adding this particular value to our total amount. So if you remember, initially our total value is 0. So I have declared total as 0. So now our item prices of I, that means what we got here when we retrieve the value, we got 40. So that means, so item prices value is 40 now. So here this is 40. So total is getting stored as 40. That means total is get updated to 40 now. And it again, it will go back to the condition part. It will reach to condition again in iteration 2. So in iteration 1, it we got first 40 in first line, and in second line our total is nothing but total is also increased to 40. And then in second iteration, now our I value is incremented. So uh, I became 1 here. So initially our I value is 0. Now I will become 1. So again it will check the condition whether I is less than or equal to 5. Again here it will become true and it will go inside the block. Now it will, here I is 1. That means it is incrementing 1 plus 1, which is nothing but 2. So it is going to print the item 2 price. And here it is going to retrieve the item of 2. So that means the second value, which is nothing but 25. So here it is going to print the price 25. And now the total is 1. Sorry. Initially, our total value in the previous iteration, it became 40. Now it is getting increased. That means 40 plus, now our current price is 25. So 40 plus 25 will become 65. Now the total became 65. So here we have added 40 to the initial value. So it became 40. So first it will print the item price 25 and then total will become 65 in the second iteration. The same way in third iteration, again it will check the condition. Again it will go back to the condition and it will increment. First it will increment, the value will increment to 2 now and it will check condition whether 2 is less than or equal to, less than 5. Then the condition is true. It is going inside and now it is trying to print the third price and it is fetching the third element here, which is nothing but the 60. So the current price is 60 and in total initially we have 65 and we are adding 60 to the current value. It will become 125. So the price is 60 and the total amount is 125 in the third iteration. Then coming to fourth iteration, again it will go back and it will increment the value to 3. So now I is 3 and it will checking whether the condition is true or not. It is true. Now it will print the fourth element and it will retrieve the fourth value here, which is nothing but 10. So the price is 10 and it is getting stored. Initially, uh, the third value is 125 and we are adding the current value, current price, that is 10, which is nothing but 135. So in third iteration, we got price value as 10 and iteration value as 135 and again it will increment. So now the incrementation will become 4. It will check the condition whether the 4 is less than or equal to 5. Again the condition is true. Again it will print the fifth item price, which is, it is going to retrieve the fifth element, that is our 30. So now our current value is, total price is 135 and we are adding the current price, which is 30, and 135 plus 30 will become 165. So in fifth iteration, we got our price value as 30 and total price as 165. Again, it will go back to updation. Now it will increment to 5. So when we reach to fifth iteration, here our I became 5 and it will check the condition whether 5 less than or equal to 5. This will become false. Now it will go out of this for loop block and it will print total amount directly, which we got 165. So final amount is 165. So this is how the iteration happens in the for loop. Hope you got an idea how to iterate each loop and how to check the condition before entering into the body and how to uh, update the body after executing. So our next topic is while loop. So while loop is like it will repeatedly check a condition first and then runs the body only if that condition is true. It is an entry condition control loop. Like if the condition is false at very start, the body will never run. So if we see this particular image, so while loop, initially we have started, so the program will get when the program reaches the while statement, after starting the program, when it reaches to the while condition, first the condition is checked, and if this particular condition is false, that means this, if this become false, this particular loop, that means whatever it is inside the while, it is never going to execute. Not even once, it will never run the program. If this particular condition is true, then it is going inside the block and it will get executed whatever the statements we have written inside the body. If it is false, it is not going to execute. It will skip the loop and it will go outside the body. And we have given the updation. So this is what the loop will control the variable. So this step is mandatory, otherwise the loop will run forever. If you are not going to give the updation, so the condition will always satisfy and it is going to run infinity times. So always go back to the condition, check the condition. If it is true, then only repeat the body. If it is false, exit the loop. Then outside the loop, the program will continue with the code after the loop condition. So it is same like the for loop. There we are initializing the value, and then we are giving the condition, and then we are giving the incrementation. There we are doing everything in one block. That means one method, we are writing everything in for loop itself. Here we are just breaking down. Before this, we will be giving one initialization. Then here we are giving that same condition. Then here we are going to give the incrementation. We are just going to separate in the while block. So as I said, it is an entry control iterative loop in Java. So it will repeat the block of code. It is going to execute repeatedly as long as the given Boolean condition remains true. So before every iteration, the condition is evaluated. If the condition is false at the very beginning, so the loop is not going to execute even once. So this is what the syntax of the while loop. So if we see this particular example, same like earlier. So it is going to check the condition. Initialization I have declared here, then I have given condition, then I have given incrementation. Same like for loop, just here we are writing them in separate manner. So if the condition is true, same as we seen in the for loop, even this is going to follow the same pattern of iteration. So as long as the I reaches to 6, so here the condition will get false. So it is going to become false and it will come out of the loop. So as long as the condition is true, it is going to execute inside the block. That means it is going to print 1, 2, 3, 4, 5. So if you have followed the for loop, you will be knowing how to perform the iteration. So just try once by your own here. So how to follow the iteration block for each condition. So this is one of the real-time example. Like even here I have taken the ATM machine logging. So here one more important thing is I have imported the scanner library. So we know that scanner is used to read the user input. So in the scenario A, it is going to check the two scenarios whether the pin is correct, and uh, then if it is correct, it is going to print it is as login successful. Mm, so here I have declared my class name as while loop ATM. Then I have started the main method. So I have used the scanner, uh, and then initially I have given the correct pin I have set to 1, 2, 3, 4, and the entered pin is 0. So it is going to print the statement ATM machine. It is going to check whether the entered pin is not equal to the correct pin. When this is nothing but initialized values. This is our while block. Here I have given a condition, the entered pin should not match with the correct pin. So I have used the not equal to operator. So our entered pin I have given 0 and the correct pin is 1, 2, 3, 4. They both are not equal. So the condition satisfies. That means it became true. It is going to execute the body inside the block. So it will ask the user enter the pin, and I have again declared the variable entered pin equal to sc dot next int. So this I have told the next int method is used to read the integer value from the user input. So whatever the user is going to enter the value, that integer it is going to read. So for suppose now I have entered the correct value 1, 2, 3, 4. So it will become true. So it will print the statement login successful. So this is how the while loop will work. So the next loop is do while loop. So do while it is like it will always run its body at least once. So then it will check the loop condition after the body. If the condition is true, it will repeat. Otherwise, if the condition is false, it will stop. So use the do while when you want the action to happen first. That means the first you want whenever you want it should execute the action, and then like it has to show the for example, if we take the scenarios like menu display or prompt it once, in that cases you can go with do while. That means it has to execute at least once, then it has to check for the condition. So then only it will repeat while the some condition holds. So if we see this particular image, so as I said, it will check. So the do will start. It will going to perform this, it is going to execute the statements once. Then it will check, update it. Then it will check the condition, whether it is true or false. If the condition is true, it will go back to the do statement again. If the condition is false, it is going out of the loop. So it is like exit control loop. So in Java, like while executes it the block of code at least once. So irrespective of the condition, because the condition is checked after executing the loop body. So this is the syntax of the do while loop. So even here also I have taken the same printing numbers example. So here I will just show the micro step iteration. I'll just skip the main part. So first in iteration 1, like it will enter uh, body runs before any condition check. So it will first pass, just it will enter the body and it will print the first value. Initially I have declared it as 1, and here it is going to print it 1 first. Then it will increment the value here. Now I will become 2. So now it will check the condition. So I, our value is 2. Then it is going to check whether the condition is true or false. So here the condition is true. Then because the condition is true, the loop will get repeat and it will jump back to the body. Again it will go here. Again in iteration 2. So this is the first iteration. In iteration 2, it is going to print the value 2 because our I value is 2. It will print and again it will increment. Now it will become 3. Now it will check the condition again whether 3 is for less than 5. This condition is again true. Again it will go back to body. Now in third value, now our I is 3. It will increment to 4. Again it will check whether it is true. If it is true, again go back to body. Again in fourth, if our I is 4, it will get increment to 5. It will check whether the condition is true. It is true. Again body. Again in fifth iteration, it is 5. It is incremented to 6. So again here it will check whether 6 is uh, less than or equal to 5. Here this condition become false. So it will come out of the loop. So this is how the iteration happens in the do while loop. So here the main key idea is the body is executed first even if the starting value uh, even if the starting I already violated the condition. It will just first execute and you would still run the body once. So after the final body execution, I will become 6 here. So the condition check then failed and then loop will get end. So if you forget to update I here and it is going to create an infinite loop. So let's take an real example. So here I have taken the restaurant menu. So here also I have used the scanner. So the program first it will print once. So here is our do while block. It is first going to print the menu lines. So it is going to print all these restaurant menu, idli, dosa and exit and enter choice. So here I have given choice. So first program wait for the user input. User types for suppose user types 3 and hits the enter. Then this choice will become the 3. Whenever it reaches to here, it will ask for user to enter. When this become 3, the choice is going to hold this value as 3. So now it will print the statement like you selected option 3. So it will check the condition now. The condition I have given is the choice should not equal to value 3. So here our choice itself is 3. 3 is not equal to 3. Here condition become false. So since the condition became false, the loop will terminate and it will print directly the next statement. Thank you. Visit again. For suppose if I have given the choice as 2, then it is going to become true. That means 2 is not equal to 3. Then it will become true. Then it will print the statement you have selected dosa. So why I have given the condition 3 because in 3 I have make it as exit. So I don't want the user to select the exit option. So I have given the condition the choice should not be equal to 3. But in our case the user entered 3. So it is going out of the loop and it will execute. Thank you. Visit again. So this is how do while works. First, it will print the statements. Then it will check for the condition. So next is for each loop. So for each loop is like just the enhanced version of for loop. So it is one of the friendliest loop for beginners. Like for it will automatically visit each element of an array. Uh, if we see this image, so here I have given type variable. So that is nothing but it will collect. Uh, so it will begin the program first. The program will start running. Then the input array. the program takes an array as an input. So for suppose if you remember in the previous example, I have told array is nothing but the collection of elements it is going to store inside the square brackets. So here I have collected some set of numbers. Let's assume 10, 20, 30, 40. Then I have given the variable. So it is a variable is getting created to keep track of which element we are currently looking at. So to keep track of these values, we are going to create a variable. For suppose uh, I have created variable I and I have initialized it to 0. And block, so block is this is where some operation happens. So some few operations will happen on some particular current element. So whichever element we are looking, so on that element some operation will get performed. And last element is nothing but it is like a decision box. That means the program will check like am I currently looking at the last element of the array. So it is like it is asking. So like when it reaches to 40, it will ask like do am I currently looking for the last element of the array. So if that is yes, that means all elements, that means all these 10, 20, 30 are processed and the program is going to end. If this is no, if it is somewhere in 30 and if it is not reaching the last element, then it is no and it is going to move to the next element. So it will increase the index value and it will go to the next position in the array. So then again it will go back to block and it will repeat the whole process. So when it finally finished all element, then it is going to reach the end. So this program finishes after processing the entire array. So for loop is, as I said, it is a special iteration construct used to traverse arrays and collections sequentially without using an index variable. So it provides automatic iteration from the first element to the last element. So this is the syntax of the uh, for each loop statement. So if you see this small example, here I have collected elements of 10, 20, 30 into the array and then I am going to print each element one after the other. So if we see in iteration 1, the loop obtains the first element of the array. So the first value is 10. Then the loop assigns value to that loop variable, that is nothing but x. So the body runs, it will print the x value, that is 10, and it will reach to the end of the body. So this is the first iteration. In second iteration, again the loop will obtain the second element, that is value 20, and then it is going to assign to the variable x. Then it will print this 20, it will reach to end, and then again it will go to third iteration. Again now it will obtain the third element, this particular element, and going to assign to the variable. Then it will print it, then it will reach to end. So here all elements are visited. So finally printed the output in order, that means 10, 20 and 30. So x is like a copy of array element when the elements are primitives. So changing x inside the loop doesn't change the array. So here we are changing the x value, but it is not going to change inside the array. So if we see another example, so here I have given the list of employees. So array will hold any kind of elements, like it can be in string, numbers or anything, but it should be the homogeneous set of collections. It will not store like strings with numbers or any other data types. So the data type should be the homogeneous. That means same values should be there. If it is numbers, all data should be in number form. If it is strings, everything should be in string. So here I have created the list of employees and store it into the variable employees, and it will print the employee list. Here I have used my for each block where I have given the string employees, and it is going to print each employee in order. So in first iteration, it will refer to Rahul, which I have given here, and then it is going to assign to the variable emp. Here I have renamed the variable as emp. So the first iteration, emp is getting stored with Rahul. Then it is going to print this particular name, and then it will go to next position. Here again it will go refer to second person, which is nothing but Sneha, and then again it will print, then it will point to next position. In third iteration, the emp is getting stored with arrow, then it will again point to next position. In next iteration, emp is going to store the name Pooja, then it will point to next reference. In fifth position, it is going to store as Manish. And when it reach to the last element, it will come out of the block. So here it will get to know there are no more elements and the loop will get end. So emp will hold a reference to the string object. So you can call methods on emp. So for example, like emp, if you want to print the length, you can just call emp dot length. So it is going to give the length, which is nothing but 5. So you can also change the variable name. You can reassign them, like you can change the emp to x. So only changes the local loop variable reference. So it does not modify the array slot which I have created, only because strings are mutable anyway. We cannot change them once we have declared them. So this is what for each loop. So our next loop condition, looping statement is nested loop. So just like the nested if, it is just like a loop inside the another loop. For every single iteration of the outer loop, the inner loop run completely from start to finish. So that means the total number of inner executions should be matched with the both outer and inner iterations. So if you see the image, so it have started with the program will get begins, and the statements here, some initial code will run. For example, set some counter values, and it will go check first condition. This is the outer loop. This is outer loop, and the program will check the first condition. If it is false, it is going to execute the loop 1. If this condition is true, it is going inside the loop. So that means it will reach to the condition 2. So increment or decrement, or like after each round of outer loop, the loop variable is updated. So for that we will be using the increment or decrement. And in condition 2, again here it will check whether the condition is true or false. If it is true, so the statements inside that are getting executed, if this particular condition is blocked, it is going to end the inner loop, and then it will execute the statement. So in condition 1, this is our outer loop. If this condition is false, it is directly going to end the first loop, and it will execute the statements whichever present outside, and then it will stop the program. And this is our inner loop. The condition true is inner loop. If this condition is true, it is going to execute statement inside them. If this is false, it is going to end the loop 2, and it will execute the statements outside the body, and it will stop the program. So this is how the nested loop will work. So it is like a looping structure where one loop exists inside another. So the inner loop runs completely for each iteration of the outer loop. So this is the syntax, same like nested if. So this is the same pattern printing, numbers printing example, just we have seen earlier. It is going to print everything in order. So this is the nested loop. So this is something for uh, movie theater. I am going to book the seats, like checking the seats row wise. So this is our outer loop, outer for loop. So here I have declared the row as 1 and condition I have given row should be less than or equal to 3 and it should get increment. So outer loop, it will declare row starting at 1 and then condition means outer loop will run while this condition row is 1, 2, 3 until it is 1, 2, 3 it is going to execute. Then row plus plus it will increment the row. So in inner loop I have given loop runs seat from 1. It will start from 1 and it will go up to 5. And every time the loop advances, it will increment the seat. So inner loop body will print the current row and current seat numbers. This execute once for each combination of row and seat. So if we check the iteration, when the when outer iteration is 1. So when the row is 1, it will evaluate whether the row is less than or equal to 3. That means our condition first value is 1 and it is checking whether it is less than or equal to 3. It is true and it will enter the outer body and it will initialize the seat as 1 and inner row it is going to check whether the condition is true. So inside our seat is 1. Here it will check 1 less than or equal to 5. Here even this condition is true. So it will execute like it will update the value. It will execute this particular statement. Row, our current row is 1 and our seat value is 1. So it will execute this statement and again it will go back to increment the value. So now initially our seat value is 1 and it will get increment to 2. So in second iteration, but our row is still 1 and seat became 2. It will check the condition 2 less than or equal to 5. It is true and it is going to print. Now row is still 1, seat became 2. So again it will increment, it will become 3 now. So in third condition, still our row is 1, but seat became 3. It is getting checked, condition is true. So again it will go back, it will increment to 4 now. Now our row is 1 and seat is 4. Here also the condition satisfies. So 1 and 4. Again it will increment to 5. So in fifth, so here also the condition satisfies 1 and 5. It will increment to 6. Here when it becomes 6, the condition will get fail. So here it will go out. That means the first row is finished. So one is finished and now it will go back from here to here to increment the row value. Now our row will become 2. Again it will follow this entire process for 2. It will check what and all will come. Then again it will increment to 3. When here also, like just here it reaches 6, it get fail. When it reaches 4 here, it will get fail and it will come out of the nested for loop and end the loop block. So this is how the nested loop is going to work. So our next looping statement is infinite loop. So infinite loop is something that keeps on running forever or until the process is killed manually. So because it exits condition never becomes true, or there is no logic, there is no exit logic. So they are used intentionally for long running things like servers or listeners or background tasks. So it must be written carefully so they cannot be stopped. They should not waste our CPU time or handle exceptions. So if I see this image, this is something it is keep on going to execute forever. So whether it can be the statement, numbers, or any kind of data type value. So conceptually, we will be starting and evaluate the loop condition. If the condition is true, it is going inside the body and it will execute the work. Possibly it may wait or it may sleep for some time or it may get blocked, but it is going to repeat forever unless until an external event or code is um, getting inside and breaking out it. So it will stop only when process is terminated by external signal, or whenever you use code break statement or return statement or methods like system.exit inside the code. So this is the definition. It is never going to terminate. So because its condition will always become true and there is no update logic, so the loop will get continue. For suppose you have just declared while condition as true and you have given nothing inside the for loop. You are not given any initialization, condition or iteration, and this is going to print true continuously until unless you stop it manually. So this is one of the example that I have taken. Here I have given, as I said, I have given true and it is going to print this particular statement clock running. And inside this I have given the try catch blocks. So this we haven't discussed. These are like we use when we need to throw an exception. So this we will be seeing in our later sessions. So as of now here we have used try catch blocks. So try, we have given the thread should, that means it should take some break of 1000 seconds. 1000 I have given, that means 1 second. So when it is going to run the clock running, in between it will take 1 second delay. So it is going to stop for 1 second and again it will continue executing it. And if this is not possible, it is going to throw the exception and it will run out of the block. So here, like we are starting an infinite loop. That means I have given the true statement, which is always true. So control always enters the loop body. It is going to enter into this place and it will print a message clock running. So here I have given try. It will ask the current thread to pass for approximately 1000 milliseconds. That means like 1 second. So this will prevent the program for printing continuously and consuming 100% of our CPU. So and again I have given the catch block, so it will catch all the exceptions including the interrupted exception. So but it will swallow them silently, so just like a it will hide the problems. So this loop then iterates again and print, then again it will sleep, again it will catch the errors, again it will print. This process is keep on repeating, so there is no code after the loop. So the program ends only when the JVM is terminated from outside by using any some external method, that is system.exit. So or some break statement is added. So until unless this particular block statement is going to execute continuously. So this is what our infinite loop. And next is our break statement. So break statement is like something we know the name itself. It will immediately exit the uh, condition or immediately exit the block. So If you see this uh, flow chart, so break statement is the loop will get start, so the program will enter inside the loop. It can be either for loop, while loop, or do while, for each, anything, and it will check the conditional code. That means some condition executes inside this loop, so it will check the condition. Third thing, the program will check a condition whether if it is true or false. If it is true, it will continue the looping. If it is false, it will exit the loop manually. And the break check is inside the loop. The program checks, like it will ask like, should I stop the loop right now? So then it will get break. So if break condition is false, then the loop will uh, continues and go back to execute the conditional code again. And then finally it will exit the loop. The program exits the loop and continues with the next set of code. So this diagram shows how a loop can be stopped easily using break even if the main condition is still true. So break statement is nothing but a loop control statement, so that immediately terminates the nearest enclosing loop or switch block. So execution continues from the start statement after the loop or switch. So whenever you see the switch statement or loop, then this is going to execute. So if we see this particular example, so I have given some set of products. Even here I have created an array with the stationery items, pen, book, laptop, mouse. And then here I am going to search the element. I have declared the variable search and I am going to search the element laptop, which is in third position. So that means I have reassigned product to P variable, and it will check. Here is my if block. That means it will compare the current product P with laptop using dot equals. Because it is correct for strings, whenever we are working with strings, we are going to use the dot equals. Then if the product is found, it is going to print that particular product, and break, it is going to terminate immediately, exit the for loop, and no further products are needed to be checked. So after the loop ends, the program continues. Uh, but here we have nothing, so it is going to terminate the code. So for suppose in our first iteration, our first element is pen. So first the P is getting assigned to pen, and it will check whether the P is equal to laptop. So this condition becomes false, and then it is going to move to next element. Here it will check for book. So P is getting stored with book. So here search means here it is replaced with laptop. So this P is getting compared with this laptop. So our element is book. So book is equal to laptop. No. Here also the condition is failed. It is moving to next element. So now P is getting stored with laptop. So here P is laptop and even search element is laptop. So this condition is true, and it is going to print product found, that is nothing but laptop. And then the break statement is there. So it is going to stop searching. So we have found the element, no need to search the rest of the products. So it is going to terminate the loop. So this is how the break statement works. So next is continue statement. So continue statement is something that it will immediately stop the rest of the current loop iteration, and it will just proceed to the next iteration. So continue is something like it is going to skip the particular element. So it just skip the remaining statements for that iteration. So if you see this image, so we are starting the loop. So the program will enter the loop. So and it will check the condition. So If the condition is true, the loop will continue running. So, and program move downward inside the loop. If the condition is false, it is going to exit the loop. So the loop is going to stop completely and control goes outside the loop. So the condition is checked inside the loop, the program reaches a continue statement. Once the condition is checked and it is going to reach the continue statement, so this continue also has a condition. Uh, like now two cases can happen here. So if this continue condition is true, it goes left and back to top of the loop again. So that means code written after continue is skipped. That is not happening here. The loop jump immediately to recheck the condition, recheck the loop condition. So in simple words, skip the remaining code for this particular iteration and start the next round of loop. And there is also another case, if the condition is false, the program doesn't skip anything. It will execute code inside body of loop after continue statement. After finishing that code, again the loop goes back to check the main condition. So this is how the continue statement will work. So it is like a control statement that skip the remaining statements and moves directly to the next iteration. So this is one of the example that I have taken, and here also I have created an array storing the number of items. So if I see here, I have taken given the count of items. So initially I have declared item as I, and my if block is going to check whether the item is equal to 0. If it reached to 0, it is going to skip the damaged item is skipped. So this is the first item, that means it is 10, and it is going to check I. Here in first iteration it will become I equal to 10. So initially our I value is 10. So sorry, I equal to 0. So I value is 10. So 10 is not equal to 0. This is false. So it is going to next statement. False in the sense it will continue. Here the next item is 0 and 0 is getting equal to 0. Here it became true. So it will print damaged item skipped. So when this condition becomes true, it will go inside the block and it will. So in first iteration, when it is 10 equal to 0, condition became false. So it is going out of the block. It will print item is scanned and it will place item 1. That means it will print item scanned, that is 10. So in second case, it became true. So it will go inside the block and it will print damaged item skipped. So next line will come damaged item skipped, and it will the next statement is continue. That means it is going to skip this particular part and it is going to next position. That means in our third case 15 equal to 0, again this is false, then again it will print item scanned and that is 15, and it will go back to next position. Again here it is getting equal, this condition is true, again it will print damaged item skipped, and it is going to skip this particular thing. It will go to next block position. Then here 20 equal to 0, this is false, so it will skip this block. It will print the item scanned, now it is 20. So this is what the exact order will get when we try to print the code. So this is how the continue statement will work. So the difference between break and continue, if we use break here, when you reach to this particular statement, it will get break and it is not going to execute this particular statements. So this will not work. So if we use continue, it will just skip this part and it will continue with the remaining cases. So that is the difference between break and continue statement. So now we are going to discuss about the important topic, which is nothing but the functions or methods. So what exactly is function or method? So a method is a named block of code. It is also called as a function in many languages. So it is like a named block of code that does one particular task. So you write it once and then you will call it or use it whenever you need to perform that particular task. So it is like a reusable unit of code that may accept inputs which are nothing but parameters, and it will perform some operations, and optionally it will return a result. So why we mentioned optionally? So functions will basically may return the result, or in some situations it may not return the result. So that we will discuss later. So it will optionally returns a result. So in Java, methods belongs to classes. If we take an example like a coffee machine, think of coffee machine as a method. So consider it as a method. So when you press a button, it is nothing but you are calling the method, and you will be selecting some options like what is the quantity of sugar, quantity of milk, or the size of the cup. And so these are all considered as parameters. So these are, you are selecting the options which are nothing but parameters. And the machine will do some operation, that means like brewing coffee and all. So it is performing some task, and in return you will be receiving the coffee. If you are receiving the coffee, it is nothing but the return value. That means you have used the return statement in your code. So if you are not receiving anything, it is nothing but you are using a void method in your program. So we will discuss about return statement and void statements, void methods in later slides. So as of now, a function is like a reusable unit of code that will perform some operation and return a result optionally. So this is the syntax for the function or method. So access modifiers, we have three different types of access modifiers. One is the public, and the other one is private, and the third one is protected. So these are the access modifiers. And static we have already discussed, and here it is optional. So static means static methods belong to the class. So non-static methods will also be there. Non-static methods need, if we use non-static method, that needs an object. Okay, so then comes our return type. So the type returned by the method, whatever type you have given, it has to return the value in that particular type only. For example, if you have used int, string, or void, uh, for suppose if you used int or string, it is going to produce the result in the form of integer or string. If you are going to use void, it is not giving any result, nothing will get result here. Next comes our method name. So method name is nothing but the identifier. That means we will be declaring a method name. We know we will be following the identifier Java rules to create the method name. So follow the identifier rules. Then comes our parameter list. So parameter list is like comma separated typed parameters. So as I said, when you are using coffee machine, you will be using some parameters like milk, sugar, and the quantity of size. So here we will be using some parameters like integer a or string b. So these are nothing but the parameters. But parameters can also be empty. So you may declare parameters, you may not declare parameters in the method. And then this is our method body will be there, few statements will be there, and return statement. So return expression is optional. So return statement required if return type. If you need a result in return, then you have to declare the return statement. If you don't want any result, you just want to execute it, you don't want any result in return, then you can go for void statement. That we'll see more in detail. So this is about a brief description of the functions or methods. So Now let's see a simple example. So here I have declared my class method demo and I have declared my main method, and initially I have set my values integer a and b to 10 and 50, and then it and then I have declared a method. So the call the method add and store its return. So I have declared a method called add. So here what exactly is going to happen? So like when I have declared integer statement a and b as 10 and 5, then think of them as a variable. So a will be going to store the variable value 10 and b is going to store the value 5. So next we are calling the method add, which is nothing but add. So so this is the comment I have passed. So, and when this line calls the add method, when this particular line calls the add method, it will send, and we have passed some parameters which are nothing but a and b inside the method. So it sends a, that which is 10, and then it sends b which is 5. The add method adds these two numbers and returns the result. So it will add these two numbers. A is having 10 and B is having 5. So it is going to add these two numbers and return the result to the variable sum. So the particular value returned, that is nothing but 15. This return value is going to store into the variable sum. So what really happened when you call the method add? So 10 comma 5 will get called and it will return the value 15. So the sum is going to store the value 15. Correct? So I hope you are clear up to here. Then we are going to print the particular sum statement. So this is going to print the sum which you have got. And this is the end of this particular main method. So main method is get finished. Now we are declaring the method definition. So it is another comment. So a method is defined below. So I have declared a method as public static int add. So if you remember the syntax here, I have said we will be using the access modifier, which is nothing but here public. I have used the public access modifier. Then I have used the static, the second one I have declared it as static, and followed by the third one return type. So I have given the return type here integer, and then I have declared my method name, the fourth part. So here it is, I have declared add as my method name. Since we have declared add here, so I am going to declare the add. And then as I said, we will be giving the parameter list. So I have passed parameters int x and int y. So what exactly is happening here? So I have declared public, that means it can be used anywhere. And what exactly mean by static? So static can be called without creating an object. So the main use of static is we can call it without creating an object. And then comes our integer. So this method, I have declared the data type as integer. So this method will return an integer value as a result. So as I said, the data type should match with the result. And then add is our name of the method. Then I have passed the input parameters. So when we call this add method, that means initially we have passed parameters a and b. So here I have again given parameters like int x and y. So when you call add a comma b, this particular line, this x will get stored with 10 and y will get stored with 5. So this particular line, so this line adds the two numbers, that is nothing but our 10 plus 5. It will store the result 15, value 15 into the variable result. So now when you are returning the result, it is going to produce the output as 15. So this is what the return result. That means this line will send the value back to the place where the method was called. So the return value, where it will go? So this particular return value will go into the method call, where we have called the method, here we have called the method. So this result will get stored into sum. So now sum will become 15. So got it? So then we are going to end the add method, and then we are going to end our class method demo. So this is how the program flow will work. So initially we will be declaring values, and then we will be calling the method. So when the method calls, it will add the number and returns the result 15, that is going to store into the variable sum and then it will print the result as sum equal to 15. Got it? You may think that when this program started, so it is the actual flow, the top up to here. So you may think I have declared the values and then I have called here, and then automatically it is going to add the values here itself, and then it is going to produce the output. No, that is the wrong way. So here initially I have declared, this is our method call. So whenever you call this particular add method, that means you have declared this method block somewhere in our code. That is nothing but we have declared our method block here, which is nothing but with the name add. So whenever you come to this line, it is directly going into this block and getting executed with the statements whatever we have provided here. Then this particular value will then directly go and store into the sum. Then after that, this line will get executed. So this is how the flow will work. Now let's see about the return statement. So the return statement is used to send a value from a method back to the place where the method was called, as we seen in the earlier example. So whenever you are using the return statement, the main work of return statement is to send a value from that method back to the place where it has been called. So if you see in this particular example, here I have declared the return statement, and this statement is getting stored into the method where it has been called. So that is the main work of the return statement. And when it has sent the value successfully, immediately it is going to stop the execution of that method. Got it? So for example, think of return as like I have finished my work. So I'll be telling that my part of work is finished. I am telling to other person, take this result and go back. So someone has assigned me some work, I did that work, and again I am telling to the person, I have finished my work, take this result and go back. So this is how it will work. So here I have given a example. So imagine a method as a machine. So as I said, the coffee machine, you will be giving some inputs, that means nothing but parameters, then it will perform some operation and then it will give some output. So this is how it will work. So the output is sent using the return. So the basic syntax is just the return statement we are going to use. Return the value which you want to return. In the place of value, we can directly call some number. As a given examples here, you can directly call the value, or you can call some particular variable, or you can call the string. So if you see this image, as I said, for example, think of it as a coffee machine itself. So here I may pass the parameters. I have selected milk, sugar, and the amount of water it should add. Okay, and how much in degree it has to boil, or you know. So all these parameters I have, which and the most one more thing, parameters are also called as arguments. So parameters or arguments are same. So these are the arguments or parameters that I have been passing to the coffee machine. So these are like some operations, selection options which you are going to select, and then it is going to perform some operation, then it will return the value here. your output. It may become 1, 2, 3. So it is going to return the uh, values in return. That is nothing but the return statement which will come in the end. So if I see one example for the return statement, so the same, uh, here I have declared the class return example, and then I have declared my uh, I have declared the int add method, and I have passed the parameters int a and int b. And then here I am going to perform the operation. It is going to add the values and going to store it into the variable sum. And here it is going to return the sum value. So this is the method block that I have declared, and then I have declared my main method here. So here I am going to pass the parameters 10 and 20. So when I pass these values, immediately A is going to store the value 10 and B is going to store the value 20. So whenever you call this method, it is directly going to the method block where it has been defined. So then it will perform the sum and it is going to return the sum value. And this returned sum value is going to store into the place where it has been called. So then here the value will get stored. In our case, it is going to store it as 30. So then in the final, it is going to produce the result as 30. So this is how the return statement will work. So this is one of the important program that is related to the method. So here I have asked like write a method that will compute the compound interest with the given principal and annual rate and times component per year. And this is the basic formula that we will be using. And I have also given the condition that return should round to two decimal places. So what exactly we are doing here? So I have declared the class public class finance, and then uh, I have declared my method, which is nothing but compound interest. I have given my method name as compound interest, and in the place of access modifier, I have declared it as public, and then I have used static, so no object is required here. And the data type I have used here double, because in the question itself I have given that the return value should require two decimal values. So whenever we need decimal, we will automatically go with double data type. And then I have given the parameters like principal, annual rate percent, times per year and years. So here principal is nothing but the starting money, the initial money which you will be having. And then the annual rate percentage is nothing but yearly interest rate. Uh, for example, suppose imagine that you have initially 1,000 rupees with you. So annual rate percentage nothing but the yearly interest rate. So think it the yearly interest rate is 5%. And when it comes to times per year, it is nothing but how many times the interest is added in a year. So if it is about 12, so monthly it will add the interest, and if it is 4, and it is going to add quarterly. So years are nothing but how many years the money is invested. So this will describe how many years the money is invested. So this is we have given all the information that is required for compound interest from this method. So when coming to this particular line, I have declared a variable rate, and then so interest rate is given in percentage, but here the math doesn't work with percent. So we divide, initially I have said that I have given the 5 percentage. So here it will not work, so we are going to divide it by 100. So 5 will automatically get convert into 0.05 into the decimal value. So the now rate will become a usual number. Now coming to this part, so this is the part of the compound interest formula, which I have given here. So rate by times per year, that will tell interest per period, and we have given 1 plus rate by times per year. That means this 1 plus is nothing but the total growth factor. So this particular line will tell us how much money grows in one compounding period. So that we are going to store into the variable base. And then this particular line will calculate how many times compounding happen in total. So if 12 times per year, for 10 years. So per year, if it is happening 12 times, then for 10 years it is going to happen for 120 times. So the interest is applied 120 times. That we are going to store into the variable exponent. Then coming to this particular line. So here we are doing our using our math dot power. So the rise base. So base is rise to the power of exponent. Uh, we know that so exponent and base. So base is power of the exponent. So here we are going to find the compound interest formula. So we will multiply it with the principal amount. Then so here I have given the comment again. So as I said, it should round to 2 decimal values in the end. So now here this particular return statement, so it will tell the amount may have many decimal values. So money usually needs only 2 decimal places. So multiplying by 100, and then we are rounding it. Then again we are dividing it with 100. So this gives us a clean amount. When we calculate it, instead of a long digit number, it is going to give us a short number. So this will return the final value in the end. So this is end of our method block. So here I have declared my main method, and then here I am going to print the compound interest. So as I said, the initial amount I have taken it as 100, then 5% I have given the annual rate, and for 12 months I am going to take it, and year for 10 years. So when we do it, it is going to produce as the final result. So this line will print our the final compound interest value. So there are some rules for return statement. So whenever you are creating the method, the return type should must match with the return value, and every execution path must return a value. Then code after return is not allowed. So once the return statement is done, the code after that is not allowed. So return values can be literals, variable, expression, or the method call. So these are some rules of the return statement. And now the next topic is void method. So the basic meaning of void is nothing but so the general meaning in English of void is nothing. So when a method is declared as void, it means it will tell that this method will perform some work, but it will not send any value back. So that is the main motive of void. So it is like a return statement in Java that will indicate the method does not return any value to the caller. So this is the syntax. We'll just declare void instead of the data type in the method declaration. So we will use the void instead of our data types like int or string, anything. So this is the basic syntax. So why exactly we need voids? So not every task need a result to produce in the end. So some methods are used only to display output or to print messages or to update data or to perform some actions. So in such cases, returning a value is unnecessary. So in those situations, we will be declaring our method as void. So if we take a normal real life example, like uh, to differentiate between written and void. So if we take the general example, like for suppose you are calling a shop and asking what is the today's price. So they tell you the price back. This is nothing but like written statement. So they are returning something to you in written. So when it comes to void method, imagine like you will call the customer care and you will say that just activate my service. So in this situation they will do the work, but they don't send any value back. So it is like a void method. So this is how the return and void statements will work. So this is the basic example of void method. So first we have created a class with name void example, and then I have created a method called greet. So here I have declared it as static. So we can call this method directly without object, and here I have given void. So void means this method does not return anything, and greet is our method name. So this particular method job is only to print the message. That means this particular message, hello, welcome to Java, and it is not going to give any value back. And then it will come to the main method. Here I have called the particular method greet. It is going to this particular block and it will just print this message. That's it. Here no calculation is done, no value is getting result. Then this class will greet the method. So we are not storing anything because void means no return value. So this is about the void method. So this is the small difference like between written and void method. In case of written method, it is going to return us the value. In void method, it is not going to return us any value. And in written method, you can store the result, and in void method you no need to store any result. And written method is used for calculations and void method is used for performing some actions. If we take the examples, like when you are going to add square, here you are going to perform some calculation. Void method is used in such cases when you want to just display the message, print the statement, or show the content. In that cases we are going with void method. So the next important topic is arguments versus parameters. So in simple meaning, like parameters is nothing but uh, they are like placeholders written inside a method that will tell like it will ask like what kind of data this method needs to do its work. So they are like empty boxes waiting to receive the values. So it is like a variable declared in a method definition that receive data when the method is called. So if you see this example, I have declared the method greet and I have declared the parameter string name. So string, and I have declared the parameter name, and the data type I have given it as string. So whenever you are going to print, so name is parameter here. So it is declared when the method is defined. So it has no value until the method is called. Until this particular method is called, it doesn't have any value. So when you are printing this particular statement, it is going to print the statement hello with the name. So as of now, here I haven't declared any name. So it is not going to print any name in this place. So if I uh, declare or initialize the value for this particular name variable, then it is going to print the statement as hello Shravani. So this is like this is about parameters. Uh, So if you imagine in your daily life, you may be filling the blank forms. So there you will be seeing that just you will be having the parameters like they will be asking fill your name, age, details, everything. So that is nothing but parameters. So the form will define what is required, not the actual values. It is just going to give you the content what and all are required. So it is not going to store the actual values into that. So next, arguments. So arguments are the actual values that you will pass to a method when calling it. So it is nothing but they will fill the empty boxes. Here empty boxes are nothing but parameters. So they are going to fill the those empty boxes. So it is an actual value that is supplied to a method when it is invoked or when it is called. So in our previous example, I have declared the greet method, and when I am calling that particular greet method, here I have declared the value to the variable name. So when you call this particular method, it is going to print the statement. So this particular argument is passed to the parameter name. So as I said in the previous example, in the form we will be having the parameters just name, age. There you are going to fill your details. Those details or those filled values that you are going to write in the form are nothing but the arguments. So for example, if you take initially I am defining the method here. So I am going to uh, define a method that is with print sum, and I have declared it as static and void method, and I am going to pass the parameters. These are parameters. It is not having any actual value, but it is telling us that there will be two values with the name A and B of integer type, but it is not having the actual values. And then I am going to give a print statement system.out.println. Here it is going to perform the sum A plus B. So this is my method definition. Here I have declared my method. Now I am going to call my method. So this is method call. Whenever I am calling that particular method, which is nothing but the print sum, and I have passed two parameters. In that parameters, I am going to declare the values. So I have declared 10 and 20. So immediately when I call this particular method, it is going to this block and performing this operation, which is nothing but addition, and it is going to give the result 30. So this is how the execution flow will work. So the parameters will receive values only when the method is called. So when method will call, then only the parameters will get the values. Until then, they are just like a empty boxes. So here is again the simple example. So here I have declared the my method. This is method definition. So I have defined my method with the method name print age, and I have passed one parameter here, that is nothing but age. So age is the parameter, and I have given the data type as integer, and have declared the print statement. It is going to print my age. So here I have defined the method, and here I am calling the method. So this is method call. So here I have called that particular method, which is print age, and I have passed the argument. So this is nothing but argument. That means it is storing the actual value for the parameter. So 25 is my argument. Immediately when I call this argument, it is going to that particular method block and performing this statement. Here it is going to print age is 25. So this is how the parameters and arguments will work. So why actually we need parameters and arguments? So without them, methods would be fixed. You would need separate methods for every value. So if you have parameters and arguments in your code, one method works for many inputs and code can become reusable. So here are some differences between parameters and methods. So parameters, where we will define the parameters, we will be defining it in method definition. And arguments, we will be uh, declaring arguments in our method call. And the purpose of parameters, it will receive the data and arguments will send the data. When created at method declaration, we are going to create the parameters, and at method invocation, we are going to create the arguments. So for example, int x is a parameter. So x is parameter and phi is the actual value, which is nothing but argument. So scope of this, so parameters will be inside the method and it is inside the calling code. So these are the basic differences between the parameters and arguments. So again, this is one of the another example for the arguments and the parameters. So this example will help us understand like what really changes and what does not change when we pass the values to a method. So initially I have created a class with args params, and this name will tell us this example is about arguments and parameters. And then I have created a method. So here we are creating a method name change, and then I am passing the parameters int n and string builder sb. So here n, it is a number parameter, and sb, it is an object parameter. So here I am creating an object for this. So this is an object parameter, and this method will receive two things. So it is going to receive a number and an object. So we will discuss about class and objects in detail. So as of now, um whenever we are going to create object, we will be creating object for that particular class. So here we are going to create object for the string builder, and then I'm going to pass the value 100 to the parameter n. So here we are changing the value of n, but here n is just a copy of the original value. So this change can happens only inside the method. So the original number outside the method will not change. So it is just a copy, but the original number will not change outside the method. And now this line is very important. So SB is pointing to a string builder object which we have created, and the append method. So this modifies the same object. So the original object will get changed, and here I have declared it as world. So this particular change is only visible outside the method, and this is end of our main method, and then the method is finished. Now we are going back to our main method. So here I have created an integer variable a, and I am storing the value 5. So for the string builder, here we create a string builder object. So it contains hello, and s is pointing to this particular object hello. And whenever we are creating object, we will be using the new keyword. And then here now we are calling our method change, and I have declared the parameters a and s. So a will directly go to n and s will directly go to sb. So remember, Java will pass us copies of values but not the original values. So now let's see what happens after the method call. So here I am printing the value of A. A was not changed because initially we have given n equal to 100. It is only changed the local copy. So the output will be 5 here. And now we are printing the S. So the object was modified using append. So it becomes hello world. And this is end of our main method. And finally we have closed our class block. So what really happened in this example? So when I have declared int data type, when Java passes, it stored a copy of value and the original value doesn't changed in the result. And when an object is created, it stored the copy of reference. So object can change later. So imagine this as a situation in real life, like you give your age to a friend. So friend will changes it on paper, but your real age doesn't change. The same way, when you give your notebook to a friend writes inside it and notebook is changed. So this is how the arguments and parameters will work. And this is one of the scenario based question. So hotel booking. So I have give, given the method name calculate total cost for the room rate for nights and apply service charge and return me the final amount. So this will demonstrate the parameters, conditional logic and real world flow. So okay, let's discuss this hotel bill application program step by step. So first we created a class named hotel and this class will contain the logic related to the hotel cost calculation. So think of it as a box that will hold our hotel billing uh, code. Now let's write a method to calculate the total cost. So here we are creating a method called calculate total cost. So here I have declared the access modifier as public. So this can be used anywhere and static. So no object is required here. And I have given the data type as double because the method returns a decimal value. And now let's understand the inputs. Inputs are nothing but the parameters. So here room rate. So room rate is nothing but the cost of one night. For example, cost of one night is 3,500. So this is the room rate. And nights are nothing but number of nights a customer or a person is stayed in the hotel. So then include service charge. So here I have taken it as boolean because so service charge may be either true or false because in case of true add the service charge, in case of false don't add any service charge. And then coming to this particular line, so first we calculate the base cost, that means multiply the room rate by number of nights the customer has stayed in the hotel. So for example, in our case, the room rate is 3,500 and imagine the person stayed for 3 nights. Then it will become 3,500 into 3 nights, which is nothing but 10,500. So then this is the amount before any extra charges. So before adding any service charges, this is the original amount. Now we check a condition. That means if include service charge, if this is true, then we add the extra service charges, which is nothing but we are going to add the 12% service charges. That means here we added 12%, 1.12 means 100% plus 12%. So this will increase the total amount. So the hotel adds service charge to the original bill, which is nothing but original amount. So if this particular condition, if this if condition is false, this part is skipped. and it is directly going to the return statement. Now we round the amount to two decimal values. So here it is optional, but in most cases try to round your decimal values to two digits. Then money usually needs only two decimals. So multiply it and then multiply it with 100, round the value, and then again divide it with 100. So finally we return the final bill amount. This is end of our method block. So method is done. Now let's go to the main method. So here the program execution starts. So Java always starts from main method, and then here we are calling our method. So we call the method now. Here we have passed our parameters, the room rate and the number of nights the customer's user or the person stayed in the hotel, and declared our service charges whether include or not. In this case, charges is include. So I have declared the argument as true. So this method will calculate everything and returns the final amount. So that final amount we are going to store into the variable total. And then finally we print the bill on the screen. So the total is added to the message. So the print statement will print the total amount. And that's the end of our hotel class program. So that is how the flow will work. So it starts from main. So from here it will start, and then immediately it will check the calculate total cost method is called. So directly it will go to that particular method, and then it will calculate the base cost first. Then it will add service charges if needed, and then it will round the amount. Then finally it will print the bill. So wherever you have declared your method block, so JVM will always find the main method in your program. From there, the execution will start. In the main method, you are going to call your method function. Then only it will go to that particular method block and execute the statements over there. So this is how arguments and parameters will work. Now we are going to enter into the intermediate level of our Java codes. So here from now onwards we are going to write our programs using the classes and objects. So till now we have written programs using the variables everywhere, and we have used the functions and methods, and there is no proper structure for the program. So this will cause us the confusion and difficult to maintain and hard to reuse the code. So that is where the Java introduced OOPS concept, where it will organize the code the same way we think in our real lives. Now let's discuss separately what exactly mean by classes and objects. A class is like a simple plan or design or a blueprint. Class will only describe something. It doesn't create anything by itself. It is a user defined data type where it will act as a blueprint. It will group the variables, which can be data or the state, and also methods, and as a single logical unit. Mainly it contains variables and methods. Variable will store the data and methods will perform some action. A class will answer these type of questions like what data should this thing have and what actions can be performed. But a class cannot hold the real values until an object is created. For example, if we take a real life example, for suppose let's take a cake example. So cake recipe is a class. So imagine that cake recipe is a class, and the cake which made using those recipes are the objects. That means in the recipe we will be having the ingredients, and we will be it will tell us the steps to prepare the cake, but you cannot eat uh, the recipe. It is just the direction, or it will just define what and all this particular class is going to contain. But when it comes to the cake which we will be made by using those recipes, it has some taste and it will be having some weight, and it can be eaten. So the key understanding here is class is just the information, it is not a real thing. And for suppose if we take another example also, let's take house. So even house, when you are building house, so before building any house we will be making a blueprint, or you will be drawing the structure of that particular house on a paper, like how many rooms you should need and how many doors or windows or bathrooms. That is the blueprint or the design you are going to create. That is nothing but class. And the object is the actual house which you have constructed or built. That will be the object, and the information or details which you have prepared before, it is nothing but the class. So here I have given an example. Class, I have created a class with student, and it contains the variables string name and int marks. So this particular class will say that it says that a student has a name and a student has marks, but it is not telling you that whose name it is storing and what marks that particular student scored, because there is no object exist here. We just created a class. So the important thing you need to remember, class will not create a student. It only says if a student is created, this is how it should look. That means it should contain the name and it should contain the marks of the students. And class will not occupy any memory. It will not hold any real values. It will not occupy heap memory, or it is only located once, is one only loaded once by the JVM. Once you compile your code, the JVM will load the class. Only objects will occupy the memory, class will not occupy the memory. So if we see the example here, this is the class which I have told you. For example, here I have taken the car, or you can see vehicle example. So whenever before constructing or designing a vehicle, the developer will create a blueprint what and all it should require. So this is the blueprint of our car which they are going to develop. This is nothing but class. It will just tell how many tires it should have, how many seats it should contain, and where the steering should place, and all the details this class will provide. That is nothing but class. It will just provide the information. Now when it comes to object, an object is a real thing created using a class. When you create an object, a memory will be allocated to it, and variables will get the actual values, and methods can be used. Object is nothing but the real life entity usable. If you take the mobile example, so mobile model, it can be Redmi, Oppo, Vivo, iPhone. That model is nothing but the class, and your personal phone which you will be using daily, that is the object. That means your mobile has the contacts and it has photos and it has some apps, and your friend's phone will also be having, even he or she will be having the same model, but their mobile will contain the different data. Here you can have the same class, but you can create the different objects, different type of objects for the particular same class. So an object is a runtime instance of a class that occupies memory and represents a real world entity. When you create an object, as I said, memory will be allocated, variables will get values, and methods can be used. Here is the example. So here I have created a class with the class name employee, and it contains the ID, string name, and double salary. Here the class will store the details. For all these things, we will be going to create an object. So for this particular class employee, we will create an object. That particular object will have the information of the employees. It can be employee ID, it can be employee name, and the employee salary. If you see this example, so in before slide, we have given the blueprint of the class. So the same vehicle class contain the objects. So in class it will store the blueprint, and in object it will store different data. So vehicle can be, it can be a van, it can be an Audi car, it can be a sports car. So each of them having the different parameters. That is nothing but the object. It have the real values of those parameters that we have declared in our class block. What exactly happens when an object is created? So when Java sees the object, for suppose for this particular class employee, I am going to create an object employee. For suppose E1 is my object, then new employee. Whenever the Java sees this particular line, internally what Java does, it will allocate memory in heap and it will create space for the variables. In our case here ID, name and salary are our variables. Object becomes usable. Now here E1 is a real employee which contains the real values of these variables. And you can declare multiple objects for one particular class. Now I have created one object, and you can create many objects like E2, E3 for the same class employee. You use same class design and you can have the different data. That means one student form, there will be one form, but many students will fill that form. That is nothing but the creating multiple objects for one particular class. And each object, that means each particular E1, E2, E3, each particular object has its own data. Even the object came from same class, this now when you are calling the object, we will be calling it with E1.id or E1.name, E1.salary. And the same way you are going to call all these variables for E2 and E3 also. Here, this particular E1.id is different from this E2.id and E3.id. The same way name and salary. So everything is different from different objects. Each object has its own copy of instance variables. And why do we need classes and objects? If there are no classes and objects, code will be scattered everywhere and it is difficult to understand and difficult to maintain, and it is very difficult to reuse the code whenever we need again in our program. In the same way, if we use the classes and objects, and data plus behavior will be together, and there will be clear structure and easy to modify the variables and easy to use the reuse the code. So without classes, there will be so many chaos, and with classes, the system or the program will be organized. And this is the combined example of classes and object. Classes is just the design or the blueprint, and object will store the real information. Here are the few differences. Classes will contain the blueprint and object will contain the real thing. Classes will not, it doesn't contain any memory. Object will occupy the memory, and class will just define the structure and object will hold actual data. Class is just the logical part and object is the physical part. Class, it can have only, if it having one class, you can create many object for that particular class. So these are the few differences. The next topic is, now we have seen what is mean by classes and objects. Now we need to declare those objects. Let's understand how we will be declaring the objects and how we are going to use those objects in our code. So when we say creating an object, that means we mean that we are making the class come to life. As I said before, Before creating any object, class is just the information that will hold. Once you are creating the object, it means you are making this class come to the real life. That means it is holding the real data or values, and we are giving some memory to it, and it will make it reusable in the code. Before object creation, class exists only as a code, and there will be no memory for it variables and no real data. Once you create object, memory is allocated, variables will get some space in that memory, and objects become reusable. Object creation. This is how we will create the object. As I said in earlier slide, this line, this particular single line does a lot of work internally. What it will do internally? First thing, it will provide memory allocation in the heap. So we'll talk about heap and stack in later slides when it comes to variable topic. As of now, heap is a memory where it will store the values of our variables. So the first thing, internally the Java will do memory allocation. Java allocates memory in heap, and the space is reserved for the variables. For example, if I have variables like name and marks, so the space is allocated for these variables. Now the memories exist, but still the values are empty. But there will be default values provided for variables based on the data type. For suppose if it is int, it will default value will be 0, and if it is float, it will be 0 0.0. So there will be few default values if there are no value allocated to the variable. Instance variable. Instance variable initialization. Java automatically assign default values. As I said, in case of string, the default value will be null, and in case of integer, the default value is 0. In case of double or float, the default value will be 0 0.0, and in case of boolean, the default value we will use as false. Internally, the object looks like, initially we have given the memory allocation. Now at this particular stage, now the object look like name. It is a string, so it will hold the default value null, and marks are nothing but the values, integer values. It will hold the default value 0. This is how internally the object looks like as of now in this stage. And the next step it is going to do is constructor call. Here Java will automatically calls the constructor. Constructor prepares the object for use. Even if you don't write a constructor, Java will provide a default constructor to the program. Object creation is the process of allocating memory for a class instance at runtime, and initializing its instant variables and invoking its custom constructor using the new keyword. So this is the constructor here. Student is the constructor. Here we are setting the values using object. That means we are accessing the variables using object. Whenever you want to access the variable, you need to use that particular object which you want to access. In this case, s1.name, here it will store Ravi, the name Ravi in its object name. And when I call the s1.marks object and I have given the value 85, it is going to store this particular 85 in the object marks. And to read values from the object, Each object holds its own data. This will print the particular variable. Here in this case, it will print Ravi, and in this case, it will print the value 85. Each object will hold its own data. And as I said, multiple objects can be created for same class, but it will be having the different data. Here I have created student S1 and student S2. So there are two students, each will be having the different names for and different marks. Both will use the same class, but both will have the separate memory. Data does not mix. Here S1 dot name is not equal to S2 dot name. The same way S1 dot marks is also not equal to S2 dot marks. They will be having the separate memory to store into the heap. If we see this particular example, here I have combined the code for both classes and objects. First thing, I am creating a class called bank account. So think of the class like a blueprint or template. Just like a blueprint for house, this class tells what a bank account looks like. In the second step, I am declaring the variables, which are nothing but account number, account holder name, and the balance. Now, inside the class, I have declared some variables. These variables are called instance variables or the data members. We'll see about the different types of variables in later session. As of now, these are the instance variables, or it can also be called as data members. Here account number will store the account number, like it can be each person will be having their own account number, and in the account holder name it is going to store the name of the person, and in the balance it will show how much money is in the account. Each bank account object will have its own copy of these three variables. In the next step, I am creating a parameterized constructor. Even there are different types of constructor that we'll see later. So here I have used the parameterized constructor. Uh, a constructor will have the same name as the class. That means here our class name is bank account, even the constructor name is also bank account, and it will run automatically when an object is created. This the constructor is used to initialize the values. Since we are passing values, this is called a parameterized constructor. So we are passing some values in the uh, parameters. So this is called as parameterized constructor. In the next, we will be assigning values inside these constructor. Here I am taking the values that come from outside and then storing them inside the object. So when someone creates a bank account, this is account number goes into this particular variable, and name goes into the account holder name, and the balance will go into the balance variable. This is like filling a form when opening a bank account. In the next step, I am creating a method to display the details. Here I have used the method name as display details. This method, it does not return anything. Since I have used void, we have discussed whenever we use void as a method, it is not going to return anything. It will just display the data on the screen. Here in our case, it is going to display the account number and account holder name and the balance the account person is having. In the next step, I am having our main class. So the program execution will start here. This is the main class. The execution starts always from main method. And then in the next step, I am creating the objects. Here I have created my first bank account object, that is ACC1. What happens here? Whenever you created this object, memory is allocated and the constructor will automatically get called, and the values are passed to the parameterized constructor. Here my constructor is this and the values have been passed. The account number as 101 and the name of the person is Ravi and the balance he have is 5000. So account number 1 now represents the Ravi's bank account. The same way I am creating a second bank account. This one belongs to Sita with a balance of 10,000 rupees. Both objects are created from the same class but they have the different data. In the next step, here I am calling the display details method for each object separately. This particular account 1 display details will print the Ravi details and this particular object will print the Sita's details. Each object prints its own data, not the others. So this is how the classes and objects will work. Now let's execute it and see what will be the output. Whenever these particular methods have been called, it is going to display the, this will directly go to the method where it has been defined. That means to this step. Here, whenever this particular object is called, it is going to print the account number of Ravi and the name of the account person and the balance. So first it will display 101, then Ravi and the balance. And after that, it is going to print this line. Then when it again called the second object, again it will go to this particular method. Now again it is going to print the Sita's details. So this is how it will print the values. Let's execute it. So this is the classes and object program. When I run this, as I said, first it is going to print the account details of Ravi and then it is going to print the account details of Sita. So here I am using the Java Online compiler since I have facing some issue with my IntelliJ. So you can also use the Java compiler to run your Java programs. Now our next topic is constructors. So in the previous concept we have seen the constructors. What exactly is a constructor? A constructor is like a special piece of code that runs automatically when an object is created. That means you do not call a constructor manually. Java will call it for you once you created your object. The constructor's main job is it will set the initial values and it will prepare objects for use and it will ensure object starts in a valid state. If you take an example of house, when you rent a new house, before you live in it, there will be already the electricity is connected and water supply is already ready and the basic setup is done. This setup happens automatically. Constructor is nothing but the house setup process. And the object we already know, the house which you are going to live inside it, that is the object. You do not live in an unprepared house. Same way, Java does not give you an unprepared object. And why do we need constructors? Without constructor, variable will get default values as we have seen. Integer will get 0 and string will get null. And the programmer must set values manually. Object may stay in invalid state. If we take an example, once the bank account is created, the bank balance will set it to 0 unintentionally. And when an employee created uh, the salary, it is initially set to 0. But with constructor, object starts correctly and import values are set immediately. Invalid objects can be prevented. The constructors will protect the object integrity. And there are few three types of constructors, that is default constructor, parameterized constructor, constructor overloading. Let's discuss each of them in detail. And before that, while we are creating a constructor, we will be following some set of rules. Constructor name must match with the class name. Whenever you are creating the constructor, your class name and the constructor name should match. And there should not be any return type, not even void. There should not be any return type while creating the constructor, and it should automatically executed. It can be overloaded and it will run once per object. So these are the some rules of creating a constructor. Now our first constructor is default constructor. That means a constructor without parameters. So default constructor will not contain any parameters. That means if you don't write any constructor, Java will automatically provides one that will set the default values. That is nothing but the default constructor. So there will be no parameters, and it is provided by the compiler if none was written, and initialize the default values. So this is how the default constructor will work. And if you see one example, how let's understand it with the help of example how the default constructor will work. So first I am creating a class with the name bank account, and in the next step I am declaring the uh, variables. So it is somewhat related to the example that we have taken in the classes and objects. I have declared the same variables over here with the account number, holder name and balance, and each object created from this class will get its own copy of these variables. And in the next step, here I have declared my default constructor. To identify the default constructor, you can see the parenthesis. Inside that there are no values or no parameters declared. Then it is called as the default constructor. And as I said, my constructor name should match with my class name, which is the bank account. And even if you don't write it, Java will provide one by default, but here we wrote it ourselves. Whenever an object is created, this particular message is printed. Bank account object created using default constructor. In the next step, I have created my main class. Execution will start from here. And in the next step, I have created the object using the default constructor. Here I have created an object that is account1. What happens internally here, when once I created this account1 object, it is going to allocate the memory, and the default constructor is called automatically this particular line. When you call this particular default constructor, this particular line is going to execute. At this point, variables have the default values. That means these variables do not have any values, so it will print the default values. In the next step, I have assigned values manually. Now I am manually putting values into the object using the dot operator. Whenever you want to insert the values to the object, you need to use the dot operator. And now here I have created only one object. That means only created account for one person, and for that person I am going to create the account number and the name of that person and the balance. And this is different from the parameterized constructor where values are passed in just one line. Whenever we don't have any values, we need to assign values separately using the object. And in the next step, I am going to print these values which are stored in the inside the object. Each line print the value from account one object. Here it will print the account number, here it is going to print the account name, and here it will print the balance. The final output will look like whenever the main method execution, this particular execution started, initially we have called the default constructor. Then immediately it will go to this particular default constructor block and it will print this line first. Then after that we have set our values. Then it will print these lines. Then in the next step it will print the number, and here it will print the name, and here it will print the balance. This is how our output will look like. Let's execute it and see. So this is our default constructor program. And when I run this, so as I said, it has print this particular line first, and then it has print all the details of the uh, bank person Ravi. Now the next constructor is the parameterized constructor. Parameterized constructor means a constructor that will accept the values while creating an object. It will be accepting the values. Whenever you are creating the object, for suppose I am creating an object for this particular class, here we will be passing the values. So here it will accept the values while creating an object. If you take an example, like while you are filling the admission form, you will be having the name, age, or marks. The constructor is nothing but the form submission, and the object is nothing but storing the details of the student. So this is how the parameterized constructor will work. Let's understand it with the help of example. In this example, I have created the class with the same bank account. I have taken the same bank example, just the difference is we have been using the different types of constructors. If you remember, this is the same example I have used for the classes and objects, and I have passed the values here. That means I have initialized the parameterized constructor is identified because I have been passed some values inside the parenthesis, and the class name is same. And when the execution is started, this will do uh, it will going this particular line, it will call goes to this method. The bank account constructor parameterized constructor has been passed, and the values has been passed when I have created this particular account 1 object, and the same way for account 2 object. So it is going to print the details of the account 1 balance and account 2 balance. Here I have just asked it to print the account 1 holder name and the balance he or she is having, and the account 2 holder name and the balance he or she is having. Whenever I have called this particular object, now the output will look like the account 1 holder name is Ravi and the balance he have is 5000, and then the account 2 holder name is Sita and the balance she have is 10,000. So this is how it is going to print the output. Let's execute it and check. This is the parameterized constructor. As I said, when I run this, it is going to print the details of the account holder name and account holder balance. And the next constructor is constructor overloading. Constructor overload will have the multiple constructors. It contains multiple constructors in the same class with different parameters, and it will be having different parameters. That means it will have the same name, but it will be having the different parameters. For example, if we take, if you are going to buy a car, there will be a basic model for it, and the model with AC, and there also be a model with AC and music system. So these are the different parameters for each car. For the first car, there will be only the basic model. In the second car, you will be having model along with AC. Here you have model with AC plus music system also. So there are different setups for each car. So the same way we are going to create multiple constructors with different parameters. So for the first constructor, it may have only one parameter. For the second constructor, it may have two parameters, and the third constructor may have three parameters, and so on. The parameters are different here. So let's understand it with an example how we have created different parameters. The same bank example I have taken, the same variables. Here I have given the default constructor because there are no parameters. This is one type of constructor. And in the second step, I have taken the parameterized constructor which is having the two parameters. And here in the third step, I have created the another constructor with three parameters. So these are the different types of constructors with the same class name and with different parameters. Once I created an object, and I have created object for three accounts. In the first account, I am not going to pass any values. In the second account, I have passed two values because I have used the two parameters. And in the third account, I have passed three values since I have used three parameters in the constructor. In final statement, I am going to print only the account details of third person, third person account name and the account balance he or she is having. In our case, here third account holder is Sita and the bank balance is 10,000. So this is the output that we will see when we run this code. Let's execute it. This is the constructor overloading. When I run this particular code, it is going to print the details of the Sita, and there is a statement that basic bank account is created that we have used here in the default constructor. So this is how the constructors will work. And now let's discuss about the stack and heap. So basically what exactly is stack? Whenever we have declared the variable. So when we are declaring the variables, we will be storing the values inside that variables. For suppose I have declared a variable year with value to 2025 and 2026. For example, it is going to basically we will be thinking that there will be a box and it will be having some value inside it, but there is a huge concept behind this. Initially, there will be a computer for us. So this computer will have some memory, and in this memory we will be having so many memory spaces, and there will be a memory address for each space. For suppose it will be having the memory address like this. Let's assume. Now we have the variable year. This particular variable year is going to store into one memory space, and the uh, this particular memory space is nothing but the stack. So it is going to store the values in the stack order, and there is also another memory space which is nothing but heap. So stack will store the memory address, and heap is going to store the value of that variable. That means this particular variable value is 2025, and that is going to store inside the heap. So here the 2025 is getting stored. And here when we store space per year, the particular memory address is going to store into this memory space. It is going to store the value of this memory address. For suppose if we want to update this value, we are updating this value to 2026. As here it will just store the value 2026. But here this particular memory is erased and it is going to provide another memory address. It is going to update the memory address. So this particular process is basically followed by Python and JavaScripts languages. That means there will be a variable. Instead of storing the value, this variable will not store the value. Instead of that, it is going to store the address of that particular value. So this is how it will store the variable inside the memory. And there is also a variable where it will directly store the value instead of the address of value. So here this particular variable will directly store the value. That means the same way there will be the stack will be there. Here only stack will be there. There will be no heap. When the variable is storing the value directly, there is no point of using heap. There will be no heap memory. Only the stack memory will be there. There it will directly store the value of that particular variable. For suppose if I am going to store the variable year, it is going to store the value directly. And if I want to update this, I am just removing this 2025 and updating with 2026. And as usual, there will be the memory address for each memory space. This particular pattern is used by C language. And now our Java or the C++ will use both the memory spaces. That means it can either use only stack or it will use both stack plus heap. So that will be used by Java and C++. So this is how the values is getting stored inside the stack or heap. Now let's discuss about the variable scopes. Variable scopes are what exactly mean by scope? Scope means whenever you use a variable in the program. That means scope means where you can use a variable in your program. It is a region of the program where a variable is accessed and valid in a memory. Why the scope is important? Because it will control the visibility, it will prevent errors, and it will save memory. It will avoid conflicts between the variables which have the same name. So we will be declaring the variables in different scope, but there will be a same name. But there in that situations, it will avoid the conflict between those variables. There are three types of variables based on the scope. The first one is local variable, where the local variables will be declared inside the methods or inside the loops or inside the blocks. The local variable is declared. For suppose here this is a method. Inside the method I have declared my local variable. The scope of this particular variable is only inside this particular block. That means the start of this block to end of this block. Within this block, this particular variable scope is allowed, where it has been declared, and the lifetime is created when the method starts and when the method ends. This is where the lifetime is created. And it's not it is mandatory to initialize the variable. If not initialized, it will throw a compiler error. And this particular local variable is getting stored inside the stack memory. If we see an example, so in the previous example that we have seen the class test, we have declared a method, calculate method. Inside this particular block, I have declared my local variable with the name number. This is the local variable and I am going to print it. Here I am multiplying it with number into number. That means it is going to multiply it 5 into 5, which is 25. And this particular block is closed and the main class block is closed. It exists only inside. Local variable exists only inside the calculate method. It cannot be accessed from another method. For suppose, before this is one block. Let's assume here I have used another method, void display. Here I am again calling that particular number, or imagine I am calling the calculate method. This is not going to work in this block because it is only initialized within this particular calculate method and there will be no default value. You have to initialize the value to the variable. This is how local variables will work. Next is instance variables, where the instance variable is declared inside class, but we will be declaring it outside the methods. Instance variables are declared outside the method blocks. Uh, for suppose it is like just we are defining the class with the variables. Those are our instance variables because we have declared outside the method block. If we see earlier, we have declared the variable inside the method block in local variables. And in the case of instance, we are going to declare inside the class. And the scope of this particular instance variables is access it to all the methods of that object. How many methods we are going to declare, those many methods is going to access these instance variables. And the lifetime is when object is created, it will get created, and when the object is destroyed, the object is collected by the garbage. And here it is not mandatory to initialize the values. Even if you don't initialize the values to the variables, the default values will get assigned to the variables based on the data type. And this particular instance variable is going to store inside the heap memory because object lives in the heap. So now let's understand this particular example. Here I have created a class with the name student. Then these variables are declared inside the class but outside the method. Here is my method block, that is show details, and my variables are declared outside the method block. They belong to an object. Each object will get its own copy. And now I am creating, here when we come to the main method block, I am creating two different student objects. This is about one student and this is for the second student, and the object is S1 and S2. S1 have the details of Ravi, name and marks, and S2 will have the details of the name, student 2 names and marks. Even though the class is same, data is different. And whenever I am calling this particular object, this particular show details method with the help of object, it is going to print the details of student 1, which is nothing but Ravi with the marks 85. In our case, here I have used it as like this. And then when I call this particular object, it is going to print Sita with marks 92. Let's execute it and check. When I run this, it is going to print the details of student 1 and student 2 along with their marks. So this is how the instance variable will work. Now the next variable is static variable. Static variables are declared inside the class with static keyword. Whenever you are declaring the static variable, we will be declaring it along with the static keyword. And the scope is, this is common for all the objects of the class, and it is stored in the method area. It is stored in the class loader memory, and default values will be assigned automatically if you are not going to pass any or initialize any values. Let's understand this particular example. Here, the variable is declared using the static keyword. It belongs to the class but not to the individual objects. Only one copy is created and shared. Static variables, that means static variables are accessed using the class but not the object. So all students study in the same school, so it makes sense to share it. Here when we reach to the main method block, I have again created object for 2 students, and here I am going to call the object along with the class name, because static variable is only accessed with the help of class name. Till now we have accessed the variables variable name using the object, that means either s1 or s2, but in the case of static variable we are accessing it with the help of class name, that is student dot that particular variable. So it is going to print the school name, which is nothing but ABC school. This is how the static variable will work. And here are the few differences between the local variable, instance variable and static variable. Where the method is declared inside in local variable, it is inside the block or the method. When it comes to instance variable, it is declared inside the class, and static variable is also declared inside the class, but we will be using static keyword while declaring the variable. And the scope of the local variable is only inside that method. For instance, it is for entire object. For static, it is for entire class. And the lifetime is for method execution, and for instance it is for object lifetime, and static is for entire program lifetime. For local variables, there will be no default value, but for instance and static variables, there will be default values assigned automatically. And local variable is stored in stack, instance variable is stored in heap, and static variable is stored in the method area. Local variables cannot be shared, even instance variable cannot be shared, but static variables can be shared because it is declared inside the static and we need to access it with the help of class name, so it should be shareable. And now the next topic is pass by value and pass by reference. What exactly happening here? So pass by value, the first important thing that when an interviewer asks you whether Java is a pass by value or pass by reference, there is no doubt that Java is always pass by value and there is no pass by reference in Java. If you say this particular thing confidently, that particular interviewer will know that you understand the JVM model correctly. When a value is passed to a method, that means Java will send a copy. Whenever you are passing a value to the particular method, Java is sending a copy but not the original variable. And there are two situations. There is in one case primitive data types and there is the another case objects. So the first situation is the primitive data types and the second situation is objects. So primitive data types, we already know primitive data types are integer, double, char, boolean, etc. Here Java will copy the primitive value. Changing it inside the method does not affect the original copy. For example, whenever you are making a Xerox of a particular document and you are writing something on that Xerox copy, you are just making the changes in the copy, but the original document will stay same as it is. In case of second case, that is object, here Java will copy the reference value. That means object, we know that object will live in heap memory and stack will store a pointer to that object. Java will passes a copy to the pointer. So modifying object's internal value, it will also affect the original value because both references will point to the same object. And reassigning reference variable, there will be no effect on original reference because giving someone a copy of your house address doesn't transfer the house ownership. It is same like that situation. Whenever you are reassigning the reference variable, there will be no effect in the original reference. Pass by value, which means the value stored in a variable is copied and sent to the method. Modifications inside method will not affect the original variable since it is stored in the stack frame. And pass by reference, the method will receive the memory address itself, not the copy. Here it will receive the copy. Here it is directly receiving the memory address. And if you are going to change any modifications in pass by reference, it will affect the original variables. Here, if you are going to make any changes or modifications, it does not affect the original variable since it is storing in stack, because it will just hold the address, not the value. Here, since it is stored in the heap, if you change anything, it is going to change the value. So this is how the pass by value and pass by reference will work. Let's understand this with an example. So here I have created a class with pass by value and the main method execution will start from here. In this first step, I am declaring a variable inside the main method. So here I create a variable called salary and I have assigned the value to the variable salary, which is 5,000. Now, what is this particular variable? It is the local variable. Since we are declaring inside the method, it is a local variable and we have to initialize the value to the local variables. Value should be assigned initially. So now the current salary of an employee is 5,000. And next it is going to print this line before giving the bonus of the salary. So before bonus, it will just print how much the employee salary is. Here I have called the method, that is give bonus is my method name. I have called this particular method. When I call this particular method, it will directly redirect to the place where it has been defined. In this case, I have defined the method here, and uh, here you need to note one important thing. Java does not send the original variable. Java will just send the copy of the value. That means it is going to send the copy of salary 5,000 to the amount 5,000, because here I have given the variable amount. So that copy is going to this method. In the method definition, that means in this particular block, here amount is a new variable. This is a new variable that receives a copy of the salary. So this copy is sent to amount variable. They have the same value. They are having the same value, but they both are from different memory locations. In the next step, I have modified the value inside the method. In my give bonus method, here I have modified value with 1,000. What happening here? We have used the operator amount is getting added. Originally, the amount is getting added with 1,000. Now I add 1,000 bonus, but I am adding it only to the copy. Initially, what is the value? 5,000. It is getting added with 1,000. It will become 6,000. Only the amount is getting changed. Here it will become 6,000, but still the salary is same. The salary is still 5,000. In the next step, I am going to print the modified value inside this particular method. Here only I am printing the output. This particular inside method will print you the value 6,000. And when you go back again to the main method, to this particular line, here I came to main method and print the salary again. Now if I print this after bonus again, it will print you only 5,000, because the copy was only changed inside the method, not outside. So initially, how our output will look now? Whenever the execution starts, it will go. There are three print statements. This is the first statement. It is going to print. The first one print the before bonus. It is 5,000. And next, when this particular method call, it will go here. And here we have another print statement. Here it will print the inside method statement. Here your amount is increased to 6,000. Again it will go back. Here there is another statement. This particular print statement will give you after bonus. Again it is 5,000. Since we have changed only the copy. This is our output of this particular program. Because since it is the pass by value, you are just copying the value. You are not, even if you modify changes in copy, it is not going to affect the original form. So the thing you have to remember in pass by value, whatever changes you make, it will not affect the original program or the original variable. This is how the pass by value will work. And next is pass by reference. So here we have imported a array list, because it is not part of the basic Java. It's a collection that is used to store multiple values. So I have imported the array list. In the execution will start from here, the main method. Initially here I have created a array list, that is and I have called the shopping list, and I have added one method. I have added one item which is nothing but the milk. So right now shopping list contain the items only milk. We'll see about the arrays in detail later. And in the next step, here this line will print the print list before calling the method. So before adding, it will print. So we have two print statements. So initially it will print this output, this line in output. Before adding, the list is only milk. So this will, in the array we have only milk item. Next again we are adding an item to the shopping list method. Now I am passing shopping list to a method which is nothing but add item is my method name. Here you need to note that Java still passes by value, but the value passed is the reference address. This is the reference address of the object, not the actual object itself. So, shopping list will contain the milk and even the list will contain the milk. Both variables may point to the same object in the memory. And in the next step, here I am defining my method. Here list is a new variable, but it points to the same array list object. It will point to same array list object. Here I have added bread to the list. It is modifying the original object. Since both list and the shopping list point to the same object, the change is visible everywhere. Here our object is add. So we are making changes to the original object. Now the list will become milk and bread. Now when we go to back to main method, here again it will print this particular line which is after adding in the output. So here it will display both two items, milk and bread. So this is how the final output will look like. Let's execute it and check. So first execute pass by value. As I said, the before bonus and in only the inside method will get changed, not the original object. It will remain same. And now let's see the pass by reference code. This is going to add the item. So initially it was milk and later it is going to become the milk and bread. So here the major confusion is Java is not passed by reference. It is always passed by value. But why did the object change? Because the value of the reference was passed. So both variables point to the same object and modifying the object will automatically affect the original one. For suppose, imagine this is the main method and we also have another method which is the add item method. In main method we have the shopping list and also list. So these two will contain the milk and bread. So they both are having the same object and same memory. What if we reassign the object inside method? If you create a new list inside the method, it will not affect the original list because only the local copy of reference changes and original list will still stays the same. For suppose to understand it better, if we take the real life example, imagine you and also your friend have the same paper, that means same shopping list paper with you, and initially you have some items. Imagine you have already three items and your friend is going to add the fourth item. Even you can see the changes, but imagine if your friend creates another new paper and adds items in that paper, you will not able to see these items. So this is how the pass by value and pass by reference will work. Java will passes objects references by value. So changes to the objects are reflected, but reassignment is not reflected. Now let's discuss about the next a few important keywords in Java. So the first one is this and the static keywords. So first let's see about what is this keyword. Uh, First, suppose this means the correct object. We know that if we are telling something, we are pointing to something, we will say this keyword. So just like imagine you are telling that this phone is mine and you are pointing to yourself that this is my phone. Same in Java. Inside a method, when Java sees this keyword in a program, it is referring to that object variables or the particular methods that the one which are currently running. So it is a reference variable stored inside every non-static method that holds the address of the current object in the memory. And why we require this particular this keyword? Because sometimes the local variable name and the instance variable name are same. This will lead to the confusion. To remove this particular confusion, we say this dot name, which is nothing but the instance variable, and the name will hold the local parameter. This works like a pointer to the object to which method that we are calling. If you say the another example, you and your friend both are having the same name. For suppose imagine you and your friend is having the same name Rahul. Someone says that imagine your teacher is calling Rahul, raise your hand. In your class there will be two Rahul and they both will get confused who should raise the hand. So at that time the teacher says that this Rahul in the front row, pointing to the particular Rahul who is sitting in the front row, raise your hand. That means the one currently being addressed. So this keyword will store the address of the particular object. That will point to the, that's how this keyword will point to the correct object. If you see, this is like my reference variable and it will hold the state and state and behavior of the particular object to the instance variables. Now next comes our static keyword. Static means it means that it is belonging to the class. It will just belong to the class, not to any object. If you remember, in the previous topics, I have used the static keyword. That means it will be accessible only to this particular class. So it is not belonging to any object. We will be declaring static whenever we know need to create any object. So the same way, the static keyword, it will allocate in the method area and remain until the program ends to the entire class. They are loaded. When the particular class is loaded, the static keyword will automatically load before any object is created. Uh, that means only one copy exists and it has been shared by all the objects in the program. Why it is useful? uh, when it is useful to store some common classes data and utility methods counters in case of constances. Here the static will be useful. If you take an example, imagine here static means your school notice board. Imagine the school notice board as the static. Once that means only one board for whole school, not for each student in your school. There will be no separate boards. There will be only one notice board. It can be in a university or college, and entire students in the campus will see the notice board. That is nothing but the static. It has been used by everyone. And here the instance variable student id card will be the instance variable. That means each student has own identity. That is the instance variable. And next important topic is garbage collection and finalize method. First let's talk about the garbage collection. What is mean by garbage collection? Java will destroy the unused objects automatically. That means you don't delete memory manually. Garbage collector frees heap memory when object becomes unreachable. if we talk, that will automatically remove or it will destroy objects that are no longer needed, so the memory can be used, memory can be reused. If you see, unlike in C or C++, programmer must delete the memory manually. The programmer who is developing the program, he has to delete manually the objects which are not used, and it will lead to memory leaks or it may lead to crashes. In this particular point, Java will solve this by having automatic garbage collection, which is handled, that means which is performed by the JVM. So it will identify objects on the memory which are no longer used in the program. That will reclaim memory of those unreachable objects. So this will prevent the memory leaks and it will improve the performance and stability. Why garbage collection is needed for us? Because the memory is limited in the system. If unused objects are left in the memory, program may slow down or it may lead to crash. At this point, Java garbage collection will prevent memory overflow and memory leaks and dangling pointers. So it all can be prevented with the help of garbage collection. And where does this garbage collection work? It will only collect memory. It will only collect memory from the heap area, not from either stack or method area or program counter. It will only collect memory from heap area, because we know that objects live in heap memory. So it will collect from heap area. When is an object eligible for garbage collection? If an object becomes garbage when no live reference will refer to it. Uh, that means if an object is becoming an garbage when no live reference will, that means no active references are pointing to it, meaning here the JVM will think this object is unreachable, so we can remove it. So the JVM will think in that way. To remove those unreachable objects, we have three common cases. One is if the reference is set to null, and the second one if the reference is reassigned, and the third one if the reference goes out of the scope. For suppose, uh, in the first case, let's see how the reference is set to null. So if you, in the first case, that is which is we are setting the reference to null. Here suppose I am creating an object employee with the class employee and calling the employee constructor. Here this object I am setting to null. In this case, the garbage collection will remove this particular object. The object is created but the reference is lost, there is no reference, so garbage collection will remove this particular thing. And in the second case, that is the reference is reassigned. In this particular case, in reassigned, here we can see same employee object and new employee. Here I am creating, reassigning another constructor to the object. In this case, first object which has been created, that means this object will become unreachable. This is unreachable because you have reassigned another object to this particular object. So the first one will become unreachable. In this case, garbage collection will remove this particular object. And the third case is it will go out of the scope. It is out of scope. In this case, you will be having some method block, and here the same object I am going to create, that is employee new employee, and the block is finished. After this method, that means after this curly brace here, or the next line, you can see this particular E object is destroyed here. Destroyed after this particular method, here it will become destroyed. In this case, the garbage collection will remove this particular object. Now let's see how does garbage collection works internally. It is very simple. Java works in three steps. Like first, it will identify unreachable objects, and then it will mark them and remove them from free memory. And many JVM algorithms exist, like mark and sweep algorithms, copying collector, and generational collectors. But mostly the interviewers will focus mostly on the concepts, not the algorithm code. If they know that you know the concept, that much is enough to uh, get to know about the concept. And here we have three different generations. The first one is young generation, and the second one is old generation, and the third one is permanent generation. In the young generation, we have the newly created objects and frequently collected garbage values. And in the old generation, we will be having long living objects, which is tenured. And in the permanent generation, we will be having the class metadata, which is all permanent for every time. And these are the algorithms that garbage collection will use. And in this particular case, and how you are going to request garbage collection manually, we can only request JVM. That means we can only request, but JVM will decide when to run it. So there will be few commands like system.gc method, which is the garbage collection, and also runtime dot get runtime method with garbage collection method. So GC garbage collection may run immediately these commands or later. We can only request, but JVM will decide when to do this particular task. And it does not destroy objects immediately. JVM will decide the best time based on the free heap and load and generation statistics. Concluding all those things, JVM will take the decision. Now let's see this simple example. Like we have seen that JV reference will be set to null, out of scope, and reassign. First, let's see what if the reference is set to null. Here in this program, I have defined a class named demo, and the main method execution will start from here. And I have created an object for the creating an employee object. What happens here in this particular case, in this particular line, employee is the class name, and this is the reference variable. And new employee, this will create a new object in the heap memory. Internally, what happens? Java will allocate some memory in the heap. An employee object is created over there, and this particular reference variable E, this will point to this particular object which has been created in the heap memory. At this moment, what will happen? E is getting stored with employee object in heap. Now what we are trying to do in the next line, we are trying to remove the particular reference. What does this line do? Now this particular reference variable is no longer pointing to this particular object, employee object. The objects but still the object exists in the heap memory, but there is no reference is pointing to it anymore. Initially our E is holding this particular value, now E is set to null. That means employee object, this particular object has no reference. No reference. Now at this particular line, we are calling the garbage collector. What does this do? System.jc method, this will request the JVM to run the garbage collector. It is not guaranteed that garbage collection will run immediately. JVM may ignore this request also. But the important thing here you need to remember is system.jc, whenever you are calling the garbage collector, it is only a request. It is not the command. You are not telling it to remove it immediately. It is only a request. It is completely depend upon JVM whether to do this particular task or not. And next here I have defined my employee class, and it contains one method which is nothing but the finalize method. What is happening in the finalize method? It is a method from the object class. So JVM calls it before destroying an object. Here before destroying it, JVM will call this particular object class, and it is used to perform cleaning operations. And here if you see, we have specified the access modifier as protected. Why? Because access the original finalize method in object class is protected, so we can keep the same or wider access. We must keep the same or wider access to all the classes. And when this particular finalize method is called, when object becomes unreachable or garbage collector decides to remove it, the JVM will call the finalize method once before deleting the object. So this is how the program execution flow will happen. Once you done that, it will going to produce the output employee object is destroyed. So here output is not guaranteed every time because garbage execution is JVM dependent. So finalize method may never be called until unless JVM decides to remove that particular method. So this is how the we are trying to reference setting it to the null. And if we see the next example, here we are reassigning. That means if you see this particular part, a new car object is created in the heap memory. That C1, here C1 is a reference variable, and this is pointing to the first car object, which is nothing but the new car. So again we have reassign, a second car object is created. This the reference C1 is reassigned to new object. Now here the first object loses its reference because we have reassigned the another object. So the first core object becomes unreachable here. And when you call the garbage collector, this line requests the JVM to run the garbage collector. And here I am defining my class car, and the same process just like above previously we have did the null, it is going to call the finalize method, but even here JVM will decide whether to do this part or not. Once it is clear, it is going to produce the output car clean, but the output is not guaranteed until unless JVM decides to remove the method. So this is how we are reassigning values. And the next one is getting out of scope. Even here we are trying to do the same thing, but here the show method is called. We have created a class and main method execution will start. The show method is called here, and the control moves from this particular main method to show method. That means show method where it is there, here we have the show method block. This defines a method named showed. It is static because it can be called without creating an object of particular class check. And here we have a new bike object is created in heap memory, and it is the local reference variable because we are creating variable inside the method. So it is a local reference variable, and B will point to the newly created object, which is nothing but bike. And end of this show method, and then the same, the JVM will decide whether to delete this particular thing or not. Then it is going to print the output bike is destroyed. So this is how we will be referencing our variables. Now the next topic is finalize method. What is finalize method actually doing? So it is a method inside object class, that means the parent of all classes in Java, meaning every class will automatically inherits it. So if you want to use it, you can just override that particular finalize method. And why does this finalize method exist? If you see back in early Java versions, programmers needed a way to clean up the non-memory resources before destroying an object. For example, database connections still open, or the socket connections which are still active, or the file writer which is not being closed. These resources are not freed automatically by garbage collection. So, finalize method was designed a cleanup hook to code that runs before object memory is reclaimed. And when does this finalize method execute? So here the important rule which you need to remember is finalize method runs, it can be maybe once before garbage destroys an object. We have seen in the earlier codes, after you are declaring or reassigning the values wherever you want, whether it is setting or reassigning or getting out of the scope, it is only decided by the JVM when the object is garbage collected. Before destroying object memory, JVM will try to call finalize method once, but it is not guaranteed that it is going to print the output. It will try to call, but it will depend on JVM. So garbage collection, you need to remember the interviewer question point. Garbage collection is a JVM dependent. So because we know why it is not guaranteed, because JVM will decide the timing. If JVM shutdowns before garbage collection runs, finalize method may never execute. Or if JVM skips the finalize method, object is getting destroyed anyway. So writing logic inside finalize is very risky thing. And why it is deprecated from the different versions like Java 9, because finalize method will slow down garbage collection, and it is an unpredictable timing. We don't know when it is going to destroy it, and it will cause so many problems if object recovers itself. And it is a very bad design for resource cleanup. The modern garbage collection and resource management techniques replaced this particular finalize method. For example, if you take the real life analogy, like think of a hotel checkout. When the guest leaves, that means object becomes unreachable. Whenever uh, there is a particular hotel and there will be a guest, when this guest is leaving, that means the object is getting unreachable here. But there will be another person who is housekeeping. They may clean the room. That is nothing but finalize. Even if the person is there or not, it will do it work. It is the finalize method. But it has some work to do, but we don't know when the cleaning time is, and sometimes the team is short staffed. She or he may not be available, and cleaning may not done immediately, or sometimes it can be skipped. Instead, this hotel will adopt better systems like supervised learning or the modern techniques to get the work done. Think of it like a finalized method. I'm just telling the description how it is work. Or you can take another very lame example, which is imagine you are throwing your garbage outside your home or your house. The municipal truck, you know that municipal truck will come and it will take the garbage, and we all know that municipal truck will come once in a week, or they may come, they may not come, they may come late tomorrow, or they may skip your entire street to reduce their work. This is how the finalized method behavior is. It is unpredictable. We don't know whether it will do work or not. It's completely depend on JVM. Imagine the truck is the finalized method. That means the garbage truck is finalized method, and the person who is driving inside that truck is the JVM. It depends on him whether to take your garbage from your house or not. If he is not interested, then the finalized, that means your wastage is not going into the finalized method. That means it is not going into the truck. This is how it will work. And the next important thing is final keyword. What does final means in Java? If you say in simple English terms, final means which cannot be changed after doing some operation or some action. It is like a restriction keyword. It will prevent modification after declaration. Once you declare anything, you cannot change it, you cannot modify it. The term itself says it's final. There are no more excuses or changes to make modification. And where this final can be applied, there are three places where you can apply the final. One is the variable. It is applied to variables or methods or classes. When it comes to variable, once you declare the variable value, it cannot be changed, and once you declare the method, it cannot be overridden by another subclass. Once you When it comes to class, you cannot be inherited or extended it. We will see all these overridden, subclass, inheritance and all in the OOPS concept, which will come in next few slides. So this is how in these particular three places we will be going to use the final keyword. Now first let's talk about what is final variable. That means once a value is assigned, it cannot be modified. Here the final variable become a constant. For example, if you see this, first you have declared int x equal to 10. If you try to do x equal to 20 again, Java will stop you immediately and it will throw error. The memory behavior will be value is stored in memory is fixed and it cannot be changed. And where when you can use final variable in what situations, like whenever you are using the pi values, or in such cases we know that pi value is fixed, there you can fix the pi variable with final pi. And you know the college name situations, college name is not going to change, and company GST numbers, in these situations you can use the final keyword. Next is the final method. A final method cannot be overridden in child classes. For example, this is my final method, final void display. This particular method cannot be overridden. It is fixed. Why final method is needed? To stop subclasses from changing important logic. So in this particular method, I have been given some logic, and there will be another class below this particular block. When it inherit it, it doesn't have any access to inherit this particular thing. If it access it, it may go to it may change the logic which I have been created. So to that particular case, I have been declared it as final method. For example, if you take the real time example, there is a rule for uh, rule book rule. So that is the final method. That means there will be some rules in a book, or in if you take the hostel scenarios, or even in colleges, there will be a board like no ragging inside hostel or inside college. So this rule, nobody can modify this rule. It has been fixed by the authority person, so no one can change it. That's how the final keyword will work. And here we are taking a bank example. So a bank class have method to compute interest, and these are our child classes, which are savings account and current account. So it cannot be override this method because interest rate policy is fixed. We know that interest rate policy is fixed. The rate is fixed by RBI rules, which is a authority that has been fixed. So you cannot change this particular method. And next comes to final class. Here, a class cannot be inherited. That means initially we will be writing classes like class, vehicle. This is how we will write and we will declare some parameters. And here in front of this class, I am going to make it final. Why it is needed? Because to prevent modification of a sensitive class, and if I am going to declare the variables like mileage or speed of some particular car, because it is different from other cars, it may change the data. The person who is going to buy it, it may change the data information. So to prevent that particular thing, I am going to declare it as final. So why we will be using this final keyword? It is very safety. It will provide safety, security, optimization, and it will maintain the integrity of the code. And next comes our another keyword, super keyword. What exactly mean by super? In general English terms, super means it is something you have done perfectly. So use your parents version or go to the parents class. So super is like a reserved keyword which is used inside a child class when parent features need to be accessed. And we will be seeing this parent class, child class, or base or derived class when we enter into oops concept. Why I am telling all these keywords before? So all these keywords we are going to use into the oops concept and exception and file handling concepts. So without knowing all these keywords, you may not understand the real meaning or operation of these particular words, what they are going to do in the code. And in next topics we are going to enter into the most important concepts. So it is very important to understand all these keywords, so just focus on these keywords more importantly. And if I see the super keyword, it is like a reserved keyword which is used inside a child class. That means we will be having, imagine you have two classes in a program. This is the parent class and this is the child class. And child class is trying, whenever child class wants to inherit the characters of parent class, we use the super keyword in child class. And why do we need this super keyword? Because the child will inherit the parent features, but sometimes child and parent have same names, so confusion may occur. That means it may have same variable name or same method name. So the child will say, I want father's version, not mine. So super will help the child access parents version explicitly. And where it is used, we have three cases, three main situations where we will use super keyword. Whenever you need to access parent variables, and whenever you need to call parent methods, or when you need to call parent constructor. In these three scenarios, you will be going to use the super keyword. Imagine you have a house, parent child house example. Let's take parent child house example. So father will be having some land and son is building house. The land is father is having and house is built by son. Sometimes son need items stored in father storage. He needs some items which is stored in father storage. So son will ask, father, give me your hammer, not mine. So here child class is nothing but son and parent class is nothing but father. And the super keyword, what it is doing? It is using parents tool. So that is how it will help the parent and child class. And now let's see one by one what it is going to do. So in this code, I have declared my class as parent. It contains only one variable that is instance variable, because we have declared within the class and we have given value 50 to the variable 50. Here we have used extend keyword. What is the use of this extend keyword? So extend means it will help the child to inherit all the non-private members of parent. So this particular thing is parent class, and this is our child class. So extend parent means child will child will inherit all the non private members of the parent. Why we are mentioning non private? Because if this particular, imagine if this particular variable is declared as private, child cannot access this variable. That we'll see in more detail. So child is able to inherit all the properties of the parent class. So here I have this is also an again instance variable, and I have assigned value 100. So it has the same name. If you see here, my variable name is same, even here in parent class is same. So here this will hide the parent value variable. This will hide the parent value variable. And void show, I have defined a method name show inside the child class that is going to print the output value. Here I have used the super keyword. The super will refer to the parent class object. It is going to refer to the parent class object. Whenever I am trying to access super dot value, it will access the value variable of parent class. So here value means it is the parent class variable. Parent class variable. So it prints 50. It is not going to print 100. It will print the 50 because we use super keyword. Imagine if you are not using super keyword and you have just given the value. In this particular case, it is going to print 100 because it is calling the variable of child class. When you use super keyword, it is calling the variable of parent class. So, and when it comes to using super keyword with methods, so the same way here I have a method display. When this is a method in the parent class, when called, it will print the parent display output, and this defines a class name child, and it is extending parent. That means child will inherit methods from parent. And I have void display same method. This defines a method name display in the child class. So this method is overriding the display of parent class. So super dot display, here what it is happening, super is referring to the parent class object. So this particular line will call the display method of the parent class. When you give this, it is going to print this particular statement. So it will print the output as parent display first. Then I also have given this particular statement to print the child display also. If you are not going to give this line, it is going to print the parent class. Now we are also going to use the super keyword with constructor. Here what exactly is happening? This is the constructor of the parent class, parent constructor. It runs when a parent object is created. At that point, it is going to print the output parent constructor. So class child will extend the parent class properties. So child will inherit the parent class properties, and I have used the same constructor. So this calls the constructor of parent class. Whenever I have declared it as super, it is going to call the constructor of parent class. It must be the first statement in the child constructor. It initializes the parent part of the child object. Here, first it will print the parent constructor, then it is going to print the child constructor. So this is how the super keyword will work. And the next keyword is Synchronized keyword. What does synchronized mean? So basically, in general explanation, synchronized mean we are telling this lock this particular code. There will be a code and we are telling it lock this particular code. It will only one thread at a time. Like imagine bathroom door lock analogy. If one person is inside, other must wait outside. So just like that, synchronized means if one is using, the other one has to wait. So one thread will do one task at a time. What happens internally? So each object in Java has a monitor lock. When thread enters synchronized or block method, so the thread will acquire lock that will enter some code. Other threads also trying to enter, but it will wait because one thread is already trying to enter the code. And when that first thread which is trying to enter the code finishes its task, and it will release the lock, and the other threads which are trying, they can get access. That means only one thread executes inside synchronized section at a time. And where we can apply this synchronized? We can apply this in three places: synchronized method, synchronized block, and static synchronized method. So this will lock the classes, not the objects. If you take the real time scenario, for example, take the bank withdrawal from some account. uh, Imagine two persons in ATM machines are trying to withdraw amount from the same account at a time. If there is no synchronization, both ATMs read same balance. Both will allow withdrawal and balance will become wrong or negative or incorrect. But if there is synchronization, one ATM will perform transaction once and other must have to wait until the first transaction finishes. This is how the synchronization works. It is just like simple logic. When one person is doing some task, the other person has to wait. That is what the synchronized keyword will do. And now here we have seen the keywords like final, finally, finalize. This is one of the major interview question in Java basics. So the interviewer may ask, define the difference between the final keyword, finally, and finalize. So here final is the keyword. We know that. And what it will do? It will prevent modification. That means once you have declared the variable or you have assigned some value and you declared that variable as final, if you reassign the another value to it later in the program, it is not going to work. It will prevent the modification. And finally is a block. That means it will execute always in the try catch. We haven't discussed finally till yet. This part we will be going to discuss in the exception handling top concept. There I will tell you in detail about finally method, finally block. And we discussed the finalize method. We know that finalize method will run before garbage collection, but it is not guaranteed. We know why, because JVM will decide whether to run it or not. So this is the difference. You have to remember it. It is one of the important question asked in the interview. Now, till now we have covered the most important concepts, what and all required to run a Java program. And now from here till now we have used all the variables, everything to declare and create programs. We have used constructors and all. Here, from here, everything is about classes and objects. So OOPS is one of the major important concept in Java. If someone asks the what is the main difference between the other languages with Java, the most important thing, the anyone will say oops concept. It will make the Java program very easy and reuse the code, and it has so many types inside it that we will be going to discuss one by one in detail. From this topic I request all of you to concentrate more, because this is the major concept or major area where you will be getting so many huge number of interview questions. Till now, before we have seen that maybe the basic level or the intermediate level. If you are going for an interview, the first thing that he will ask, do you know the OOPS concept? And what does it mean? How many types does it have? Can you write the program on this particular type? So there are so many things we will be going to discuss in detail. Now let's start our OOPS concept. There are mainly four major pillars in the OOPS concept, that is encapsulation, inheritance, abstraction, polymorphism, and everything will depend on classes and objects. So apart from that, we will be having inheritance, polymorphism, encapsulation, and data abstraction. This is how the OOPS concept is built. Let's see each one of them in detail. Before going to that, we also need to know what exactly mean by getters and setters. So getters is something like we will be reading the value. To read a value, we will use the getter method, and to update the value safely, we will use the setter method. Why it is needed? To apply validation instead of direct assignment. So we will be using the getter variable. And you know that age cannot be negative value. So to apply this validation, we will be using getter and setter methods. And we already know we have some access modifiers, that is public, private, protected, and default. Public means we know it is accessible by everyone. Protected means protected will be accessible to the same package and to the subclass. And private is accessible only to that particular class. Default is accessible to the same packages. So this is how the access modifiers will work. It will be visible to particular limit based on the modifier. So now let's discuss about the first important uh, OOPS concept, which is encapsulation. So what does encapsulation means? So in simple words, encapsulation means data should not be directly accessed from outside. It must be accessed only through the methods. That means it is wrapping up the data and methods in a single unit, which is nothing but class. If you see in this image, data encapsulation is a combination of methods and variables, and both they are encapsulated inside the class. So that means it is hiding the internal data from different access. So in real world scenario, if you take this particular example only, the capsule, so there will be medicine inside it, but you cannot directly touch the content which is inside the capsule. You can only consume it through a safe wrapper. So the same way, similarly in Java, so it will be having classes, variables and methods, and in class will be a entire capsule, and variables is like medicine, and methods are like the controlled access. So why we need this encapsulation? Because exposing variables directly leads to problems like invalid values or inconsistent state, and there will be no control over how data will change, and security risk will occur. How to implement these encapsulation? We have encapsulation requires three main things. It will be using private variables, and it will provide public getters or setters, and it will maintain validation logic inside the methods. Using private variables, it will hide the data from the outside world, and whenever it is providing the public getters or setters, you are controlling the API's access. That means application program interface access. You are controlling that particular access using getter or setter variables. And maintaining validation logic inside methods means you are force safe values only. It is going to save the values which are forced. Let's understand it with the example. So this is an banking account example. So what exactly is happening here? I have created a class bank account. It will represent a bank account, and it have a variable which is the data member. This is the data member of the class, and it has been defined by private access modifier. That means it cannot be accessed directly outside this class. That means inside this class, we have this one particular block, and we have another block, and we have another block. So this entire thing is one class, and I have declared private. It is accessible only up to this particular class. And if I am going to declare any class extra outside here, to this particular class, it is not getting accessed, which the balance variable is not getting access to this particular class. And I have created a public method. It allows reading value of a balance, and the return balance, it will send the current balance value back to the caller. And this is a method which has been used to add money to the account. It will receive an input value which is nothing but the amount. Here I have given an condition. This will check whether the deposit amount is positive or not. That means it will check the balance whether it is greater than 0 or not. Only the valid amounts are accepted. If this particular condition is true, it is going to add the amount to the existing balance. And this particular method is used to take money out of the account. It receives an input value which is nothing but the amount, and here also I have declared a condition. This condition will check whether the account has enough balance or not. So withdrawal is allowed only if the sufficient balance exists in the account. And in this particular line, if this particular condition is true, the amount will get subtracted from the balance because you are trying to withdraw amount. So the balance should get updated again. So we are subtracting amount from the balance. So this is how the encapsulation will work. And when to use this particular encapsulation. So when the balance variable is private, the changes happen only inside that particular methods if you have seen, and the validation will prevent the misuse. So without encapsulation, there will be no validation and it may lead to illegal state. But with encapsulation, the illegal values will get rejected. And what are the advantages of the encapsulation? It will hide the data. That means internal variables are hidden from direct access, and it will provide controlled access. Only the methods will decide how values can change. And it will provide validation. That means it is preventing the illegal data, and it will provide maintainability. That means changing the logic doesn't affect the calling node. And it also provides flexibility. You can change the data type internally. So these are the advantages of using encapsulation. If the interviewer asks you, is encapsulation is data hiding? Data hiding is a consequence of encapsulation but not the definition. So without getters or setters, can we achieve encapsulation? Yes. If there is no need to access data externally, encapsulation will bind data and methods, but not by force of getters or setter values. And our next important topic is inheritance in the OOPS concept. What is inheritance? In simple terms, inheritance means we will be writing the code once and we are going to reuse it many times. Whenever someone asks inheritance, the first word it will be is reuse. We will be going to reuse the variables from the parent class. So it is a mechanism in Java where one class, that means child class, will acquire the properties and behavior of another class, that is the parent or super class. We will be having a flow chart like, imagine it is a class A and this is class B. This is called as parent class or super class or the base class, and this is called as child class or the subclass or derived class. So whenever the child class is extended, it is going to extend the properties of parent class. So it is inheriting the properties or the behaviors of the parent class. Why inheritance is needed? It will reduce the duplication and it will improve the maintenance. And the benefits of using inheritance is, it will, the first thing as I said, it will provide code reuse, the one thing, and there will be hierarchical classification because it is going through the flow one by one, and it can also increase the levels, and it will support the support the overriding concept, method overriding, and it will provide the cleaner code and improves the extensibility also. And this is the basic syntax of the inheritance. There will be a parent class and there will be a child class, And child class will always inherit properties of parent class using extend keyword. That means child will inherit properties from parent. And what will get inherited? We know that will be the instance variables, non-private methods, and protected members. And what will not get inherited? If something is declared as private variable, it is not getting inherited, or the constructors will not inherit. Overload methods we cannot inherit, and static methods. So this is what you have to answer if someone asks what can be inherited and what cannot be inherited with the in inheritance. And we have three different types of inheritance. Java will support three different types of inheritance, that is single inheritance, multi-level inheritance, and hierarchical inheritance. So in single inheritance, what exactly is happening? There will be one parent and one child, and child is inheriting properties of parent. And in multi-level inheritance, we will be having another grandchild. There will be a parent, son, and grandson. So grandson will inherit properties of both parent and grandparent members. And there will be hierarchical. That means there will be only one parent, but it can have so many childrens. So let's understand these inheritance in detail with examples. So this is how I have given the image here. There will be a class A. This is called as base class, or it is a parent class, or it is a super class. And there is another class which is derived class. It can also be called as child or subclass. So child class will inherit the properties of parent class with the help of extends keyword. So there will be only two classes, that is the single inheritance concept. And if you see this example, so there is a parent class which is nothing but the vehicle, and we have a child class, that is car, and car is extending the properties of parent class vehicle. In this, inside the parent class, we have a method, and this method belongs to this class vehicle. And whenever this particular method is called, it will print the vehicle starts. And there is a child class. This defines a class named car, and it extends the vehicle. That means the car will inherit the properties of vehicle class. And this is a method of car class, that is void accelerate. And when this particular method has been called, it is going to print this statement, that is car accelerate. And we have another uh, class which is test. This is the starting point of the program where the execution will start from here. And here we are creating object for the car. And C is a reference variable. The object will have both vehicle and car features. Because you are creating object for the child class, we know that child will automatically inherit the properties of parent class. So child will be having some properties, and parent class will be having some properties. When child try to access this parent properties, it will add the properties of parent class along with the properties that child is having. And whenever you create object for this child class, it is going to print features of the that particular class and the parent class also. And here, after creating object, I am calling the start method. This method is inherited from the class vehicle. This is the parent class method. And also I have called the accelerate method. This method belongs to the car class, which is child class. So it is going to print both the statements, vehicle start and car accelerate. And the next type of inheritance is Multi-level inheritance. As I said, there will be a parent class or there will be a base class or the super class, and there will be subclass also. That means child class. In between, we have an intermediate class. This is called as, it can also be called as derived class. It is derived class for class A, and it is also a base class for class C. That means it acts as a child for class A and acts as a parent for class C. So that is why it is called as intermediate class. And in this particular case, the class B is going to access all the properties of class A, and class C will have all the properties of class B as well as class A. Let's understand it with an example. So here I have defined a class named animal, and it contains one method which is eat method. So this method is going to print the statement animal eats whenever it has been called. So it represents the eating behavior of all animals. And there is a child class with a class named dog, and it is going to inherit all the properties of the parent class animal. So dog has all the animal methods, like what the methods animal having: eat. So initially dog has a method bark, and now it is going to add the method eat also into this particular class, because you are extending the properties of parent class. And whenever this particular method is called, it is going to print the statement dog barks. And there is one more class which is called as puppy, and it is also having a method inside it which is cry, and it is also going to inherit the properties from dog, what dog have bark, and indirectly it is also going to inherit properties of uh, grandparent class which is eat, because dog is inheriting properties of animals, so automatically even the grandchildren will get the properties of grandparents with the help of intermediate class. And when this particular method has been called, it is going to print the statement puppy cries. And here I am going to create object for the class puppy, and p is the reference variable. P will access methods from all three classes, that is puppy and dog and animal, and it is going to inherit all the methods of all three classes. Whenever the object p dot eat has been called, it will print animal eats, and whenever p dot bark has been called, it will print dog barks, and whenever p dot cry has been called, it will print puppy cries. So this is how the multi-level inheritance will work. And the next type of inheritance is hierarchical inheritance. That means there will be there will be one class, and it can have many children. That means there is one superclass and there are so many subclasses, and it is going to inherit properties of all three subclasses will get the properties of parent class. And let's understand it with example. So here I have declared a class that is parent, and I have defined a method which is property. Whenever this particular method has been called, it is going to print parents property. And here I am having two subclasses, that means two child classes, which is one is son and one is daughter. So a parent is having a son and daughter. They both are extending the properties of parents. That means now here automatically the method property has been inherited to both the subclasses. And now when I am calling the main method, I have created object for son of, I have created a new son object, and I have created new daughter object. Here Without storing it in a variable, I have created object. If you see, till now, before we have been storing variable, we will be using a reference variable to store the object, but here I have created object without storing it in a variable, and it will call the inherited property method directly. At this moment, it is going to print the output as parents property 2 times. So this is how the inheritance will work. And we know that there is also another inheritance which is multi-level, multiple. We have seen multi-level, and there is one more inheritance, that is multiple inheritance. It is allowed in other programming languages, but in Java will not support the multiple inheritance. Why? That means it is going to override the same method, so it will get confused which properties it has to inherit. So instead of multiple inheritance, Java will provide us interfaces where multiple inheritance will use interface to inherit the properties. So technically, multiple inheritance is not allowed in Java. So this is the concept of inheritance. And next important OOPS concept is abstraction. In general meaning, abstraction is nothing but you are hiding some internal concept complexity. So internal complexity will get hidden, and it will show only the necessary details to the user. That is nothing but the abstraction. Only the part which is required, that will be get exposed, and internal hidden details will get covered. So you only interact with what you need. So it is a process of hiding implementation details and exposing only the essential information with the help of methods or interfaces. The user should know what an object does. The user may know what an object is doing, but it's not mandatory to know how it is doing. So internal complexity or internal work is not needed. They can just know what it actually doing. If you take an example like ATM machine, you will be pressing the withdrawal button and you will receive the cash. But you never focus on how the money is getting out, how the internal process is happening, or the database queries you will not see, or the logic you will not see, and you will not see how the cash is dispensing inside. You only interact with the buttons, which are the essential details. You will enter your amount and you will get the cashback, but internal detail is getting hidden. And why do we need abstraction? It will reduce the code complexity, and it will improve the security, and it also isolate the changes. Mainly it helps us to focus on functionality. So there are so many types of abstractions. So types of abstraction implementations. So mainly it happened in two ways. One is the abstract class and the other one is interface. In abstraction level, abstract class is partial, and in interface, abstraction level is full. And the method types is allowed abstract plus normal, here abstract plus default plus static. In abstract class, we will be using instance variable and static variable, but in interface variable, we will be using only public, static, final. And the constructors are allowed in abstract class, and in interfaces constructors are not allowed. And in abstract class, multiple inheritance is not allowed, and but in interface, multiple inheritance is allowed. And the term abstract keyword is used for declaring the abstract class and declaring abstract methods. And there are some rules of abstraction. The abstract class cannot be instantiated. It can contain abstract methods, normal methods, constructors, and variables. But subclass must override the abstract methods and it cannot be final. Abstract method cannot be final because you need to inherit the properties, and it can also have constructor, but it is not called directly. And interfaces will support multiple inheritance. These are some of the rules of abstraction. And before going to code, how the internal memory is working. So whenever you are creating an object with a child using abstraction, for suppose I have created an object to the vehicle, the car, and it is the reference variable in memory. The reference type is abstract class. This is the abstract class, and the object created it is the concrete child class. Only overridden methods can decide the behavior at the runtime. So let's see an example using abstract class. So here I have defined an abstract class with the name bank account, and abstract class cannot be directly instantiated. It can contain abstract methods and regular methods. I have declared the variable which is storing the account balance, and it is shared by all bank accounts because I haven't declared any access modifier here. By default, if you don't define any access modifier, it will become public. And here I have declared an abstract method. There is no implementation here, just subclass must provide the logic for this particular method. And it is a normal method. It adds the given amount to the balance. It is going to add the amount to the balance. And in this particular class, it is a subclass and of the bank account. It will provide implementation of calculate interest method. So here I am going to add the 4% interest to the balance. And in this class, it is another subclass for the bank account because for same account we are creating multiple subclasses. Here again I am going to add 2% interest to the balance. And in the main method, I am creating object for the savings account. So savings account object is created and the reference type is bank account. The deposit method, whenever the deposit method is called, it's add 500 to the account balance. And whenever the calculate interest method has been called, it is adding 4% of interest to the balance. That means it is adding 5,000, 4% to the 5,000 balance. And the remaining balance will be the remaining balance is 5,200. And this is another example of the payment. Here we are using the interface, and here we have created two subclasses for the parent class payment, and we are implementing the till now you have seen the keyword extend. Whenever you are using abstract class or whenever you are going to access the properties, we have been used the extend keyword, but when it comes to interface we will be using the implements. So that is going to access the properties of parent class, and it is whenever this particular methods has been called, they are going to print the output as processing via UPI and processing via bank servers in the main execution code. And here I have created object for the payment class for the Google Pay subclass, and I have called the make payment function, and that is going to print the output as processing via UPI. Now, the final concept of OOPS concept is polymorphism. So in simple words, if you split the terms, poly means many in general English, and morph is nothing but forms. That means polymorphism is we will be having many forms, many type of forms. So that means it will be having same name, but it have different behaviors or different parameters, we can say. In Java, polymorphism will have same method name but different outputs based on the input or object type. It is the ability of a method to take different forms and behave differently depending on the number or types of parameters that you are using or the object type at the runtime through method overriding. So, there are two types of polymorphism. One is compile time polymorphism, and the second one is runtime polymorphism. Compile time polymorphism is also called as early binding, and runtime polymorphism is also called as dynamic binding. And this compile time is method overloading, and runtime polymorphism is method overriding. That means in method loading overloading and method overriding, we will see about them in detail. Before that, overloading is something you are you will be just differentiating the parameters inside the methods, but in overriding you are accessing the same method name with the same amount of parameters. That will become the overriding concept. If you see here in method overloading, there are two methods, but you are inserting different parameters inside the method. But in method overriding, you have same type. If I see in detail, method overloading is a compile time polymorphism in which multiple methods in the same class will share the same name but different in their method signatures. That means the shortcut thing you need to remember, if method overloading means it will be having the same name, that means same class name, but or the same method name, but it will be having the different parameters. It will be having different parameters. The method to be executed is resolved by the compiler during compilation based on the argument list. The key points you need to remember, it has same method name, same class, but different parameters, and return type may also vary, and binding will occur at the compile time. So let's understand it with an example. Here we are writing a code for method overloading. If you see here, we have three methods. This is the first method, this is the second method, and this is the third method. And we have same method name. Method name is same, but the parameters varied. Here I have only one parameter. Here I have two parameters. Here I have three parameters. The parameters can be same, but it should have at least one extra parameter to differentiate between method overloading and method overriding. And what exactly I am performing here? As I said, it has three methods with same name but different parameters. And the first method, it calculates the bill for a given amount. That means here I am going to add 10% tax by default, and it is going to add to the amount. And in the second method, I am going to calculate the bill for a given amount with a custom tax. Including tax, here I am going to calculate the bill, and in third method, I am going to calculate the bill for a given amount with tax and also with discount. Here I am deducting the discount. So including the tax after getting the final amount, from that I am going to give the including the amount, from that I am going to deduct the discount. So it will define the, here I have defined the main method, Here I am creating object for the bill calculator and the reference variable is BC and the calculation will happen. The first method with default tax, it will calculate the amount, and in the second method it will add it is going to add the tax I have added is 8%. 8% tax is added. In the first I have given 10%, and in the third method along with 8% it is going to give 100 discount. So this is how the method overloading will work. And the next type is method overriding. Here we will be having the method name will be same like method overloading. Method name will be same, and also the method parameters will be same. So that is where the overriding will happen. Parameters also same. So here it is a runtime polymorphism mechanism in which a subclass provides a new implementation of method that already exists in its parent class with the same method name and same signature, that means same parameters, and it also has same return type. The method to execute is it is determined at the runtime based on the object referenced. And the key points that you need to remember here, it will occur across inheritance hierarchy, and there will be the method name, parameters and return type must match in method overriding, and it will provide specific behavior in subclasses, and if there is anything that will be resolved in runtime via dynamic dispatch. Let's understand it with an example. So here if you see I have a class vehicle and I have two subclasses, which is class 1 and class 2 with the name bike and car. In the parent class, I have declared method as start with no parameters. Here, even in subclasses, I have used the same method name. That means it overriding is happened here. And how it is going to print the output. Whenever this particular method has been called for the parent class, it is going to print vehicle is started. It represents the generic start behavior of the vehicle. And here I have defined a class bike that inherit the properties of vehicle, and it overrides the start method. And here it is going to print bike kickstarted. It will represent the start behavior of a bike. And even in the second subclass, the class name car, it is extending the properties of vehicle class, and here also it is overriding the method name, and here it is going to print car engine started with key. In the main method I have declared a reference variable v of type vehicle class, and it can point to any object of the vehicle car or its subclasses. And I have created a bike object, I have also created a car object, and when the start method has been called, start method of bike has been called, it will print bike kickstarted. This it is going to print. And here when I have started it, it is going to print the method of car class. This is how method overriding will work. And this is the common differentiation between overloading and overriding. Here overloading will occur at the compile time and overriding will occur at the runtime execution. And here the parameters should be different in overloading and parameters should be same in overriding. In overloading, we can use any access modifier. Even if you don't use, by default, it will be public. And overriding, it cannot weaken the access modifiers. And return type may change in overloading. And in overriding, the return type should be same. It should not change. And overloading does not need any inheritance, but overriding needs the inheritance. And it will happen at early stage, and it binding will happen at the later stage. These are the few differences between overloading and overriding. So these are the four main pillars of the OOPS concept, that is encapsulation, abstraction, inheritance, and polymorphism. And here I have given some practice questions based on the keywords that we have discussed and the OOPS concept, coding examples. And then I have also given few MCQ questions based on these topics. Now the next important topic is arrays. So what exactly is an array? So array is something, it is like a one box where it will be containing many small compartments, and each compartment will store a value, and all compartments have same type of items. So when it comes to array, it will store all these same set of elements. So for example, in Java, array is something, it is a collection of homogeneous elements, that means which will be having same data type, that is stored in the contiguous memory locations and accessed using index that has been starting from 0. uh, it is a collection, that means it have a group of values, and homogeneous, all values have same type of data. That means if an array is storing the integer values, all the elements should be in integer type. If it is storing the string value, all elements should be in string, or if it is double, so the elements should be of same data type. And coming to contiguous memory allocation, so values, if you see here, it has been stored side by side. So values will be stored side by side in RAM. So that is why it is called as contiguous memory allocation, and it has not scattered randomly. And it has been accessed using index starting from 0. So first element index will be 0. For suppose if I have array 10, 20, 30, 40, so it starts from here 0. So index is nothing but the position of the element in the array. So it starts from 0, 1, 2, 3. So if you want to retrieve the index position of 2, you will be calling a of 2, and that will fetch the value 30. So what are the benefits of array? So it will organize related data, easy for looping, it will fastly access the elements randomly, and reduces the variable names, and it provides memory efficiently. Uh, why array? Why arrays are exist? Like before learning arrays, imagine this situation. Suppose you want to store marks of 100 students. Without array, it may require too many variables, and it hard to remember each and every student name, and we cannot loop it easily, and hard to maintain the code also. In this situation, programmers needed a structured way to store multiple related values inside one big container, which is nothing but arrays. This container is known as array. So without array, if you have 100 students, you will be declaring variables for every student, like int m1 marks of every students. So it is very difficult to write up to 100. Instead of this method, there the programmer created the concept of arrays, where it will store elements contiguously. And this is the sample image. So I have 9 elements of in the array. So index, the position will start from 0, and that means the counting of index will start from 0. These are called array indices, and length of the array is 9. First index value is 0, and last index value will be 9. So it will be between 0 to 8. That is 9 elements. And how arrays work in memory. Let's say you have integer array 10, 20, 30. Java will create three blocks together in heap memory and it will assign index value. We know 10 is the index position of 0, 20 is the position of 1 and 30 is the position of 2. And inside the memory, Java will create three separate blocks to store these array values. We know heap will store the values inside the block. So Java will create three separate blocks for these three values. Each value placed next to each other. So each values are placed next to each other. This is called as contiguous memory allocation. That means there is no gap between the elements. This will help the processor access any element instantly. And we already seen how indexing will happen in arrays. So it starts from 0, not 1. You have to remember that indexing in array, it always starts from 0. So an array have 5 values to store. So according to that, we will be providing our index position. It starts from 0 and go up to 4, which will contain total 5 elements. So that is why we are using in loops. If you see, we will be writing like this. So for int I equal to 0, then we will be giving some condition, array of length, and then incrementation. Whenever you will see, it will begin with 0 and ends at the length minus 1 position. And there will be a some common mistake, like whenever you try to access the element outside the array boundary, it will throw an exception. But suppose here I am having 5 elements, that means the array will go from 0 to 4. If you are trying to access the fifth element, that means there is no fifth element, it will throw an exception. Here in our case, it is related to array, so it will throw array out of bound exception. And when it comes to types of arrays, there are mainly two types of arrays. One is one-dimensional array and the second one is multi-dimensional array. So since now, previously we have seen the 1D array, that means it will store the elements continuously in a linear format. So that we have seen the student marks example. In multi-dimensional array, it will store data in a table format. Like you will be having rows and you will be having some columns to store the data. If to this example, you can take employee working hours for 7 days. It will be storing the information of employees and it will be storing the 7-day hours. So that is how the two-dimensional array will work. If you see this particular example, here I have given an example of 1D array where I have declared the uh, elements of marks. This particular line will create an integer array which is named with marks. This is the integer array. The array stores 5 integer values which are 85, 92, 76, 88 and 95. Each value is stored at a specific index. Like how exactly it is going to store? We know that indexing will start from 0. So 0th position is going to hold 85 and the marks of first position is going to hold 92 and so on. It will go up to 0 to 4 and in fourth position we will be having 95. And here I have given a for loop block. This is a for loop. It is used to go through the array. I equal to 0. The loop will start from first index marks dot length. It will give the total number of elements. So in our case we have total 5 elements. So it will give the length of the element and the loop will run from 0 to 4. So loop will run from 0 to 4 and this particular line will print each value of array one by one. So marks of I gets the current element at the index I. So when it starts from 0, it will print 85, then it will print 92. So based on the position, it will print it line by line. And here I have declared a variable total and I have initialized the value 0. This variable will store the sum of all marks. In this block, this is an enhanced for loop. It automatically goes through each value in the marks array. So each value is stored in variable m. Only one value will store at a time. And here in this line, this will add the current mark to the total. What is the current marks obtained? That will get added to the total variable. It is same as total equal to total plus m. And this line will print the final sum of all marks stored in the array. So this is the end of the main method and array class example. So this is how 1D array will work. And when it comes to multidimensional array, it is like a collection of items that has been arranged in a table format. So we have already seen everything is arranged with rows and columns. Just imagine, in your school days, you will be having a school register attendance. It will be having the names horizontally and the dates vertically, just like the 2D array is going to store the values in rows and columns. So a two-dimensional array is a data structure that store elements in a matrix form, that means in rows and columns, and it has been stored in a contiguous memory. Each element can be accessed using two indices. This is the syntax for the two-dimensional array. That means till now we have been accessed elements using, if you want to access the second element, you will be using a of 2. Or if you want to access the first position, we will be using a of 0. So, but when it comes to two-dimensional array, you have to give two indices. That means you have to give the index position of row element and index position of column. So if it is this, it is going to fetch the first element. And if I am going to give this, it is going to fetch the second element in the first row. So second element in first row. So we have to give two indices values to access the elements. Row will identify which row we are fetching the value, and column will identify which value is present inside that particular row. Now here I have given, if you see, the data has been stored in the form of rows and columns, and it has 3 rows and it has 4 columns. These are row indices and these are called as column indices, and each of it is represented by array A of 0. Each row inside a table is 1D array. So each row acts as a 1D array, and when you want to fetch the value of this particular element, you need to give the indices position of row and column. If you want to fetch this particular 30 value, it has been in second row. That means you will be declaring it 1 and in the second position. So based on the position, whether it is in which row or column, we will be fetching the elements. And how it will work internally. Even though we visualize 2D array as a table, in memory, Java will store it row by row. That means we have been declaring the array. We have two rows here, 1, 2, 3, with the numbers 4, 5, 6. So visually, it may look like it will store in the table format. This is how visually it will look. But the memory representation, it will be storing it as row by row only. 1, 2, 3, 4, 5, 6. It is how it is going to store in the memory. The rows are stored one after the other in a contiguous memory allocation. and how it will behave inside the JVM memory. In Java, a 2D array is actually an array of arrays. So within one array, in an array, we will be having so many arrays. That means, as I said, you see here, each particular row is an array. So each particular row is one 1D array. It is a separation of 1D arrays. But representation in memory, how it will look? Inside the memory, it is going to look as a contiguous memory value. So now here I have 4 3 is 12 elements I have. It is going to store the elements continuously. It is going to store row after the row in a contiguous memory allocation. Technically, rows may not be adjacent in memory in JVM heap. And why we use 2D array? Because some real world data naturally fits into two dimensions. For suppose students marks per subject, as we have seen, or in chessboard game, or in seating arrangements, or in matrix multiplications. And when you want to store the RGB pixel values in image, and when you are following the grid pattern algorithm, so in all these situations we need 2D array. If you try storing such elements using 1D array, indexing would be confusing and it will throw the errors. And there are few characteristics of 2D array, or it will store row by row, we know that, and it will memory looks for contiguous logically, and it should have same data type. Every value should be of same data type, and it is a fixed size. It cannot grow dynamically, and we will be accessing indices based on a of I and a of j. Here I will represent the row and j will represent the column. Let's understand it with the help of uh, an example. Here what I am trying to do. So in this, I have created a class with name matrix demo. Here I am declaring a 2D integer array which is named as sales. A 2D array is like a table with rows and columns. The values inside are that now this is stored as 10, 20, 30, 15, 25, 35, 12, 22, 32. So it is a 2D array which has been stored in rows and columns. For suppose, if imagine if I want to access this particular value. This is the row indices and these are the column indices. So it starts from 0, goes to 2. If I want to fetch the first element, we will be fetching. Here I have given a name sales. So I am going to give sales 0 of 0. That will give us 10. So the same way, if you want to fetch the second element, we will give 1, third element 2, and when it comes to next row, we will be starting it with 1, and when it comes to third row, we will be starting it with 2. So this is how we are going to fetch the values. And here I have given total sales. A variable name total sales is created and it is initialized to 0. This variable will store the sum of all sales values. And here a variable name max sale is created. It is initialized with the first element of the array. Here max sale itself I have given the first element. I have marked 10 as the max position. This variable will store the highest sale value. And here I have given a for loop. This particular for loop is the outer for loop. It goes through each row. This will work for row, and this particular for loop will iterate through column. So it goes through each row in the 2D array, and here sales of length is nothing but the number of elements in a row, the number of rows inside a table. In our case here we have 3 rows. And this is the inner for loop. It will go through each column of the current row. And sales I dot length is, it will give the number of columns. So we have three columns. And here in this particular line, it will add the current sales value to the total sales variable. And it keeps accumulating the total of all values. Every time it will be changing. And here I have given a condition. It will check whether the current value is greater than the current maximum sale. If this condition is true, then the current value will become the new maximum sale. So that is how it is going to update the maximum sale value. And finally, it will print the total number of sales and highest value that has finally found in the array. So in our case, 35 is the highest value. And the next concept is multi-threading. So simply multi-threading means it will be doing the multiple tasks at a time. So it will be having multiple tasks and it will execute all those tasks at a time in a single program. Same computer processor performs more than one job simultaneously. So it is a programming technique where a single process creates and manages multiple independent execution sequences, which are nothing but thread. Thread means it is a set of execution that will run only one task at a time, that runs concurrently to maximize CPU utilization and improve the performance. So imagine your phone, it can download a file, it can also play music, it can also show notifications, it can do so many activities. These tasks will run together and threads are going to execute everything in parallel, and each thread will perform one specific task. So based on the core availability, we will be having so many threads inside the processor. And process is nothing but it is going to run a program. Thread is a subtask that is happening inside the program. Concurrent execution, that means the tasks are running parallelly together. And CPU utilization, it will keep the processor busy without idle. So every time it will be running some particular task, it may not stay idle. So every time the processor will be trying to do some or the other task. And when it comes to thread particularly, so as I said, it is the smallest unit of execution of a program. It is going to perform a small task in a program. Meaning thread runs its own instructions and program counter, stack and the local variables. There will be multiple threads. So we will be having multiple threads. They share the same program memory, but they will be having the separate stacks. Thread is also called as lightweight because it will use very fewer resources, and it is also called as execution flow because it is going to perform the task one by one, and it is also called as path of execution. And here is the few differences between the process and thread. Process means it is running the program. Thread means execution path inside this particular process. And process have the separate memory. Thread may share the same memory. And processes is very heavy. Thread is very lightweight because it uses only very few resources, and processes slows the IPC, and thread will share the data very quickly. Processes contains more security. Thread may not contain more security. It may corrupt each other data while running so many tasks. And before this, why multithreading exists? Because CPU will execute millions of instructions per second, but programs often wait for input or output, and it will wait for the keyboard, mouse, network, everything to work. If CPU will sit idle during waiting, performance will get reduced. At this position, multi-threading will avoid waste by switching between the tasks and keeping CPU always busy and executing the background task parallelly. And there is also a concept called thread scheduling. That means CPU will schedule uses the scheduling algorithms to decide which thread should run. So it will decide which particular thread should run which particular task. So there are few algorithms like time slicing algorithm or round robin algorithms, priority based scheduling also. Java uses preemptive scheduling because CPU can interrupt running thread and give time to another thread. And here are the few thread states. A thread may pass through several stages. Initially, it will be new, the object will be created, and when it is runnable, that means it is ready to run or it is waiting for the CPU to perform some task. And when it is running, it will execution will start on the CPU. When thread is in a blocked or waiting stage, that means it has been passed due to the input or output value, or it has given some sleep time, or it has been locked. There will be so many situations. And when thread is in terminated state, that means it has finished the execution. These all are managed internally by JVM and operating system. So thread will share the heap memory, variables and objects. It may have separate program counter, stack and local variables. Because of this shared memory, we need synchronization, otherwise the race conditions may occur. And what are the few advantages of multithreading? It will provide the higher throughput. That means it will perform so many works in less time. And it will keep the CPU busy. That means it will reduces the idle time, and it enables real-time parallel processing, and it performs better for input and output tasks. And there are two ways to create a thread. One is through extending the thread class and another one is through implementing runnable interface. Here it will be inheriting the thread class and it will override the run method, and it will start the thread using the start method. In implementing runnable interface, we will implement using run method, and object has been created passing runnable, and when it has been called, it will call with start method. Runnable is preferred because it will allow multiple inheritance at a time. It allows multiple inheritance at a time and better separation of task and thread. It will separate both task and thread efficiently. So we will prefer the runnable interface mainly. And there will be a life cycle of it. So thread will start with start method. That means it will create a separate call stack and call runs internally. And when we call the run method, it will start execution. And when we call sleep method, that means the thread will pass. We will be giving sleep method maybe for 1000 milliseconds or 10,000 milliseconds. Based on that, it will go for a pass mode. And there is another method called join. It will wait for another thread to come. And there is one more method called yield method. It is like a scheduler to give, it will give chance to another threads also. That means, so how exactly the threads are working? If you take the kitchen scenario, one person will be cutting vegetables and another person will be cooking and one person will be washing dishes. So every task is happening parallelly inside one particular kitchen. So the same way thread will perform execution parallelly inside one program. And let's see this particular example. So here this line will create a class named work thread which is extending the thread. It extends thread, which means This class can run as a separate thread. This can be run as a separate thread, and thread allows multiple tasks to run at the same time. Here I have given the run method. Whatever code is written inside run, it is the task that thread will execute. We know that run method will perform the execution, and here I have given the for loop. That means the loop will run from 1 to 5. Each thread will print values from 1 to 5, and here this thread dot current thread, it will get the current running thread, whichever it is running, that value it will fetch. And what get name method will do, it will get the name of the thread, which thread it is running, like whether it is thread 0 or thread 1. So based on that, the name of that current running thread will get fetched here, and this line will print the thread name followed by the current number of loop. Example, you may output may look like thread 0, it will fetch the first value, and in thread 1 also it may give first value. Thread 2, again in thread 0 it can give second value. In thread 1 it can give second value. This particular order may change. Every time you run this particular order will get changed. It's not fixed that thread 0 will only give 1 or thread 1 will only give 1. The number of times you are going to execute, this particular order will keeps on changing. And next I have created the class named test thread. Here this particular line, here I am creating the object named w1, the first thread object, and here I have created the second thread object with name w2. When I call w1.start, this starts the first thread. Internally, Java will call the run method. A new thread starts running parallel to main method, and here this starts the second thread. Now the both threads will start running at the same time. This is how the threads will perform execution. And the next most important topic is exceptions and file handling. What exactly is an exception? It is like a normal program flows a predictable flow of execution. Statements will execute one after the other, but during runtime, we may get the unexpected situations. These unpredictable, abnormal situations are called as exceptions. That means it is an abnormal runtime event or error condition which will disrupt the normal sequential flow of the program, and it causes the JVM to deviate from the control flow, and it will force the program to terminate unless it is handled properly. Why do exceptions will occur? Because when we are during program execution, the program interacts with both internal and external resources. Internal and external resources, that means it can be user input or files or data, hardware devices, network, and so many memory resources. These resources are unreliable. They may fail anytime. So, runtime errors are unavoidable. And what happens if an exception occurs? Don't we handle it? JVM will detect this particular exception. JVM will detect the exception and it will create an exception object. An exception object has been created by JVM, and that will search. That means JVM will search for the matching handler. Search for matching handler. If that particular handler not found, JVM will terminate the program. And during stack trace, that means error will print. This sudden termination is very difficult in the real systems. And why handle exceptions? Why do we need to handle exceptions? because it makes the program reliable, stable, user friendly, and more predictable. So, to prevent the program from crash, if the particular error is not handled, JVM will start further execution. Handling ensures the program continues execution safely. For example, if you take the situations like banking application or medical equipment or in ticket booking situation, you cannot afford the crashes. You have to handle that particular situation, then you can move forward, and you need to recover from errors. Even after an unexpected situation, we can take corrective action such as we will try to retry to perform that operation and log in error details. And again, if there is any user invalid input, you will ask again user to enter the valid input, and rolling back to the incomplete operations if something is missed out. We'll try to recover all these errors. And why exception? Like it will display the meaningful message. That means initially we will be getting exception in this particular thread. That means like in this particular thread, and it will show the package. For suppose it may show like this. Instead of this, we will be showing the particular operation we will display. For suppose if it is bank application, we will show withdrawal failed, and why it is failed we will give because of insufficient balance. So we will be showing the meaningful messages instead of throwing the errors. And this is an example. So what exactly is happening here? Here I have defined a public class ATM, and I have given a try block and catch block. We will be seeing about try and catch in the next few slides. So it started a try block. The code may cause an exception which is written inside this block. That means here I have created an integer variable balance and I have assigned 3000 to the account balance. And here I have created an integer variable withdrawal amount. This will store the amount 10,000. And I gave a condition if it will check if the withdrawal amount is greater than the balance. Then manually it will create and throw an exception, and it will display the message insufficient balance is attached to the exception, and it will end the if block. And here it will subtract the withdrawal amount from the balance. This line runs only if there is no exception. If there is no exception occurs, this particular line will get run, and here it will print a successful message along with the updated balance. And then the cache block will get start here. This particular block will execute if an exception occurred in the try block. If there is any exception here, then it will search for the respective catch block, and that will print the error message from the exception the transaction has been failed. And finally it will print the message even if the exception occurred or not, it is going to print this particular line ATM still working. So this is how the exceptions will work. And next is file handling. What is file handling? It will refer to a technique of performing data storage, and it will retrieve operations on external file using the Java programs. That means it is a process of performing persistent input and output operations on secondary storage devices such as hard disk files using Java's input output streams and classes to read, write, modify, delete, and manage file contents. Why do we need this file handling? When a Java program ends, variables stored in a memory disappear. This is temporary volatile storage memory, which is RAM. Here the variables will get stored. But sometimes we want data to stay permanently even after the program termination. Even if the program is terminated, we want some variables to stay permanently. In situations like when you want to save the transactions, or when you want to log the files into a document, or user credentials, we want to save it, student records in the data. So these all situations require a permanent storage. So there the Java will provide the file handling concept. And what are the few characteristics of it? It will the persistent data storage, that means the data will remain even if the program terminated, and it will support large amount of data beyond the memory limitation. It enables sharing of information with multiple programs can access the files, and supports sequential and random access, and it will handle different file formats. It can be the text file, binary file, CSV, JSON, or log files. And here, when it comes to Java input output streams, what is mean by stream? It is like a continuous flow of data between the Java program and a file. Between this, there will be a continuous flow. And there are two types of streams, which are input and output stream. Input stream will read data from file, and output stream will write data from program into file. So input stream will read the data from file, and output stream will write data into file. And how the file handling process will work. Whenever a program interacts with a file, there will be few steps that will occur. First thing we will be specifying this file path, and next we will check if the file exists or not, and then we will open the file stream. Then we will perform some read or write operations. Later we will close the stream, and if there are any exceptions, we will handle those exceptions. And why exceptions occur in file handling? Because file handling always risk failure, because external resources are unreliable. Possible reasons could be either the file is not found, or there is no permission to open the particular file, or directory may be missing, or the file already opened by another program, or even in some situations network storage is unavailable. Because of these uncertainty, Java requires exception handling for file operations. And here are the few different types of file operations. One, we will be creating file, or writing or reading data, appending, deleting, and renaming the files. And that means file creation, we are creating new empty file if it is not existed, and writing data. It could be we are storing text, number, or binary values. Reading data, we are retrieving the information from the file. Appending, that means we are adding new content to the existing file. Deleting, we are removing the file permanently. Renaming is we are trying to change the file name again. So these are the few operations that we will perform on file. How the internal working of file handling happens. Java does not directly interact with the storage hardware. It may use operating system, file system, or it uses kernel level disk drivers. Here, first Java will go to JVM. There the operating system will call the disk storage. So file handling depends on the operating system permissions and the availability of the operating system. And why file handling and exception handling always go together? Because file operations are always unpredictable. Even simple read or write can fail unexpectedly. So Java will enforce checked exceptions for file handling. And this is one simple example for file handling. Here I am importing a file writer class. That means this class is used to write data into the file. To write data into file, we will be fetching this particular class. And I have defined a public class name, which is file writer example. And here I have given a try block. It will start a try block. Code that may cause an exception is written inside this block. If there is any exception occurring, that particular code we will write inside the try block. And here I have created a file writer object named writer and opens a file named that is data.txt. In the write mode, I have opened a file which is named as data.txt in the write mode. And writer.write. Here it will writes the given text into the file. This particular text has been added to this file, and then we will be closing. Once it is finished, we will be closing the file. This will release the system resources used by the file, and then it will print a message indicating that file writing was successful. Here I have given the catch block. It will execute if an error occur during file handling. If there is any error occurred, this particular block will handle that. Here it will print the message from the exception, that error handling file. Whatever exception that we will get, that particular exception it will throw. So this is about file handling. And there are types of exceptions in Java. One is, first thing, Java is categorized exceptions into two broad types based on whether when they are checked and enforced by compiler or JVM. We have two different types of exceptions: user defined exception or built-in exceptions. In built-in exceptions, we have again two types. One is checked exception and the second one is unchecked exception. Inside checked exceptions, we have so many categories. It can be class not found exception, interrupted or input output exception, SQL exception. The same way in unchecked exceptions, we have so many exceptions like arithmetic, null pointer, array out of bound. So let's discuss about checked and unchecked exceptions in detail. So in simple terms, what is mean by checked exception? Checked exceptions or the exceptions that the Java compiler will check before running any program. Before running a program, the Java will check whether there are any exceptions. The compiler will check whether there are any exceptions in the program. If such exceptions may occur inside the code, the compiler forces you to handle them using a try catch block, or you can use the throws keyword that we will see later. So you need to handle exceptions using either try catch or the throws keyword. That means checked exceptions occur due to external or environmental factors beyond the programmer control, and thus Java requires mandatory handling at the compile time to ensure the safe execution. Until unless you clear this particular exception, you cannot move further to the execution. And why compile time checking? Because we said that these exceptions depend on the external factors. There will be few uncontrollable situations, like maybe file missing the folder and database server has lost its connectivity, or there will be network unavailable, or user may enter invalid format data in the input stream, or memory card might have been removed while reading the file. These kind of situations cannot be controlled by programming logic. Java will force error handling at compile time to avoid program crashes. And there are few characteristics of checked exceptions. It is enforced by the compiler because to move forward with the safe execution, you have to handle that particular exception. It must be handled either using try catch or throws declaration. It will represent the recoverable conditions. It has not been caused by the programmer logic, but it has been caused by external factors, and it will ensure safe programming. Here are the some common checked exceptions. One is file not found exception, input output exception, SQL exception, class not found exception, and interrupted exception. What is mean by file not found exception? It may be the file path is invalid, or maybe the current file which you are looking for is missing. In that situation, it will throw file not found exception. Input output exception, whenever you are reading or writing the file, there may be an error occurred. In that case, it will throw an input output exception. And SQL exception means it is related to database. In if there is any issue occurred in the database, then it will throw SQL exception. And class not bound exception, it will happen in a situation where JVM is not unable to load the particular class which you have been requested. In that situation, it will throw class is not found. And interrupted exception is thread is interrupted externally. We know that thread may collapse sometimes. So in that case, it will throw there is an interruption occurred while thread is executing. Then it will throw interrupted execution. Why these checked exceptions are exist? Because to force programmer to think ahead and guard against possible failure. Java wants the developer to either recover from the exception or inform the JVM through throws. Using throws, it will inform the JVM that there is an exception and you need to recover from that exception. Let's see with an example. Here I have been imported file reader class. That means it is used to read data into file. Earlier we have seen file writer class. Now we are seeing file reader class. And I have defined a class that is checked example. This is the main method. It will throw exception. It will throws exception. Here the throws exception means the method does not handle the exception itself. Any exception is passed to the JVM, and here I am creating a file reader object with the name file. It will try to open the file data.txt for reading the content. If this particular file does not exist, then it will throw an exception, that is it will throw a checked exception. Whenever the file is not existing, it will throw file not found exception. So this is how the checked example will work, and we'll see another example. Here I am importing java.io. That means it will import all classes from Java IO package, input output package. And here I have also imported SQL. That means it is also importing all classes from SQL package because it is used for database related classes. And I have created a class with the name checked exceptions demo. Here I have defined a static method with the method name connect database. The method declares that it throws an SQL exception. Here it will manually throw a SQL exception with the given message, which is database not reachable. And this is end of the connect database method. This is the main method. Program execution will start here, and it starts the first try block. Here I am attempting to open a file that is record.txt for reading. If this particular file is missed, it will throw file not found exception. And here I have created a buffer reader to read the file efficiently. And this is end of the try block. Then there is a catch block. It will catch the file not found exception. If this try block throws any exception, here it will catch that particular exception, and it will print the message, error message related to the missing file. And then I have given second then I have given this second try block, and it is calling the method that will throw SQL exception. And if there is any exception occurs in the connection database, this particular catch will print the database error message. And I have also given third try block. So basically we have given three try catch blocks. So in the third try block, here it is going to print a message indicating a process is happening. And here I have given thread.sleep. That means it will pass the program for 2000 milliseconds. It will pass program for 2000 milliseconds. In general, it is passing 2 seconds. And it may throw an interrupted exception. And if there is any exception occurs in this particular try block, the catch block will catches that particular exception and print a interruption message. And this is the end of third try catch block. Here this line after all exception handling, it will show the program continues execution normally. And this is end of the main method. This is how the checked exception will occur. And next we also have another type of exception, which is unchecked exception. In simple, it is unchecked exceptions are those exceptions which are checked usually only at runtime. It will check only at runtime but not by the compiler. Compiler will not check the exceptions. It will happen only at the runtime. That means these exceptions are caused primarily due to programming mistakes. Because of the logical mistake by the user, this will throw the exceptions. Because if you see this particular line, runtime exception, these exceptions occur due to violation of the program rule, or you have given a bad logic. Because of not the external environment failures, these particular unchecked exceptions will happen only because of the programming mistakes. And why compiler will ignores them? Why it is not happening because of compiler? Because these exceptions arise due to programmer mistakes that can be avoided by the proper logic checks, not due to external system failure. If the programmer check the logic again, he can rectify because it is not happening because of any external factor or the system failure. If he rectify it, it may recover from that particular exception. So compiler assumes programmer will fix the logic instead of forcing handling. And these are the few key characteristics. It will detect it. These exceptions are detected during runtime. Here the characteristics of unchecked exceptions. So it will detect the exception during runtime, and developer is not forced to use try catch here because this is caused due to programming mistake, and it will prevent through coding it correctly again, and it will happen only because of the internal issues, not the external issues. And these are the some common unchecked exceptions. These exceptions will happen at the runtime. And arithmetic exceptions, because whenever you have declared any value that is dividing by 0, it will throw an arithmetic exception. And null pointer exception, you are trying to access object which is using the null reference. In that case, it will throw the null pointer exception. And there is an array index out of bound exception. This we have already seen in arrays concept. Whenever you are trying to access the element which is not in the range of array index, then it will throw it is out of bound array. And number format exception, this will happen when you are trying to convert a non-numeric to number. That means whenever you are trying to convert any string or something to number format, then it will throw number format exception. And there is another exception which is class cast exception. Here you are trying to give the invalid typecasting. In that case, it will throw the class cast exception. And why Java separated exceptions into two categories? Because the designers aim to encourage safe handling of external resource failures and avoid unnecessary mandatory handling for the logical based exceptions, and that two separated exceptions will provide clean separation of recoverable errors versus programmable mistake errors. We will be having errors which are recoverable and which happened by programmer. So this will come under checked exceptions and this will come under unchecked exceptions. This will improve the reliability and clarity of exception flow. Let's check it with a simple example. Here we are trying to divide a number by 0. This will throw an arithmetic exception because dividing by 0 is not allowed in Java. This will throw an exception. What happens when this particular program runs? The program will compile successfully, but at runtime it will throw arithmetic exception because the program will stop abnormally. The exception is not handled yet. Until unless you handle this particular exception, it is not going to continue the execution. Then here is one more example for unchecked exception. Here again, here also I have declared three try catch blocks. First, here I have started a try block. This will handle the runtime errors. Here, if you see, I am trying to divide it with 0. I have created an integer variable and that is attempting to divide by 0. That will throw an arithmetic exception. This will end this particular try block, and here if we found any exception, and the catch block will catch us that particular arithmetic exception and print the math error. This is the first try catch block. In the second try catch, we are creating an integer array with 3 elements. And it tries, and here what we are doing, we are trying to fetch the fifth element which is not present in the array. In this situation, it will throw array out of bound exception. When the try block contains any exception, the catch is going to print that particular message. That means invalid index, and it will throw array index out of bound exception. And in third try catch block, here I am creating a string referencing to with no object assigned. That means I have given the null value, and it tries to access a method on a null reference. It will throw a null pointer exception. And you are trying to fetch the name of length, but there is no name. It has been set to null. In this situation, it will throw null pointer exception, and the catch block will catch that particular exception and throw the message, print the message. And finally, it will print the program completed safely. This is how the unchecked exceptions will work. So these are the few differences between the checked and unchecked exceptions. And in checked exception, it is checked by the compiler, but in unchecked exceptions, it is not checked by the compiler. And in checked exceptions, you must and should handle the errors because it is happening because of the external failure. And here it is optional. Either you can handle it or not. It will throw the program error. And it will occur at compile time or runtime, but unchecked exceptions may occur only at the runtime. And it is a subclass of exception. It is a subclass of runtime exception. So these are the two categories of exceptions. And the next important block is try catch block. Till now we have seen the try catch blocks in our programs. What exactly is this try catch block and what it will trying to solve? When a program runs, we will be facing some unexpected situations may occur. We have seen some scenarios like dividing by 0, or we will be giving the invalid input, or the file might be missing, network failure, or database issues. In such problems, if these problems are not handled, program may crash immediately. To prevent this particular crashing, Java will provide structured error handling using the try-catch blocks. So, in simple explanation, try means it is attempting the risky action, and catch is something it will handle problem if it occurs. If any problem is occurs, that it will handle. And try is trying to attempt the risky action. So, a try catch block is a Java construct used for exception handling. The try block contains the code that may throw an exception. It will contain the code which will throw an exception during runtime. And catch block will contain the code that will handle that particular exception. Here, the JVM transform controls from try to catch when the exception occurs. If there is no exception occurs, then the catch block will get skipped. There is no use of catch block if there is no exception. And here you need to remember, catch executes only when exception occurs, and try must always be followed by at least one catch or finally method. Only one catch executes for a single exception, and execution will resume after the try catch block. So these are the some situations that we have seen when the try catch problem will solve. When you are trying to divide by 0, or whenever you are giving invalid user input, or if the file is not found, network failure, or database unavailability, in these problems, if these are not handled, program will crash immediately. And what happens internally? When JVM enters the try block, every statement will run sequentially. If any exception occurs, JVM will stop execution inside the try block, and it will create exception object. Then it will search for that particular matching catch block based on the exception type, and it will transfer control to catch block. So JVM will transfer the control from try to catch block. And after catch block completes, execution will resume below try block. If there is any try blocks below that, then it will start resuming execution from there. If there is no matching catch block exists, so then the program will crash immediately. And why Java uses this try catch block? Because to recover from failures instead of stopping execution, and to show friendly messages instead of technical errors, and to allow debugging and maintenance, to keep the application available even if there are any faults. So there are some applications like ATM or banking payments, online shopping. It cannot crash just because one small error happened. You need to handle that particular exception. So this is one of the simple example of try catch block. We have already seen so many try catch blocks. Here I am trying to perform a risky action, because here I already know that it will throw an error. This will start a try block. This is the code that may cause an exception, and that has been written inside my try block. And when I am trying to perform this, it is going to throw me arithmetic exception. This line will not execute because, that means this particular line will not execute because an exception occurs in the previous line. So that will end the try block, and the catch block will start. It will catch that particular exception, and it will print a message. It is error, it cannot be divided by 0. Until unless you change this number to some other number, then it will print the statement inside try, and then it will print program will continue normally. So this is what happens in the try catch block. And there are few, we know that there is throw and throws keyword. And what is mean by throw keyword? Throw keyword is used to manually throw an exception inside the code. If there is any exception inside a code, that will throw the exception manually. Meaning, the programmer will deliberately creates an exception object, and then the programmer will throw that particular exception. It will transfer control to the nearest matching catch block by explicitly throwing an instance of throwable or the subclass during the runtime. It is used inside method body to indicate abnormal condition caused intentionally by the programmer, because this is happened because of the programmer trying to intentionally create an exception. And why we use throw? Because Java will sometimes it cannot detect the logical errors. In some situations, there will be few real world scenarios, situations where throw is needed. If the user age is invalid, or you are trying to withdraw the amount which is greater than the balance, and if you are giving incorrect username or password, or if the file format is not allowed, Java will does not automatically throw exception for these rules. The programmer must do intentionally. And how the throw will work internally? First, the programmer will write the throw new exception type message, and then JVM will stop remaining instructions of that block. Then JVM will create an exception object in the heap memory. Then the program will jump to the matching catch block based on the exception in try block. If that catch block is not found, the program will get crash. Imagine if there is an situation where you are trying to check in the airport. You try to board with expired passport. You are trying to board with expired passport. The security guard will stop you and he will raise a complaint. He throws you out of the queue. That throw is nothing but the security guard telling the system something is wrong. So that is how the throw keyword will work. And here is an example for the throw keyword. Here I have imported the scanner class because it is used to read the user input from the terminal, from the console. And here I have created the bank account. Here I am declaring a private variable balance, and I made it private access modifier, and I have given a method bank account constructed to initialize the account balance when a bank account object is created. This particular line, it will set the initial balance to the initial balance of the account, and here I am defining a method withdraw to deduct money from the account. And here I have given a condition that it will check if the withdrawal amount is 0 or negative. In that case, it will throw an illegal argument exception if the amount is invalid. And I have given another condition. Here it will check if the withdrawal amount is greater than the balance. If so, it will throw an arithmetic exception if there is not enough money. And then I am trying to subtract the valid withdrawal amount from the balance. Then it will print a message showing the remaining balance after the entire withdrawal operation. And here I have created another class throw example, and then I have created a scanner object to read input from the user. This will create a bank account object, that is ACC, with an initial balance of 5,000. It will prompt the user to enter an amount to withdraw. And here it is trying to read the user input, which is a double value. So I have used the sc.nextDouble method. And then here I am calling the withdrawal method of bank account with the entered amount. This may throw an exception if the amount is invalid or it is exceeding the balance, because I have given two conditions. If it is less than the amount or greater than the amount, it will throw the exception. And then I am closing the scanner object to release system resources. So this is how the throw keyword will work. Based on the condition, it will throw the suitable exception. And next one is throws keyword. Throws, it will tell the caller of the method that this method may throw an exception. It will tell this may throw an exception. Like method is like a warning caller. Like it will tell, be ready to handle an exception. I am throwing an exception, be ready to handle that particular exception. That means this particular throws keyword is used in method declaration to indicate exceptions that a method may propagate to its caller without handling them locally. It enables exception propagation instead of handling inside the method. And why we use throws? Because method may contain code that it will perform file input output operations, and it will do some network communication. It will trying to access the database or interacting with the hardware. These operations may fail unexpectedly. Instead of handling exceptions inside the method block, the throws keyword will pass responsibility to the caller. And how it will work internally? So we will be declaring a method signature with the method name and the exception type we are throwing. And method is not going to handle this particular exception. It is calling the caller either try catch block, or it will declare throws again. If the top level caller does not handle it, then the JVM will automatically terminate the program. For example, if you take the situation where you were imagine a junior employer, he cannot handle the customer complaint. So he forwards the issues. So there will be a junior employer. If he is not able to handle the particular customer complaint, then he will forward that particular complaint to his team lead. That is nothing but he is throwing, that means forwarding the responsibility. That is what the try catch will do. It will solve the issue locally. And this is one of the example for uh, throws keyword. And here I am importing three classes, that is one is buffer reader, then file reader, and input output exception. Buffer reader is something we will be importing to read the text. It is to read text efficiently from a file, and we know file reader, we will use it to open a file and read. And input output exception, it will handle the input output exceptions. To handle them, we will be importing the input output exception. And here I have defined a class student file reader, and I have defined a method that is read file that takes a file path as input, and declaring the throws IO input output exception, meaning it does not handle file errors itself. It is not going to handle errors itself, but it will pass that error to caller. Then here I am creating a file reader object to open the given path, and it will wrap that particular file reader in buffer reader to read the file line by line efficiently. String line is something I am declaring a string variable to store each line to read from the file, and then I gave a condition. This will read each line of the file one by one and continues until end of the file. That means until it reaches to null, it is going to read the entire lines in a file line by line. Then I am closing the buffer read to release the system resources, and then I am closing the file reader. Here I have created the main class throws example, and I have created an object student file reader, and I have used a try catch block, and it will start a try block to handle potential exceptions. That means here it is calling the read file method to read the file which is students.txt. And catches will catch any input output exception that occurs while reading this particular file. If it happens, then it is printing the error message if reading the file fails. This is how the throws keyword will work. So here are the few differences between throw and throws keyword. Throw will explicitly throw the exception and throws will declare the possible exceptions. It will tell priorly, be ready that there will be exception occur and you need to handle it. And throw will be used in inside the method body, and throws will declare the method signature. Throws will occur only one at a time. A throw will occur only one at a time, but throws will provide multiple exceptions separated by commas. And the responsibility of throw is it will throw the exception. Throws will hands off responsibility. And here is our final topic, which is finally block. What is finally in Java? The finally block in Java, it is like a special block of code that is associated with exception handling. It works together with both try and optionally catch. Optionally, it may require catch or it may not require the catch block. It exists to ensure that certain important code executes no matter what happens in the try block. Whether the exception completes normally, an exception is thrown, or exception is caught, or even if a written statement is executed inside the try catch block. And why does Java needs a finally block? Because in real systems, like some pieces of code must always be executed regardless of the errors. Examples of such cleaning tasks, releasing the file handlings, closing database connections, or some network sockets, or closing scanner classes, unlocking the multiple threadings, cleaning the temporary session. If these are not released, these situations are not released properly, programmers may leak the memory, or the file may become locked, or data corruption risk will increases. So system performance will degrade completely. Therefore, Java designers added this particular finally to guarantee execution of cleanup code. And when exactly does finally execute? Finally executes in the following situations: normal execution or no exception. Finally will run. If it is normal exception or even there is no exception, the finally will run. Even if an exception occur and it is caught in catch, still the finally will run. And an exception occurs and is not caught, still it will run. Then the exception will continues to propagate. And try block has a written statement, then also the finally will run. And catch block is also having the written statement, even in that situation finally will run. And try block calls the system.exit. In this particular situation, the finally block will not run. This is one of the major, and it is one of the only major exception that we have in finally block. So, except for forced JVM shutdown, that means forcefully we are shutdowning the system, except in these situations where it is killing the process or crashing the system, in all remaining situations, finally block will execute. And why can't we rely on catch for cleanup? We said catch is used optionally because cleanup must be done whether exception occur or not. There may be multiple catch blocks, but code duplication would happen if cleanup was repeated inside each catch. And trying to close resources inside catch means that it won't run when no exception occurs. So therefore, finally, we'll ensure that there is no duplication and it is consistently cleaning up the logic and it is centralizing the exit logic. And how Java is handling the finally internally. The JVM will rewrite the method bytecode during the compilation so that the finally block instructions are inserted before every exit path of a try block. And whenever the execution exits, it may be normally execution may happen or it may happen abnormally. The finally bytecode segment, it will execute before the control moves out. Thus, here the finally is guaranteed by the bytecode design but not by the language syntax alone. And what is the typical usage of finally here? Finally is used for code that must execute no matter what, especially in resource cleanup. Like whenever you are closing a file or whenever you are closing a database connection or a scanner class or you are releasing the lock or shutting down the applications, Java's new try with resources tries to eliminate need to explicit finally, but it will remain foundational concept as it is. And let's understand it with an example. So here I have created a class with finally demo. It is the main method where the execution will start, and I have given a try catch block along with the finally block. And here the code that might cause an exception is written inside the try catch block. But here if you see there is no exception, it is going to execute perfectly because I am not dividing it with 0. It will clearly give the value 5. And so it is dividing by 2 and store result. It is going to store this particular result into the num variable because this operation is safe and does not cause any exception. And this is going to print the result of division inside the try block. And in the catch block, it starts a catch block to handle any exception that cause in the try block. But here we didn't cause any exception. That will print the exception message if an exception occurs. In this case, no exception occurs. So this particular line is skipped. If there is no exceptions, the catch block will get skipped. And in the finally block, the code inside finally, it will always execute. This particular block will always execute whether there is an exception occur or without exception. This is going to execute. That means it will print a message indicating that finally the block is executed. This typically used for cleanup tasks like closing files or releasing the resources. So what is happening in this program? So it will perform a safe division inside the try block. Since there is no exception is occur, catch block is getting skipped and the finally block will execute always showing up a clean message. And this is all about the we have discussed all the important concepts in Java starting from the variables from basic level to all the exceptions that we are going to handle. And why finally matters, especially in file handling. So it is a resource sensitive because it will handle the limited files and only one process may access certain files at a time. If the programmer opens a file and does not close it, the resource may leak may occur and repeated execution can exhaust the OS file handle table and the file logs remain active unintentionally. Therefore, these resources opened inside the try must be reliably closed. Then only the other process will access that particular file. And here is another example. And here I have given star. That means it is going to input all the classes which are necessary for this particular program. And I have given a try block and I am trying to read a file which is test.txt. And here I have given a condition that the characters should not be equal to -1. If it is something throwing an exception, then it is going to the catch block and it will throw the input output exception. If you are not giving any input data to read, then it will throw an exception that input output exception. error occurred. And in the finally block, this is going to execute always. Here I am printing closing file resource, and if the file is not equal to null, then it will close the file. And here again I gave a catch block. If this particular try block throws any exception, the catch block is going to throw that particular exception with a message error closing file input output exception occurred. So this is how the finally block will work. So these are the few practice questions I have given based on the concept of arrays, threads, and try catch blocks, exceptions, and file handling exceptions. And here are few MCQ questions. So till now we have covered all the important concepts from basic level to advanced level. So practice all the practice questions or MCQ questions that I have been created, that I have been provided as a assignment.